center that's free? If so, stand up and compress towards the middle so that people on the edges can have a seat. So there's definitely some seats over here. I see a bunch of seats here. Squeeze next to your neighbors. In the back also, some seats. If you have an empty spot, make room because we're going to fill this room. I'm just the hype guy. And I'm not... No, I'm not the fluffer, Paul. Paul is my fluffer.
He just said so.
Oh, did he?
Yeah,
oh, all right. So keep compressing. There's still some spots over here. Dirk? Is that Dirk? Is there a spot next to you? All right. Grab a seat. And so thank you everyone for coming. I want to give a huge round of applause to the hardest working conference organizers I know. We've got Chris and Toshan. Come on up. What? You have to speak in both of them. One's for the stream, one's for the room. And if you put them close, there might be interference, so separate them a little bit. That's what Hans says.
James is making things really complex. Good morning. Hello. Hello. Who's here for the very first time? Whoa. Who's been here 10 times or so? Well, you could have been here 9 times. This might be the 10th edition, but the first one was a Puppet Camp, and we skipped 2 years. But the 10th time we do this, because we did one in Portland and one in Berlin. So, who's been to the one to Berlin and Portland? Yeah, Tim. Yeah, a bunch of you. So, if you talk about us on any social media, use this. If you want to get online, use this. I'll keep that up so you can actually scan, and it's different from last year. And don't ask me why it's 2023. I don't know. I didn't put it there. It's also in the lobby. There's signs on the pole, so you can just go there. And we'll make sure they're in the rooms also. So this slide is familiar. There's people sitting on the stairs. There's people standing here. There's probably still people outside. We have this fake limit of people, but we don't want to end up being FOSDEM where there's 200 people queuing for a room of 30 people.
Yeah, so people on the stairs, please, or get on a seat, or go to the overflow room. We don't upset the the venue, and we have strict rules now, so we need to abide by them. So please, don't sit on the stairs, find a chair, or go to the overflow room. It is working, audio. And
so the FOSDEM compression algorithm, which means if there's an empty seat next to you, squeeze to the middle. There's 4 seats up front here. There's still seats in the back there. So just do that. So what is this conference about? The people in the picture, I don't know about the person who's sitting right in the middle, but the others, they're almost here. The MGMT contributor who was tweeting isn't here. The Vox Populi contributor is still here. Yeah, the person ruining the picture with the DevOps Days hoodie, he's also hiding here somewhere. We have some news about that, but that's for later. So keep talking to each other, keep learning from other communities. There's new communities popping up, there's communities that decide to go to the dark side, but that's not our problem. We have a pretty packed schedule. There's a lot of rooms in the afternoon where you can go and learn new topics. So just go into a random room if you don't know what talk you want to see and learn from the others. Food. I guess you already had coffee or tea. Lunch is on your own. The restaurant is going to be open. Today's menu is carrot soup or Flemish stew and vol au vent, and there's a meat or a veggie lasagna, and you basically can get the whole menu for just short of 10 euros, whatever. We got about an hour lunch, but they start serving lunch at 12:30, but you want to be here for the Ignites anyhow, so don't run. For those who are staying till Wednesday, or are still not decided if they want to stay till Wednesday, we also have a pretty packed program then with an Assemble Collab event. We have Puppet Community Day. We have a Cilium workshop, if I haven't seen Raphael yet, but it's going to happen. We've got some hands-on building stuff, like foreman stuff and other things and other workshops. And yeah, even Wednesday is going to be packed. What are we going to do today? Today we're going to start with Patrick, who's going to talk about his journey into doing totally new stuff. Then Keith is going to teach us how to make spaghetti, and I hope Alessandro doesn't get pissed then, because Italians and spaghetti might be. Adam is going to tell us about all the new fancy tools he bumped into. And then we're going to have Ignites. And then in the afternoon it's going to be all over the campus for the rest of the day. We got word from Oleg that he probably won't make it. He wasn't sure yet, but that's at this point the only cancellation we know of. He might still show. As soon as we have final updates on that, we'll share them with you. Yesterday we were teasing that we might have something new. We still need to get it confirmed, but we might have a talk on Pickle tomorrow. As soon as we get final confirmation, that's gonna be public too. But we're gonna start with Cote, then we're gonna talk about Winlang, and so tomorrow is gonna be how to deal with code and code reviews and all of those things. Obviously, the thing why you are coming here is for the free beer for tonight. It's in the same place as always. It's right across the street. What? And I'm gonna give the mic to Tasha now, because he's gonna explain how that works.
So yeah, the free beer event is tonight, same place. So you go out from this block and then walk towards that direction, cross the road. Be careful when you cross the road. And then you're at the zone. So you can be in the zone. You need to get wristbands to get free beer. Well, free drinks, whatever you prefer to drink. The micro isn't doing it? Okay, now? Okay. So the wristbands will be handed out at the sponsor booths. So please go and visit the sponsors, which I will go over in a minute. They also have free lunch vouchers. So go visit them, please. They make it possible for you to get free coffee, free beer, and other stuff. So the sponsors, we have Ansible as Titanium sponsor. They have a big booth. I presume everyone has heard who they are. So we have Puppet. Again, I presume everyone knows who they are. We have Isinga, which is a monitoring tool. AT Computing, which does consulting, and Freelance, which does cloud stuff. You have Red Hat, so those people who wear red hats, that's all they do. But they also have like an enterprise Linux, or they used to have one. We have Rudder, which is a very nice tool. We have Open Future here. They're a local consulting company. We have Beta Dots from Germany also sponsoring, and Kangaroot, also a local consultancy company. And then we have ATIX, a German consultancy company, and the Skill Factory from the UK, the country that left the EU, remember? And then we have obviously HOGENT, our event, our location venue, to thank them. They give us this venue every year, and we are allowed to return. Let's keep it that way, please. So, and that's thanks to back there. So if you see him, thank him. And then you have Inuits, which is part of Chris's company, and Vantosh, which is my company. And then we have CityTV, so that's Han there in the middle of the room, doing the video. Yeah. And then we have SIG.io, who does the overflow one. We have PAC this year, who is doing some book things. So please don't go for lunch if you would like a book, because we will do the raffle after the Ignites. And then we have Compass, who is subsidizing and helping out with the catering. So all the catering we don't do anymore ourselves, gives us more time to do organizational stuff. And they give a lunch at a subsidized price. If you are a speaker, an organizer, find me or Chris and you get a free voucher for lunch, a little paper just. And that's about it. Thank you and enjoy.
We're going to give the mic to Patrick. Do we need to introduce him? Yes.
There's no time.
Oh, he says there's no time.
Eentjes genoeg?
Twee.
So het is spaghetti.
Als je deze ook nog om zou kunnen doen. Dat is voor de video.
Kun je hem oppikken?
Ja. Ja.
All right. Wow, what a collaborative intelligence. So you know you got asked like, oh, can you submit a talk? And then you're like, okay, what am I going to talk about? You make up a fancy title, and then it's 2 days before the event. You're like, why the hell was I thinking? So bear with me. There's something about collaborative intelligence because I'm going to talk about AI and people and how that works. But yeah. But I think it's important. I could give a great keynote on the future, which I don't know and never known. But I feel what's really useful, at least how I learn, is when I look at the new technology, I'm trying to understand how it works. So instead of going off into a philosophical thing, will man be replaced by machines and automations and all that stuff? We've heard that before when the new, kind of a while ago, all the automation scripts, automate yourself away from a shell script, right? So I'm not going to talk about that. I'm just going to try to make you understand how it works, and then you can make up your own mind. Whatever. So I'm going to show some code, and I hope you can read it at the back. If not, shout. There's a repo that contains the code. It's basically a set of samples of lessons I create for people with a DevSecOps background to understand how this new AI, Gen AI thing works. I'm gonna not use the APIs directly. I'm gonna use a framework. There's plenty of them. These are a few of them, depending on your preference. I'm going to use LangChain as the framework in the examples. Right, so I'm now going to switch over to code. Can you read this in the back? All right, mission accomplished. So, LangChain. Ecosystem typically came from data science, Gen AI makes sense. There's a lot of Python. Now these days it's going to evolve, but I assume one way or another as a system administrator, maybe you played around with Python, but the examples are not like the hardest code to understand, and I'm not the best coder either, so I like simplicity in there. So we'll just install LangChain. LangChain, and for the examples, I'm going to use OpenAI. You can use any of the models or service or cloud providers. It is just to keep it simple for people to try out at home as well. All right, we got the first installation going. Of course, I'm not going to show you my keys and load it into an environment variable, blah, 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 blah. All right. Okay, first example. Is it zoomed in enough or should I zoom in more? Okay, good, all right. So you're familiar with ChatGPT, so I'm just going to ask the simple question. I'm going to load the library, OpenAI, and I'm going to ask it, where is Ghent? And of course, it answers me pretty simple. Ghent is located in Flemish region. All good, pretty easy. Now, let's ask this 6 times. And as you notice, it gives different answers, right? And it's the first thing you would not expect. Think of it as a large language model like GPT, like your bash completion. It's just trying to predict what is next, but instead of having its dictionary, it uses the internet. Of course, some things are going to give a different answer. So one important concept of this is that you want to make it predictable. Sometimes you want it to be more creative if you're making things up. Sometimes you want to make it predictable. And to make these calls predictable, we use something called a parameter called temperature. And the temperature 0 means it is very predictable and should always give the same kind of result. And as you see now, when I set the temperature to 0 is always going to give the same result, right? So we learn a model, we're just going to call it, and we set the temperature. And then some of the models give results back, right? I'm not able to show this. Some will show you only immediately the complete result, and others are able to stream the result. So you see sometimes that it's being generated. That is because it works that way, right? It's not instantly has the answer. Think of it as constantly adapting what is the next character it should go. So in our case, we can pull off a parameter, streaming is true, and then it is just being streamed. The text that I send over to the LLM is what you would typically type in ChatGPT. But there is a limit of what you can type in that buffer. And sometimes that is called it's called the context size. So think of it as I'm providing the model, the LLM with the context, and it has a certain size. There's going to be smaller ones. There's going to be buffers up until 100K, but you have to know how big your model is responding to. So in this case, it has a context size of 4096. And it has a maximum tokens, and tokens, think of it as parts of words that it uses to generate the next part in there. Everybody good? Right. So you wrote the first thing, where is Ghent? And sometimes you want to see what goes under the hood. That's the important part. We all know frameworks, they like to abstract things away, but I like to learn these things. So I enable debug and see how it goes. So this is a simple output of something that goes over the wire. Notice that it's like just text. There's nothing else going on. It is text with an answer. I got like a lot more information. I can enable more debug flags, but you will see me in these examples. I have a callback handler, which is hooks into the internals of LangChain and reports when an LLM is doing something, is being generated. So you see, oh, a new token, where is Ghent, is being generated, and then it is the end, right? This is just that you understand that is a way of debugging things and to see what goes over the wire. Up until now, I've used just one request. But you know, typically you do request, answer. You're in a chat mode. So for that, we select a chat model. They're different than the other models, which are more like instruct models. They kind of give you question, answer. Chat kind of enables you to have that conversation. So what's useful to know there? If I'm sending just a question to ChatGPT, sometimes I want to kind of provide a bit of initial context. So in this case, I'm telling it, you're a helpful system that translates English to French. Right? So that is called a system prompt. And then I send it my question, typically a human message. I love programming. And then lo and behold, j'adore la programmation. Parfait. Right. So you can use this in your Copilot. Imagine you're an expert developer in blah. It will set the tone, you get a different answer. If you don't know this, so it's kind of like, it's not doing anything magical, it's still text, but text, right? So the word context is pretty important. So this is the difference between kind of one kind of question and a chat going on. And of course, I can build on more of those messages. Right. This time, we're going to have it generate jokes. Instead of having just text going in, very similar to templating, we want to have a template that we can set parameters and send it over. So in this case, my prompt template is, tell me, adjective, joke about content, and I can pass along funny and chickens, and it tell me a funny joke about chickens. So it generates the prompt based on a template and with some kind of parameters. And then obviously, why did the chickens go to the champs? To talk to the other side of the road, and like the Sean said, we have to be careful when we cross the road. So this kind of allows you to think about a template that you're reusing over and over again, and you just have it parameterized. Also, think about this, how this will work with kind of injection of things, but we'll get there too later. So, very simple thing, I can kind of have a conversation that goes in templating. So notice I'm doing a lot of boilerplate, but kind of gets you in the set of different models, a template, sending things over, and that is everything you could do typically in a ChatGPT. So ChatGPT only knows what is in the model. And one of the things you want to do is you want to bring in your own knowledge. Something the internet doesn't know, something that was done later after the model was built. So in this case, what I will do is I'm just going to load a simple Markdown file. And what's in there, it is just a history lesson about DevOps, blah, 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 what happened there. Okay. Instead of loading it as a text, I can obviously use a better parser, and I can use a markdown loader. And I can use a whole bunch of files and read them in. And I can even load a website or anything, any data source you're getting, right? So there's loaders in those frameworks to get it from your SQL database to your Datadog logs to wherever. You're just going to pull in data that you wanted that the internet doesn't know. And then you can use that in your prompts to kind of answer questions. Now, what we really want to do is we want to create a prompt that says, given this information, given this question, answer me this. It is just text. There's nothing special about this. But the thing is, how do we get it to say, like, this information? So what do you do if you're looking for information on the internet? You do a search, you do a query, you look at a database, with your wiki, or wherever. So we're doing something similar. We're just going to do a search. The problem is, not a problem, you can use any traditional search mechanism like a database or your kind of typical keyword indexer. But there's a new kid on the block, which is semantic search. And semantic search doesn't use keywords, but it looks for semantic similar meanings. So even the words are not similar. In a way, kind of any of the config management tools, they're related, but they will not match if I search for one of them on a keyword, but they will match on semantic meaning as being related to being a config management tool. So next to having your data, you want to have it indexed using an embedding. And an embedding, it's a mathematical model, but you don't really need to know how it exactly works. Think of it as an indexer that calculates a vector, and if there's a piece of information here, there's a piece of information there, if the two are related, the vector will be very closely related. So if we can calculate the vector difference, and if it's close, then we know the documents are related. So if I have a question, and if I look up what is related to that question in my database, in my documents, and all of my stuff, I will find the pieces that I will put in my prompt. So that's kind of how it works. A vector is just a bunch of numbers, but there's now a service much like a search indexer, which is a vector store you will hear about. This is where you store all the documents with the index. So I can query it like a database, a search, a semantic indexer, which is a vector store. But when I put those documents in, if I have a very long document, what is the meaning? If one paragraph is about one piece, another one is about another piece of information, if I do the meaning of the whole document, it will be different than when I split that off in multiple parts. So when I have my markdown file, I'm just going to split it. You can split it naively by saying every 100 characters is a piece of information, but I can do it more intelligently by saying I'm going to split it by header. So I have paragraphs I'm going to index on those parts. And that gives you a better relationship of those pieces. I know it's a little bit abstract, but we're getting there. Hang on. So I got the documents. I'm kind of chunking them and splitting them up into the pieces I need. I've indexed those pieces into my vector store. And now I can do a search for this. So in this case, I'm using ChromaDB, where I am kind of, first, I'm going to index all the documents that I read, and I'm going to store them in my vector store. Now, I can find the related documents based on the query I use. So this is not necessarily needed, But if you're dealing with unstructured text, like PDFs, or Word documents, or wikis, this gives a lot better results than your keyword search. So that's why we're doing this. So now, how do we make use of that? We connect to the existing database that we populated with all our information. And we're using a retrieval thing. So we're, I will show you what it does. Who were the people involved in writing the DevOps handbook, right? Return the results as a JSON and using the first field and last name. I'm first going to do the query based on the internet information, like we did in the very simple query. And it's telling us there's 4 people that have written that book. Now, we're going to augment that information with our own markdown file, with our own information, and then ask that question again. So when we ask it, and I'll have to open this, it adds another author, John Alspaugh. And that is because we've put that own information in our prompt when we did the query to the database. So this is how, when you see the new AI about documentation or indexing or search, this is how it works, right? So we fetch the data, we cut it up, we put it in an index, and then when somebody asks a question, we look up the related information, we put it in the prompt, and then we do the query. There's no rocket science here, there's nothing special over the wire. It's sending text, nothing more than text. But we can get fancy with that mechanism and say, I have open API docs somewhere. So I'm going to use it to say, split up the documentation of the Open API spec, index it. When I do a query, look up the pieces that you need in that documentation, and then try to figure out what the query is. And in this case, it uses the Open API spec from a Meteo weather service. And as you see, you are given the below API information. Here's the information that we got from the API documentation. And use this to answer the question. And you can see that it's kind of constructed the URL that it's supposed to use to do that query. So you see, we've enhanced whatever was on the internet with our own information, this time not with our wiki, but with our API spec, and it just was able to do a call on the internet. Personally, I found that pretty cool, right? And that is also, you know, a good cause of writing documentation. Now it's actually being used by somebody. All right. So what if we go further and we say, not instead of just kind of enhancing our calls with what we find in our own information or what was indexed in the model, what if we just allow it to call out to the internet? It's a different source of information that is being able to find. So in this case, I'm using DuckDuckGo service. I'm using this to query, and it, you know, when I query it, it will just give me a result. But I can start building an agent with a set of tools. And in this case, I'm providing it a tool and say, here's a searcher, and use this for when you need answered questions. Note that I did not programming or instruct the model more than just a description of how to use it. So how would this look like under the hood? I'm just going to skip that part. So on the text level, you see this is the prompt that goes over the wire. Answer the following question as best as you can. You have access to the following tools. There is a tool called DuckDuckGo Search with the description of the tool, and it explains how the format goes on, and then begin with your question. So I've now blended a model with a set of tools. It figured out how to kind of put them all together into a prompt and just send that text over the wire and give me a result. And then it goes on, are you sure you need a tool, or are you not sure you need a tool? So it's having that whole chat conversation, and then eventually it finishes with saying the weather in London is like that. So this is something that is with just a model doesn't work. Just providing it with information on your own doesn't work. But now I provided it with a tool that is using when it kind of expect that it needs it. This is also how you solve a model that you ask, like, what is 4 plus 4? A model would just guess on a probability. Maybe it found the answer somewhere and kind of had it right, or it gets it wrong. But if I get a model, a set of tools like a calculator, it can see like, oh, to add numbers, here's a tool that's very good at adding numbers. And it sends that over the wire, and then that triggers your code of the calculation. Stepping up our game, what if we just have a bunch of those agents that work together? One is, in this case, a senior analyst. One is a tech content strategist. And another one knows a lot about AI advancements. And you give it a task to find like a full analytic report. So each of them goes on to the internet and says like, okay, I'm going to do a search on AI 2024. Then they come back, this is the information. Then they have another one chatting with it, like, what do you think? Was it a good idea? Was it not a good idea? And it keeps it in a loop. So this is how you would maybe construct something like, no, here's an incident. What should we do about incident? Oh, there's an expert in incident recovery. There's a cloud expert. There's an expert at giving pizzas away or something, right? And they all kind of work together during your incident and make that. So this is the style of automation that we're looking at beyond the simple prompts. And to close off kind of like the leading up to the next thing is, this was just text. The new models are able to do vision, right? So I can feed it an image of a hot dog, right? And then when I ask it what's in the image, it's going to tell me a hot dog with ketchup and mustard, right? But imagine I have a screenshot. What are all the areas that I can click on in this screenshot and list them in a table together, with the name, description, and their coordinates? So then I have an agent that has a tool that can reason about what it sees on my desktop and is able to click on stuff. In this case, I took the home page and it just kind of got all the links where it could click. It didn't even look at the HTML. And then I noticed also that social is spelled with 2 O's, which I would have never have noticed. But this is a way, kind of like think about how your desktop is also being monitored and not anything that goes on there. So I hope that gives you a little bit from the basic to the power, and I know this is a very fast one, but it's also not like complex code. It's not that I had to code like for hours and hours to do that, to get it working. All right, let's see. So I'll switch back to my slides. And one of the things you notice is that, oh, how do we solve this problem here? Oh, let's use more AI, let's add more data, let's add more tools. And it's kind of like this spiraling of you feeding the machine to make sure it does what it's supposed to do. So when is enough? Some people think, it will just work. Others, they think, oh, we'll never get there. It will never be correct. But it is something that we're just going to keep going. And like I mentioned, it's not because I think it's not going to happen that not somebody else will come up with the idea or try. There's tools that will start monitoring your desktop. They record every screen capture of anything you clicked on. You, your teammate, the whole company also has data collecting your knowledge. And then by putting your images to text, you can remember things nobody knew or the guy that left kind of only knew and bring that in. Of course, there's a new set of privacy problems, so we use more AI to scrub anything that should not be recorded on our screens. The big side. And there's this drive about building the tools that build the tools, and we all know where kind of that ends, like because premature optimization is evil. But there's some truth to this that we're trying to get better at certain tools. And finding the information that you have on your wiki that you will not be able to find or assist you in your daily job, that's huge wins. And I would say that kind of pattern of augmenting your data, retrieval augmented generation, is the pattern of 2023. All companies that you will see have been started on that journey. The code execution part and the vision part, everybody's continuing to explore that in 2024. So that's where we're at. Obviously, you're a system administrator, so how does it help me? Well, you could copy and paste things in ChatGPT, get your code, and have it help you and assist you find your information. But what about you as a vendor? Why are you not supplying an index to all your information that is readily queryable, that's consumable by these tools, and that people can just index or have their AI tools use? What was that? I don't know. That was AI. Right? Okay, so Open Interpreter is kind of, we give it a tool and just say, here's a Linux box, try to solve the problem. I don't care how it works, just figure it out. So here's a little capture of me yesterday evening. Install FFmpeg using Ansible. And anything that is suggested by the LLM in Markdown, it just starts executing this. Okay, it took me probably 6 tries to make something usable. The first one, it was stuck at sudo. What do I mean sudo? The next one was, it couldn't figure out what to do writing a config file because it always had the bash quotes missing. So I already gave it a few instructions. I said, well, don't use sudo, your root, which is the system prompt. And then I said to it, use Python to generate your config because then you don't have a problem with your quotes. It still got it wrong because then it started installing, after a while, FFmpeg directly because it basically gave up on Ansible there. But this one finally worked. It installed it. I was able to get it. So is it working? This one was still just using the internet knowledge. Imagine we just augment this with our own set of tools. It's able to verify whatever goes on the machine. We enhance it with the documentation about that it needs to be done. We enhance it with our own notes, kind of notes.txt that we all keep or whatever. And that could give a better result. But it just gets you into the ID. I had another example about while I was doing this all manually with the assistant, and then I wrote it like ACID afterwards, like whatever I did right now, can you write me a Puppet manifest? And it did, right? So we're also teaching it in a way that it can help us do the manual exploration work. Would I trust it right now? Hell no. Right? So you see the evolution is going. We don't know where we're ending up, but it's definitely an interesting journey. So this was my short summary, and I have a lot more in depth, and you can look at the repo. This is like how GenAI can start helping DevOps, and note that I didn't put the Copilot thing and ask for snippets because that's so 2022. But there's a flip side to it, like, okay, building all this new AI, GenAI stuff, the unpredictable nature, the chaos, the tools, the security, something we're very good at, right? So we can, whatever you're building in your company or other people are building, we can bring a ton of value to come in. And I'm predicting that this is coming to your platform team. I know the term is loaded with a lot of things, but in my head, there is part of the platform team is cloud. Then it's a layer higher, which is the application platform. And then there's also going to be a data platform and an AI platform. And they're all kind of about governance and shared components that you want to roll out to the rest of your organization. So I would advise you to start paying attention, understand the basics, and also understand what's coming at you. First thing is developer experience, prototyping. So how do I do this in my org? How do I get access to my data? It's something you can help each of the teams with, and probably need some standardization there as well. Some term you will hear, it's not just about the prompt, but you say it's like a flow. First something A, then B, and a query. So look at like other ways of dealing with this, visualizing that stuff. And then there's debugging, because I do one prompt, a call, another call, another call. And so I want to have this debugging way of seeing like what went over the wire. Much as we've shown, it's like the traceability. We know for applications and API calls, we need something similar for this kind of prompting and calling. You want to have some local models, like you have a local development stack, knock yourself out. It works on a laptop. Obviously, you don't get the same quality, but it is good to do a lot of coding. The models that are being created, probably you want to have a registry, or you want to use one of the open model registries. It's like who gets access to what is vetted. Think of it as a container, you pull it in, you pull it out. This is similar, like there's going to be some governance happening there as well. The prompts, one team reusing the prompt from another team, business logic specifics. There's public prompts registry, likely you'll have a prompt registry also in your company that people are, think of it as your Git repository, your prompt repository, your model registry. So they're all going to be similarly. And that pattern that I shown you of bringing in your own data, it's also going to be a service. RAG as a service, right? This is Amazon Q. They have all those connectors, all that chunking. It's just going to be a service. I've just shown you to make it you understand how it goes a little bit under the hood. But that is just something teams will start using as a service. And you better understand how the implications are for security, getting data in there as well. Agents as a service, even though it's far away, the vendors are providing the tools. And maybe there's simple case, so even though the technology is not that mature, maybe for smaller things, it can already help. And then how to unify it, like, oh, should I go with Azure? Should I go with kind of the bedrock from AWS, the Google, run my own? So what people are looking for is a unified interface, much like S3. In this case, it might be that we're all ending up being the OpenAI API, but it's like a front that we expose all this information to, like an abstraction, so we don't have to reinvent the wheel of adapting when there's a new model coming around. And then guardrails as a service, I often refer to this as the web application firewall But for what goes in and out of the prompt, so guardrails as a service it exists on every of the cloud vendors where you can say, oh, this is the quality, is it sexual loaded, is it self-harm, it could be PII. So typically you could have central rules, you can have team rules, you can have application rules, but that's something that will likely be coming as a service as well. Observability is how do we deal with any of those changes in prod? That traceability that I've shown you, instead of just doing a health check on an API, is it ready? Is it working? Yes, no. You send it a set of prompts with an expected result and see if that's still within acceptable limits. So that's kind of the monitoring observability that you do. And then obviously this is important because in your test cases, you cannot predict all the things people are putting in there. So you need feedback as a service to feedback more test data, to feedback more information to the people building the prompts and building the applications. All the services that I've mentioned, most of the companies I've known have cobbled this together DIY kind of last year, but you know, many things here are instant legacy, and you'll have to migrate to one of the vendors there as well. So this has been kind of a short talk. I hope it was a good balance between thinking ahead and a little bit of the code. Understand it's not something 9 a.m. in the morning, although it was already 9:30. So if you need some help, you have some ideas, you're passionate about this stuff, I certainly am. Contact me. And finally, I want to say this is an integration game, right? I have not had to do any weird math or have a major in that. I could just make things work. We are so used to dealing with uncertainty in production. We have so much experience to making things bend to what we want. So this is something you are very good at, and I encourage you to kind of explore the technology and get closer to your teams and learn from them, but also help them with all your knowledge. Thank you very much. Thank you. Nee, doe gaan maar.
You have the mic, so either you give it to me or... A short 20-minute break before we start discussing Italian dishes. But maybe there's some news we have to tell. Are we taking a break now, or there's a break now? There's a break. Okay. Or maybe we'll. Battery is empty. So the battery is empty. Let's have a break.
Uh,
intro code, and he has a book he's working on, which I'm not sure if you're going to talk about much.
I'll mention it.
A little intro. Han, when you're ready.
Yeah.
Good?
Yeah, she doesn't actually have it.
He's going to give us a talk by himself. Thank you very much. A round of applause, please.
Oh, can I have the mic? Thank you. All right. Thanks, everyone. So yeah, I'm going to talk about taming spaghetti infrastructure. So on the book, I'm working on the 3rd edition of the book right now. And so the talk is some of the kind of ideas and things that are going into there, some of what I'm thinking about that's going into this edition. Early thoughts, so feedback is really appreciated. I'm also very conscious that we're going to be hearing in a minute, or after me, we're going to be hearing from Adam about what he and his team are doing to make the stuff in my book obsolete. But I think there's different layers of abstraction or what have you with this stuff. And the stuff that I'm talking about, I think, is really around kind of how we design and put together infrastructure as it kind of grows, and we have lots of people working on it. And I think the improvements that we're in the midst of seeing and that we should be seeing over the next number of years are around kind of taking away some of those lower level annoyances and things, and so that we can focus on the higher level stuff. But one of the things that I've kind of realized as I look back on how stuff has evolved over the past really, is that a lot of the challenges that we face are kind of still there, and it's in terms of how do we think about how to design, and put this stuff together. So I suspect in some form or another, a lot of this stuff will still be relevant. Hopefully we can focus more of our attention on the kind of really, the meaty stuff rather than details. So one thing that I often get faced with as I work with clients, I should have mentioned also that I work with ThoughtWorks, which is a consultancy. So I spend a lot of time working with different clients, especially kind of larger, banks and media companies and so on. And that's where it gets really messy, right? Which is where it gets fun. But some of the things that I often hear from, especially if you're talking to kind of more senior leadership and all that, is like infrastructure seems just like it's kind of like just like plumbing or whatever. And when I say we need to think about our strategy for how we kind of architect the infrastructure to make sure that it can really support the organization's goals, whatever we're trying to do. Sometimes I get told, well, that's a solid problem, right? We've signed a deal with AWS or whoever, and that's job done. And it's like, well, not really. So I'm sure most of you are familiar with Corey Quinn's stuff, and he wrote that piece a little while back on 17 ways. There's 17 different ways to run a container on AWS. Followed up with another one and another one. And some of them are pretty obscure, like weird edge cases of okay, there's a container in there and all that. But I mean, the point is, like as a platform, like the clouds to me are not really a platform. They are kind of just like a collection of stuff that you can assemble and use in various ways, right? And then when you kind of combine, with all the kind of the cloud native computing foundation, that whole list of all the kind of tools and things like that. We need to, obviously we need to do a bit more than just say, here you go, right? Have at it. So I would say that cloud is the start of our strategy for infrastructure, right? And so the most recent State of the DevOps report that came out had a little piece on cloud. We had an interesting thing where they were talking about how it doesn't automatically produce benefits, adopting the cloud, right? And in fact, they've seen that oftentimes organizations, as they move to the cloud, become less effective in those ways that they measure, the measures of effectiveness that they have. Unless they make use of flexible infrastructure. Unfortunately, the report doesn't really go into much details of what does flexible infrastructure mean, right? So I kind of like take the opportunity to say, it's the stuff that I think you ought to be doing, right? If you do stuff the way that I think you ought to do it, then that's flexible, and hopefully it does help you to be more effective, right? So one of the things that I'm expanding on in the 3rd edition of the book is around environments, because I realize it's one of these things it's one of those terms that like we talk about and we think we're talking about the same thing, but maybe we have kind of different definitions and so on. And so it's useful, I think, to kind of hone in on it a little bit and think about how we define it and how we kind of design environments, right? And so one basic way of defining it is just to think about it as it's where you have like multiple workloads that are related, right? That are somehow having to integrate together. and probably share some elements of the infrastructure, right? And so obviously defining the environment as code is kind of what we do with our infrastructure as code, right? So the challenges we get is when we start scaling it. By scaling it, I don't necessarily mean the load and that kind of thing, although that's a thing as well. It's more about the numbers of things that we're running on it, the numbers of applications, of services, business capabilities, the number of people working with it, the number of people building different aspects of it and parts of it. Again, as these, for a large organization, we are getting kind of really, it gets really messy, right? And so there's three kind of areas of challenges that I'll talk a little bit about. One is supporting the software delivery, right? It's the classic, we need to kind of test our software through environments and getting that into production. Also, the number of environments, by which I mean particularly the number of like production environments where maybe you're running in different geographical locations, or you're like replicating, maybe you have software that you have multiple customers, maybe it's multi-tenancy or those kind of things. So maybe you have to have multiple environments for those kind of reasons. And also the number of workloads, the number of different applications and things that you're running on top of your infrastructure. And so all of that kind of adds to complexity, right? Makes it harder to manage. So for the first one of those, effective software delivery. Multiple environments here is about the classic path to production. Whatever kind of environments you have, you're going to progress your software from one to the other. Now, it's interesting. So back in the old days when we started out with infrastructure as code, we talked about configuration drift. And back then, configuration drift, we were talking about the differences between environments. That you have your software that works and you deploy it to the staging environment. It works there, it passes tests. And then you start to deploy it to the production environment and it doesn't run because there's some little difference in some library that's installed on that server versus the other server. And so this was the problem we were trying to solve with that, right? And the idea that you're going to have this infrastructure code that you're going to run across all of your environments, and it's going to kind of deal with that configuration drift and keep things consistent and make it easy to kind of have, this was also the time when DevOps and continuous delivery were kind of new concepts, this idea that we're going to kind of make everything really smooth across the board. And so this was really kind of a key thing. What I'm kind of, it's disappointing to see that a lot of times what we end up doing is essentially doing snowflakes. We used to talk about snowflake servers. We often do the same thing now with code, where it's like for every environment we have a different copy of our code, and we make changes by we make a change to the code for the test environment, we apply it there, we say that's cool, and then we copy the code to the staging environment and we edit it to make sure it's because there's some differences between the environments, and then the same thing for prod. And so we've kind of go away from this. And it's funny that the term configuration drift these days tends to focus on each environment, like the code for the environment, does it match? And we worry about kind of getting drift that way, which is, okay, yeah, you do want to have your code and your actual stuff match, but it's really across the board is where it gets messy. And so a useful pattern to think about and maybe go back to a bit is how do we make sure we can reuse our infrastructure code across the environments, right? And use things where there is a need for variation between the environments. We can use kind of configuration parameters and all that, but we kind of codify it. It's all in the code rather than in your head. Make sure you remember when you copy the code from one environment to the next to tweak this or that. Yeah, taking the same code and bringing it across environments. Another kind of common thing that we do is where you have the infrastructure team is having to kind of build stuff essentially by hand, kind of on demand, for whoever is running stuff. So application team says, oh, we need to kind of make a change to our configuration for some of our infrastructure, for our database or message queues or what have you. And so they have to raise and ask the infrastructure team, can you go and do this for me, please? And then they go and edit the code and make the changes for us. Something that I think is interesting that starting to see a little bit more of is this kind of more dynamic type of environments where stuff gets provisioned automatically, maybe when the software is deployed. And this is kind of, I think it's building on the kind of GitOps idea of, okay, you have your code and you have, for each environment, you have the version of the code that's meant to be what's running in that environment, what's applying to that environment. And that's getting kind of extended into infrastructure with things like, cross-plane and stuff, things like that, where they have the kind of controller pattern. And I think there's a lot of kind of, there's a lot of kind of questionable stuff here, or things that people get a little uncomfortable with. One is the fact that these kind of patterns that I'm talking about tend to be implemented a lot in this kind of the cloud native as code for Kubernetes, right? You have to have Kubernetes in order to do this, and maybe I don't want to run a Kubernetes cluster just to manage my infrastructure. And then also, so also then the idea that you need to have it running kind of behind the scenes, right? So you push the code change, and then something happens, and then your environment is broken, and then you have to kind of scratch your head and figure out how. So I think there's challenges with the way some of this stuff is implemented, but I think the concept is quite cool in the separation of, like, as someone who owns an application, I don't necessarily want to think about having to write the low-level details of infrastructure code for my infrastructure. I kind of just want to say, look, I need a database, right? And maybe I have a few things that I need from that database. I'm going to be storing personally identifiable information in there. So therefore, I need whatever the right things should happen with that in terms of encryption and policies and so on. But as an application developer, there's that level of what I care about and what I would like to have just kind of happen. And so if you kind of build this stuff well, you can kind of empower those application teams to say, I can kind of create a new environment, right? Because I'm just saying deploy my application, and we know the kind of infrastructure that it needs, and that can just be done. So we can kind of have those kind of separation of concerns between those. Another challenge I see quite a lot is where, so the environments are kind of static. And again, even though they're built with infrastructure as code, you kind of have this idea that creating a new environment is a lot of work, right? So if we say we want to have like a performance test environment to do some special testing, we got to ask the infrastructure team, and it takes time to get set up. And then it kind of sits there and maybe kind of runs up costs as it keeps running. And then what this kind of leads to is where you have like lots of different teams, like different application teams deploying their stuff into the same environment and trying to test it there. And there's two kind of, I guess, negative outcomes I tend to see with this. One is that the environment becomes a blocker. It's like, oh, we have a change we want to test, we want to deploy our application, but another team is testing stuff in there, and so we have to wait for them, and it becomes bottlenecked. Or it's like, oh, that's fine, everybody just deploy your stuff in there and don't worry about it. And then, so you deploy your application, something breaks, and you try to figure out what did I do to break it, and you realize, oh, it wasn't me that broke it, somebody else deployed something in there and made a configuration change or what have you. And so there's this kind of this thing of like, we're kind of like fighting over these environments, and I think that has a lot to do with it, again, being this kind of static thing that's a little bit hard to set up, and so it's an obstacle, right? And so it becomes kind of a precious resource. And then you also get the kind of ironic, I guess, thing that you also get is that you get environments that are underutilized, right? So you get this clash of everybody trying to use these environments, but you also get environments that are sitting there racking up costs. And the reason being, of course, because it's hard to get an environment set up. Once you get one set up, you don't give it back, right? You can hang on to it. And so I think this inflexibility and this kind of the static nature of the way we manage environments, even with code, tends to lead to this. And so I think if we get into this kind of thing where we can kind of dynamically provision environments and provision them according to what's being deployed on there, and as kind of an automated kind of thing, you can start doing things where you have like just enough environment, right? And so your full production environment might have a whole bunch of infrastructure, some different infrastructure for 3 different applications, but then you're going to deploy wrong way. You have just that one application that you want to test some changes to. You can say, let's deploy just enough of the infrastructure for that application to run, and maybe mock out and stub anything in terms of other applications so that we can do that, right? And so that kind of gives you the ability to kind of manage just what you need and ideally do it on demand and deprovision it automatically when it's not needed anymore and so on, and so it can be just done more efficiently. And so then if we think about, so that was the software delivery stuff, how do we support that with our environment? So as we think about having more environments for production, there's different reasons we might have that, right? When I mentioned you might have different regional customers that you need to kind of have, and in some cases you might try to have a single environment that meets all of them, but in a lot of times, due to regulatory things and all that, you end up needing to have separate kind of copies of your systems and separate copies of your infrastructure for each of those. You may also have SaaS customers, right? Depending on your business model, it may be that you have customers that come to you, and so you're going to spin up infrastructure and instances of your stuff just for them, and that maybe they want to have their customer data separated from other customers who might be of yours, who might be their competitors, right? And so there's that kind of pressure, okay, you have to have separate environments for us. And then sometimes there's this co-branding stuff, right? So you're going to kind of customize software for, maybe you're doing like partnerships with somebody, and so you're saying we're going to deploy our software with different branding and those kind of things. So those are some of the kind of scenarios I tend to see where we end up with lots of different production environments. And oftentimes this is not kind of planned, right? This is the thing, because we kind of start out, when we're designing this stuff, we say we're not going to do this, right? We're going to have a single instance, and we can do the kind of multi-tenancy thing, and that's really the efficient way to do it. And then you get these kind of business pressures where it's like, well, we got this customer waving a bunch of money at us saying, they refuse to be hosted next, in the same, infrastructure as one of their competitors or what have you. And so you can't turn down that money, and so you end up just kind of like hacking it together. And you end up back with this kind of snowflakes as code thing where it's like, every country that you're in or every kind of customer that you have, you've kind of copied the code and tweak it and edit it. And typically what you see with these kind of things is when you get a new customer that comes in, it's like, oh, make sure you copy the code from the last customer we did, because that's the one that we made the most fixes to. The ones before that, they're all kind of like manky and kind of stuff's wrong with it that we haven't got around to fixing, right? Not familiar to anybody? And so I think the thing that we would like to be able to do is a bit more of a kind of composable environment. So it's like you think about, okay, there's common elements of the infrastructure that we need for all these different instances. We'd like to be able to configure those and maybe have, in some cases, we're going to deploy some stuff and not others, depending on what it is that the particular customer or the region needs, whatever the differences are. And so you kind of want to have your infrastructure code as something you can kind of like, pick as components, right? Componentized, right? I'll talk a little bit more about kind of thinking about components in a moment. But where we're trying to get away from is that monolithic thing, right? So when you have just all of your infrastructures in one big blob, one big project, that's where it's really hard to kind of break it apart, hard to do those kind of dynamic things of having partial environments to test, say, one application or to subsets of the services that we want to offer to a particular customer. And so the way that we kind of deal with this, again, I'll have three things on here. So one is finding ways to make those environments more composable. Then being able to use that to design the infrastructure and provision infrastructure around applications rather than kind of more kind of horizontal thinking of the architecture for it. And then again, dynamically provisioning the infrastructure. So for composable infrastructure, what we're talking about is splitting that monolithic infrastructure. So as an example, this is like, let's say it's a big Terraform project, right? So I worked with a client a couple years ago in London where they had a Terraform project. When you ran Terraform apply, it took 2 hours to run. They had one file called rds.tf. It had 60 MySQL database instances in there. Yeah. And so like when we were talking about with them was, well, how do we break this down a bit, right? How do we make it so that we can have separate kind of bits of infrastructure separately provisionable for each, right? And so let me go to the kind of component model to think about how kind of how we originally thought about it, how they originally thought about it. So when you think about just the runtime, like the infrastructure that actually runs, for the most part, the level of components that we talk about, like they don't really exist, right? Maybe we have tags and stuff to indicate what kind of things are where, but really you've got the applications and stuff that are running on it, that are deployed onto it, and then you've got those individual resources from the IaaS, infrastructure service level, kind of, the API, what does it give you in terms of resources, right? And everything else is just kind of like, imaginary. So you have your source code context is where, in your Pulumi, your Terraform, or your whatever, your Ansible, you have like the things which correlate to the individual, what the API gives you, right? So it's very low level. This is, mapping of what the cloud platform gives us and how we want to wire it together, right? Here's examples of the kind of what those look like. And then you've got and this is one of those things where the terminology is not consistent across vendors, right? But stack is kind of, kind of ish. Like I think we know what we're talking about when we talk about stack, which is basically the deployable unit of infrastructure code, right? It's like when you run your apply or whatever the command is, this is the unit of code that's going to get applied and might potentially change, right? And so stack, it's a code level thing and it's a deployment level thing as well. Terraform project, CloudFormation stack, and so on. And I also want to touch on the libraries, right? So going back to that client with the 2-hour Terraform apply, when we talked about, we need to break it up. You know, we need to kind of break that up into smaller pieces. They're like, oh, that's great. We'll turn it into a bunch of Terraform modules. And it's like, well, Terraform modules don't really cross over, right? They're not a deployment unit, right? They're a code organization unit. When you run Terraform apply, it's still going to read all those modules, pull them together, and then apply them. And it's still going to take at least 2 hours, maybe a little more because you have to kind of coordinate now. It has to kind of download the different modules and work out the versions and such. So those kind of libraries are useful for organizing your code and even sharing code across projects, but it doesn't help with that. You know, how do you kind of make the deployment level smaller and more composable? So there are some examples of things that work at that level. I feel like there is a higher level to think about in terms of designing our infrastructure and a higher level component. I like to think of it as an infrastructure product. I'm kind of like cribbing from data mesh, where they have data products and all that. It's like, how do you define something which is kind of meaningful to the consumer of it? So the application, as an application team, what's meaningful to me? If we're going to say we're going to break down that deployment stack into smaller pieces, that becomes kind of a technical thing. So what's the right level of design for that infrastructure code that makes sense in terms of how we want to deploy it and make changes to it? Might not be the same level that's meaningful for the application folks. In fact, it might be that that has like multiple stacks are actually involved in that. So maybe you have different stacks that are doing kind of the data, and that needs to be treated a little bit differently because we have to worry about persistence of it. Versus some other parts of the infrastructure might be in a stack that we can kind of store and recreate quite quickly because it's, you know, everything in there can be ephemeral. And so having the kind of freedom to kind of decouple that level can be useful. So yeah, and there's a few things I've seen out there. So Pulumi has the concept of a project, which is kind of at this level, or can be. You have the idea of micro stacks where you break down smaller stacks within a project and can deploy them separately. Now, HashiCorp have confusingly announced they're coming out with this new thing that they call stacks, which is not what anybody else calls stacks. And it is basically how to configure multiple Terraform projects and modules, you know, and integrate them. Like, okay, you can have a couple of projects where the inputs from some feed into the others. So that's conceptually, I think, fairly close to this. But yeah, it's kind of disappointing to me that they they overload that term. Oh well. Yeah, and so the second pillar of kind of making this stuff work is thinking around how can we design our infrastructure around the applications, around the requirements of the applications, right? Because I think the natural way that we tend to build infrastructure, especially when it's at that high level of across of our different workloads that we may have, is we kind of think of it technologically, right? We kind of think about, oh, you should have all your networking stuff in one project if we're going to break it up, and then we'll have all the database stuff and compute. And this is like in software architecture, this is also a classic pattern or a classic anti-pattern, right? We kind of found that actually this causes problems because you get these kind of coupling across, like if I need to make a change to the infrastructure for this one of those applications, I'm touching things which might affect other applications and their infrastructure. So the kind of vertical layering is really more effective as a way of dividing things up so that you can kind of work on the changes to each independently. And then keeping in mind that also, so one of the kind of, I think, useful divisions to think about is thinking about the infrastructure that is specific to the applications. Maybe it's things like the load balancer rules and the database instance and I don't know, message queues that are specific to that, for that kind of service or what have you. Versus then there's the shared stuff where it's like, okay, maybe it's a container cluster that multiple applications in. So thinking about those divisions then helps us think a little bit about how do we organize and gets us into that. How can we have infrastructure that's going to be provisioned specifically for that application because we've kind of identified that, right? Which is this, right? And so this is the idea that rather than seeing an environment as something that you build, so you go and you build the environment and then it's there, and then applications can go and deploy their stuff in there and try to get it to work in the environment. can we do it application-driven way, right? So can we say, okay, along the bottom there's some things that are shared, and maybe we have the concept of an environment and the stuff that is at that level. So you provision an environment, and then the things get provisioned for that. And then the things that are specific to my application, when I deploy my application, the infrastructure code gets kind of grabbed and either provisioned or updated or what have you. Oops, that was going the wrong way again. All right. And so this is basically just the idea of getting us to that flexible cloud infrastructure, or my kind of thoughts on what maybe the DevOps report is talking about when they say what helps to make actually you get more, better, higher performance out of using cloud. And so just to kind of summarize it up, that's about thinking about how we do the software delivery, number of environments we can support, and the number of different workloads we can have on it. See how we can make that infrastructure more composable, design the infrastructure around the applications, and make it dynamic. So that's, yes, that's my thoughts. I'm happy to hear kind of feedback and ideas on that. Thank you.
So, thank you, Mr. Keith. We have a few minutes for questions, and also, if you answer all the questions correctly, you get a chocolate present.
All right.
So, here, give you the mic. You
Yep.
have a good 10 minutes. So.
Okay, thanks. All right. Who's got questions or feedback or objections?
He's decided he doesn't want to do stuff.
Yeah, we have an hour.
All right.
So maybe no, he'll be right back.
Coming back to the 2-hour Terraform thing,
Yep.
how did you pull that apart in the end?
So the Terraform 2-hour apply thing, how do we pull that apart in the end? So that was, it was tough, right? So basically we broke it into separate Terraform projects, each of which we could ideally provision separately. Now, what you very quickly run into with that is the dependencies between them. And so you say, well, okay, at the lower level, we've got like the VPC and subnet stuff, right? And then you've got kind of maybe, I don't know, container cluster. We had like the databases and so on. And so things kind of like pile up on top of that. And so in order to test this Terraform project that defined infrastructure that relied on all of that, it's like, oh, suddenly we have 2 hours to set up everything before we can start testing the thing. And so we really tried to push hard on using things like kind of mocks and stubs. So for example, the networking component, it had like a lot of stuff because it had to be like the real deal, right? It had to like have all the kind of like, event logging and all the policies and on that. So it was a fairly kind of heavy thing. And so we said, actually, we could have like a really lightweight one just to test this thing that we need to test. All I need is a subnet, right? Hand me a subnet, and then I'll deploy my thing and I'll test my thing, right? And so you can have that. It's like kind of the classic thing with software testing where you're like trying to figure out how can I test just this one piece by itself and then bring them together. But when we bring them together, only test the things that need to be tested at that level. Classic test pyramid, although with infrastructure, it tends not to be a pyramid shape because unit tests for infrastructure tend to be less valuable. I can talk about that more if people are interested. Sorry.
How would you approach a customer that is not be well, a SaaS customer, but they don't want their data to be in a cloud, but in their on-premise environment? So I have some components in there that are way out of my control, so they deploy their own cluster, and I just get containers or something in there where I have a black box, which I can't replicate in my testing environment.
Yeah, so the question is around what happens if you're having to kind of build stuff on, and the client's infrastructure is in their data center, and you don't have control over that, right? You're not being asked to build that. You're being asked to just deploy onto this container cluster and database that we provide. I mean, that's a classic dilemma, right? And so my kind of reason in life at ThoughtWorks as a company, because we do a lot of software development consulting, is I try to get in under there and say, no, I want to help you with that stuff because I think it'll help, if we build the infrastructure in a way. Even if it is within the data center, obviously you can do this stuff. That's more compatible. Those times where, so I've had times where the line is a little bit different maybe than what you described, where it's like, well, there's a central team and they're set up landing zones, right? So they set up the networking and policies and accounts, and then you can deploy some infrastructure that you're allowed to deploy, but within that. The thing I've tried to do with that is to make kind of almost like adapters. So if we can agree the interface, right? Okay, this is what you're going to provide. These are the things that you're going to provide, and then I can kind of like mock those on my own. So for my testing, I'm going to have like a cut down kind of version of what they've provided. That's consistent enough, but it's not an easy. I don't have an easy answer. Yep.
What's your idea on the promise of Kubernetes as abstraction layer of the cloud?
Kubernetes is abstraction layer of the cloud. I think that's cool if you're kind of building new and you have that freedom. I think one of the things I find, again, talking about the types of clients that I have, which are, they're not going to rebuild everything they have on as containers and serverless, anytime soon. And I think one of the things that I think about when we talk about these new waves of technology coming along is that they don't really replace the previous wave. It's not like the new technology comes and the other stuff disappears. And people are still using mainframes, right? So they're really additive. And so I'm always a bit skeptical when I see kind of tools and things coming out which are like, oh, here's the new thing. And it's like, first, everything's a container, everything's serverless. And then, you do really awesome stuff with that. And that's like, that's nice. And it might be nice if I'm starting a new thing. But I kind of need backwards compatibility and so on.
Gotcha. Time for one more really good question. I have one. Or two really bad questions.
We have observed that the increase of the cost, if you're going those swim lanes of the each product, it was some increase of the cost for the infrastructure.
So, repeat the question. Yeah, so I didn't quite catch that. Is it about the cost?
Yeah.
Can you unplug you? Unplug you too.
Yeah, you can unplug me. Yeah, that's cool. So sorry, were you asking about like how do you deal with the fact that cost is going up and up? Or?
I was asking if you're giving that environment for the product, basically, right?
Yeah.
So you kind of decompose that. So is where the cost increase for that, for the infrastructure, etc., because you have the set of more components.
Yeah, I mean, as you have more product teams and more stuff, and more developers working on things, yeah, obviously the cost of the infrastructure goes up, and that's one of the things that tends to surprise people because they look at like, oh, what's our current infrastructure in the in the data center, and what would that cost if we kind of turn that all into cloud-based stuff? And then you give people the cloud, and it's like, oh, I'm going to create new environments and everything. And so I think it really comes down to, so some of the stuff that I'm talking about is how do we get away from needing like a big environment that sits there, and we're all kind of trying to do stuff in it. How can you kind of make stuff, okay, I'm going to spin it up, I'm going to run some things, I'm going to tear it down. How can I make sure that happens? So I think that is a big thing, is just being able to manage it more flexibly and dynamically, and having kind of the dashboards and all the kind of things to kind of make sure that you can see what's going on. But I think the other thing is also just you have to build that into the costings, right? And I think that's the thing that people often miss, is that you're kind of, one of the great things about the cloud is that you're no longer constrained by like the data center having these kind of fixed things, and but that's also, yeah, the flip side of that is that, yeah, you can ramp up your costs really fast. Right.
Okay. One more giant round of applause, Mr. Keith.
Thank you.
That's so good.
Thank you.
Do you want to do this? Do this too.
Hang on, I will. One second. Let me finish.
Okay, so in a few minutes we're going to set up so you can chat amongst yourselves for 2 minutes. Tell jokes. Who wants to tell a joke? Appropriate joke. Paul? Paul has a joke. All right.
No, in my hand. Otherwise I start to feel like I'm pretending. I feel that way about these fucking things. I can't.
Put it a little bit lower.
You want me done here?
Yeah, right there, yeah. I think it might work better that way. I can help if you want.
I think I can get it. Maybe this way. How's that? Is that one good in mic land? You're gonna help?
Yeah, I'm going to check you.
Yeah, thank you.
So
Yeah?
it's good.
Okay.
Ready for you?
No, yeah.
All right, everyone, no more chit chat. Fun time is over. This is serious business. All right. Hello. So welcome back from the very short break. We have a special treat today. We have Mr. Chef Adam Jacob here, who's Jacob or Jacob?
Just Jacob, no S.
I got it right. Beautiful.
Yeah.
So he claims he's going to give a talk about art, but I think he's going to also throw in some of the news on his new System Minute tool. And I've asked him for some live demos. So if he pulls through and pulls one in the last minute, that would be cool. If not, we'll just like go up to him in the hallway and be like, I wish I had done a demo. He's actually born, I didn't know this till just today, from the wrong Vancouver, not the Canada one, the US one. But he came all the way here from the US, and we're super fortunate to have him. So please give him a giant round of applause.
Yeah. Yeah, my Vancouver's more like Kentucky. I don't know what the like Belgian equivalent of Kentucky is. I'm sure you have one, right? Where is it? Alps? Did I say that right? I must have, because y'all laughed. Yeah, so where I'm from is like Alps. I couldn't tell you if that's true, but let's just go with it. Yeah, okay, so I like Patrick, you like submit your talk thing in advance, you know, and I was like, you know what would be cool is we should do like a survey of all the cool new stuff that's happening. And I wrote that talk, and it was pretty good, but then I realized that I didn't want to give it. So, so this is ChatGPT generating the slide for the talk I was going to give, which is what's new and cool. I am going to talk about new and cool stuff, but not this way. So basically, a couple things happen. There's no slides either, so you're just going to sort of get my notes. Because when I was showing people the talk, they were like, just do it this way. It's so fun. So if it's not, you can blame people who work for me. Okay, so this isn't actually the talk that I wanted to give. I was going to give this talk that talked about DevOps, and it was like, hey, we need a second wave of cool new DevOps tools, which I do believe we do need. But I realized as I put the talk together that the DevOps part was boring. Like, talking about DevOps wasn't actually what I cared about, and it wasn't the point that I wanted to get across to you anyway. What I really wanted to do was talk about art. And so I want to spend the next 50 minutes talking to you about technology, but through the lens of art. Because over the years, what I have done mostly is build technology products. I build new stuff. I built Chef, I built Habitat, I built some other things in the middle, and now I'm building System Initiative. And I've kind of come to believe that the delta between art and science isn't as strong as I believed that it was. Like, I felt like I was taught that there was this real strong line between the arts and doing art and thinking about art, and then science, and they weren't the same, and they didn't get to hang out together. And it turns out that the Greeks actually super agreed with me. They have this phrase called techne. Techne basically means, you know, art that is practical. So if you think about the art of practical things, or the creation of stuff, Aristotle talked about this as a state involving true reason concerned with production, which sounds really fucking highfalutin. But essentially, it's the root of the word technology. And so when they thought about technology, what they were thinking about was art that went into stuff that you use. And for me, most of the time in the last 20 years, I feel like that's really what I've been doing, is I've been sort of exploring what it's like to think about and build art. And the longer I do it and the more I focus in on it, the more I believe that the first step in building something really cool is that it has to be kind of amazing, first for yourself. So you have to look at it and be like, I love this thing. For whatever the reason is that you love it. Like, whatever the thing is that you like, you have to really want it. Then secondarily, it has to be amazing for the audience. So, you know, you can make art just for yourself that no one ever sees, but I like building things that you see, right? I like to give them to you and have you play with it and see if it's good, right? But if I want you to like it, the best way to make you like it is for me to like it, right? If I try to please you, I'm probably gonna get it wrong, right? Because you like stuff I don't like. And I don't really know what's in your brain. So a key part of deciding to make something that you love is looking at other things people have made and loving those things, right? So if you just hang out, I love heavy metal, although I'm wearing, I think, an Allman Brothers shirt, so you wouldn't know it right this second. But, you know, if you love something, and you don't take in new inputs. I have some friends who also love heavy metal, but what they really mean is they love Metallica. And that's like what they love. And that's awesome. Metallica's cool. But they don't love like the rest of heavy metal, right? They're like, grindcore's too loud. And I'm like, no, I fucking like grindcore too. You know? Like I want the whole thing. Give me like black metal from Norway in some tiny town with like a kid in an icebox. And I'm like, fuck yeah, you know? Because I like it, right? And so I'm taking in this art and I'm pulling it in, and you're then basically pulling that in and you're in conversation with other things, right? That stuff's in conversation with other heavy metal, it's in conversation with other black metal, it's in conversation with other things. The same's true for us in the technology that we build, right? We're constantly in conversation with the technology that came before, with the things we're building now and what we're thinking about in the future. And nowhere more than here do I feel like that's true. I love coming here because here in Ghent at Config Management Camp, this is like the most, I'm gonna use the word safe, I don't know if that's the right one, but it's the place where I feel most at home with the people who I think are most likely to like the shit I like. Yeah? And so what I really want to do is hang out with you and talk about technology I love as art, because then I want to hang out for the next 3 days and just talk to all of you about the stuff you love and why you love it. Because that's going to inspire me to go make better art. And then hopefully it inspires you to go build your own art and to make the things you think is cooler. And I hope that that's what happens. So that's why we're talking about art today. So I'm going to talk about 3 things. I'm going to talk about Wing, which you're also going to hear about tomorrow. So sorry for the doubling up, but I didn't know when we started. I'm going to talk about ChatGPT, which you also heard about earlier, but from a slightly different angle. And I'm, of course, going to talk about System Initiative. I'm going to talk about what makes them fun. I'm going to talk about what makes them helpful, what to me makes them inspiring. And then I want to talk to you. So let's go. Let's talk about Wing. So what's Wing? It's a programming language for the cloud. This is our website. That's what they describe it as. So it combines infrastructure, runtimes, and code into one language, enabling people to stay in their creative flow and deliver better software faster and more securely. Wing's mostly open source, I think. It does look like it's mostly open source. There's some parts that aren't. It's unclear to me which ones are open source and which ones aren't, so we should ask him tomorrow. Prior art for Wing, you know, the first person I ever heard talk about Wing was actually Joe from Pulumi. I met Joe before Pulumi was a thing you knew about. We were like having dinner with venture capitalists, and Joe basically pitched Wing to me as Pulumi. And I was like, that sounds pretty cool. So to me, Joe is the earliest prior art for this that I ever heard. But the thing that you most commonly will think about is the serverless framework. If you've ever used the serverless framework, basically you write a bunch of little functions, and then you glue them together with some YAML, and then you run them. And that's like the most direct ancestor to Wing, right? So what's it like to use Wing? Well, first off, Wing's a programming language, so what you're really doing is writing code. It thinks about this idea of like the cloud as runtime. So if you look up there, it says like bring cloud and bring util, and then we're creating buckets and counters and queues, right? All that stuff is, you know, cloud as runtime. It's thinking about, you know, these abstractions that we're going to use, which then eventually become infrastructure. And then we have this function we call queueSetConsumer. And that has a little in-flight tag on it, right? And what that means is we're going to run that code at runtime, right? So it's going to like set up a bunch of stuff from the cloud, make your queues together, and then when it wants to run the function, it's going to run this little counter. And what it's going to do is every message that comes in, it increments a counter, then it puts it into a bucket, then it logs some output, right? And then we can write a little test and be like, hey, does this actually do what I thought it would do? So an interesting thing to think about here is that there's this split between pre-flight and in-flight. So they think about the code, most of the code here is pre-flight code, which means when the compiler runs it, it's going to take it, and then it's going to turn that into infrastructure. And then the in-flight part is the function that's actually running when you're doing whatever you're going to do, right? So there's this interesting split there. We'll talk about that again in a minute. But there's really no infrastructure description here at all, right? Other than queue, right? Or bucket, right? But you don't really, it doesn't look like infrastructure as code. You're not describing infrastructure really at all. You just kind of focus in on the behavior. So then what you do is you run this thing in a simulator. And when you do that, you run this command that's called wing it. Yeah? Fuck yeah, wing it, right? I'm the guy who brought you knife, recipes, right? I love that shit. This is like my jam. So as soon as I got to wing it, I felt like this little dog. I was like, yes, this was made by people like me. They love you in their hearts. It was awesome. So then Wing It pulls up this pretty rad simulator, right? So how's this thing work? Well, it takes all that code you wrote and it puts it into a simulator, and then it's all running on your laptop. So there's no actual cloud involved, but I can click around on this thing and interact with it directly. So I wrote all this code that's like, hey, make me a message queue with a consumer in it. I can like put it in the little box, I can type in my message, I can hit the button, and it'll actually push the message through the system. I can then click on the next thing, the little message store, right? And then I can inspect it. And it's got a list of files that it wrote out, right? And then it's got a little message. Hello, configuration management camp. It's the best, right? And it gives us the raw data back. This is rad, right? This is fucking cool. Who doesn't want a little simulator that has all your business logic in it? You can just click around in it. You can change it. You can be like, oh, I don't like the way the file names are written. And then you can tweak it, and it'll hot reload it, and then you can do it again, and it's got a new file with a new name. That's fucking cool. It doesn't work that way if you use some other thing, right? It's cool. So then you're like, hey, that's rad. You can manually mess around with this thing, but I am a professional software developer. I need tests. And they thought of that for you too. So they take that little test I wrote before, they throw it in a little panel, I can hit the little button, and what it'll do is not mess with the local state of the simulator. This is genius. I know it seems dumb, but if you think about it, I can go tweak this thing, I can play with it manually. Every time I run a test, it runs it in isolation. It's just a little bit of sweetness. It's just a little goodness on it that like makes it even better. So you can run the test, it'll tell you if it worked. That's super rad. Look, this feedback loop is incredibly good. If you've ever used any of the existing serverless tools, let's just call it awful between friends, right? We're all friends. Hi, Livestream. It's not good, right? It's no fun. This thing's fun. It's fantastic. It's super nice. Night and day better. Night and day compared to the other ways you could possibly do this. It's so much better. Okay, so then you're like, hey, the simulator's rad. How do I deploy this thing to production? Well, at deploy time, you generate infrastructure as code. So you say wing compile, and then you pass in a platform. And the platform is like a tuple of the infrastructure backend you want to run and the cloud provider you want to deploy it to, right? So you say Terraform and AWS, or Terraform and Google, or whatever. And then what it does is spit out infrastructure as code, right? So this is a Terraform repository. They spit it out in JSON rather than HCL. That kind of bummed me out, because I feel like if you just gave me a ball of JSON, that just, I don't know. I don't know why it felt like a cop-out, but it did. But I get JSON, right? It's 6 1/2 dozen to the other. What's cool about the JSON it generates is all the glue you don't want to have to think about, it did. So it thinks about things like IAM rules, right? It knows that I'm building you a database table, and it knows that database table needs to talk to the queue. And so it sets up all the rules to make all that stuff happen for you. You don't have to think about it. I love it. I love the inferred infrastructure part. That part, great. So cool. Look, what's Wing? Wing is great. Wing's awesome. It focuses in on the developer experience that you want. It solves that horrible feedback loop that lives in the serverless space. There's a ton of inspiration that we should all draw from Wing, right? So cool. I can dig it, as the Fonz would say. Okay, what else do we need to know? So what are the sharp edges? It's not all good, right? Something's got to be terrifying. So, you know, Wing's very abstract. If you think about it, most of your applications actually do care about the specific behavior of the stuff you choose. You don't really choose queues. You choose NATs. You choose RabbitMQ. You choose SQS. And you care because you're picking individual properties of those queues. So I have some suspicions about like queue, right? Are we gonna have database? We're gonna bring database? Is that gonna work? I don't know. Maybe if you're small, but not if it matters. Extending the platform. To do this, you kind of have to be an expert in the Wing abstract programming style. So you have to know that I want a developer to have this abstraction that is queues. Then you also have to be an expert in infrastructure as code, because you're going to have to write a compiler backend that understands how to go from the abstract to the concrete, which, I mean, is totally doable, right? It's not like that's not a thing we can do. But let's just say it's harder than maybe other things we might need to do. And then finally, troubleshooting and collaboration and release planning. There's a lot of like day 2 shenanigans that happen when we're like running real life applications. And this is a pretty complex deployment pipeline. You're gonna review the application logic. You're also gonna review the generated code. Then you're gonna look at the plan for how that would apply across the other thing. That's gonna be different depending on the backend you chose. Look, this complexity, this part's mostly because of how infrastructure as code works.
I don't think it's Wing's fault. I think it's just that's how infrastructure as code rolls, and so you're just sort of stuck with it. If you think Wing's interesting, what other things could you look at that are also interesting? So one is this crowd of things that I think of them as the annotations crowd. So there's a set of people who are like, hey, you know what we should do? We should decorate our programming languages with infrastructure. So Shuttle is a good example of this. There's some code here that says, hey, I need a database. And so you just put a little fucking annotation in there, and then it poops one out for you. Clotho is another one. They're like, hey, I want my map to be persisted in some store. What store? I don't know. But it is going to do it. So if you think it's cool, you could look at the annotations crowd. Another crowd with the same basic idea, which is we need a cloud programming language, are the language-specific paths. So you can see this with like Deno, Vercel, other people. Deno is the best example because essentially they're saying, hey, look, we build a runtime for TypeScript. What we're going to do is add services to our runtime like key value stores and queues and cron jobs and all the things that you want to do in this abstract programming language. So then instead of thinking about infrastructure at all, you're just going to use our key value store to implement what you want. Then you don't have to think about it. No infrastructure is code. It just works. So what other directions could we go? So what kind of cool art could we think of beyond here? So one is this pre-flight, in-flight split. I did this to you with Chef. How many people use Chef? Remember how it had like a compile phase and a runtime phase? Did you like that split? No hands. My hand's up, but only because I wanted you to do it. This guy's like, I kind of liked it. Right, because he did some macro shit. I see you. I know what you did. You walked that runtime thing and fucked with the array. I know you. Okay. And it was cool you could do it, but I'm not saying that it was a good idea. It wasn't. People hated it. I wish I could have gotten rid of it, but I couldn't figure it out, and these guys didn't either. Real languages. You know, Wing is mostly TypeScript, except when it's not. That's going to bite you someday. I don't know which day, but it will. Should you really have infrastructure as code here at all? I'm completely unclear why we care about having to specify the compiler backend and the cloud provider. You've already abstracted away Q. Just do it. Just make that thing happen. Skip this whole shenanigans of pretending you're going to generate infrastructure as code like it's going to integrate with my other infrastructure as code. We just watched Keith's incredibly good talk about infrastructure as code patterns. You're not integrating this shit in your existing Terraform repo. Yeah, that's dumb. It's not going to happen. So why are we doing it at all? Why not just make the calls and do it yourself? Okay. Let's talk about ChatGPT. Yeah? You sick of ChatGPT yet? You will be. Okay. What's ChatGPT? Look, it's this big conversational AI thing that we trained on this huge portion of the internet, which is awesome. It's also like a terrifying hype demon that's coming for your jobs, your life, and all the fun in the universe. It's Broco's basilisk. It's not at all open source, so sorry, but it's just not, so you're going to have to deal with it. I asked ChatGPT what it is. It gave me a pretty good answer. I think the important part is it's designed to understand and generate human-like text based on the input it receives. And that's what it does. It's quite good at it. Prior art to ChatGPT, this is Eliza. This is the first AI chatbot I ever used. It was designed to be a therapist. So I pulled up Eliza as I was prepping this talk, and it said, hello, I'm Eliza. I said, hello, I'm Adam. And it said to me, did you come to me because you are Adam? And I was like, whoa. I mean, yeah, like a little I did. So I think it was pretty good even then. Another thing that's sort of prior art here is Spam Assassin. How many people use Spam Assassin? Yeah, fuck yeah, Spam Assassin. Saved us from spam. Amazing. Right, machine learning thing. Trained on a huge corpus of all the spam. We ran it for decades. It's what kept your inbox clean. Spam Assassin. Get some. Okay. AWS. Look, Amazon, I'm using this for search. So if you really think about similarity search and faceting, the earliest versions of this really were things like this, where I said, give me red sweaters with faces on them. And so it gave me a thing of red sweaters. This one has a face. It's not a sweater, but whatever, it's got faces. And then this is a sweater that comes in multiple colors. And then they understood that sweaters had different facets that you might care about. For example, crew neck sweaters, long sleeve sweaters, right? And you could like pick between them. That was cool, faceting. Also cool. Google, take all the data ever, anywhere, and throw it in a search engine, right? Good idea. Hot dog, not hot dog. This, I think, honestly, was the pioneering thing that led us to ChatGPT more than anything else. Because how many of you installed Hot Dog Not Hot Dog? Yeah, not enough of you. You can't install it anymore, which bums me out. But there was a minute where everyone in California had Hot Dog Not Hot Dog, and were taking pictures of everything, being like, is it a hot dog? And you were like, it's not a fucking hot dog. Anyway. Okay. So what's it like to use ChatGPT in real life? So I was trying to think of like, what's the thing I could do to show what it's like to use ChatGPT, and I thought this crowd will appreciate Chef, so let's do that. So there's an OG Chef tutorial that basically lets you create users in databags. So this is the conversation I had with ChatGPT. I said, I have a server running Ubuntu, use Chef to write me a recipe that installs Nginx and Postgres, make sure all the packages are up to date, and has a user Adam with an SSH key I can log in as. And it just did. It was like, sure, no problem, homie. And it wrote the recipe exactly the way I would have written it. Might have taken it away. The only problem was it decided my shell was bash. I don't like bash. So I said back to it, Adam prefers to use ZSH. Can you do that? And so make sure it's installed and change it. And it was like, absolutely, no problem, homie. And it rewrote the recipe, set my shell to bash, put a little comment in there that says, Adam likes bash, right? Good call. But it did have like a small logic bug, which if you're an order nerd, which I am, I'm like, hey, you referenced ZSH, but we hadn't installed it yet. That would bother me till the end of time in this recipe. I would just be like so angry about it. The Puppet people are like, this is why you need dependencies. But I'm not a fucking Puppet person, I'm the Chef guy, and so I don't like it. And so I was like, hey, can you just do that before the user gets created so I'm happy again? And it was like, absolutely, right? And it puts it right at the top. It's like, first thing we do, install ZSH, because that's what you told me to do. And I was like, this was awesome. What if I wanted to get my SSH key from a data bag? And it was like, no problem. And it like writes the code again, and it fetches my SSH key out of a data bag. Here it is, right? And then drops it off. And I was like, this was amazing. Hey, instead of doing that, could you just iterate over all the users in the data bag and install their SSH keys, and then show me some JSON examples so I could populate the data bag? And it was like, no problem. And it wrote the recipe perfectly. It gave me a little example. There's even a user that has ZSH and a user that uses bash because it knows I care, right? Because it loves me, right? And then it did the right thing. And here it is. It's like, hey, grab the bag, walk the bag, make the users, done, burger. I cannot tell you how much time I spent writing this tutorial in like whatever, 2006, right? It was like a minute. And this thing just did it, and it was amazing. So I then was like high on my own supply. I was like, ChatGPT, this is my fucking new best friend. So part of what happens inside of System Initiative is it's a big graph. I'll talk about it in a minute, but it's got a table that's called edges. And I needed to write a recursive query against the edges. And how many of you know how to write recursive CTEs from memory? This guy, one guy, that's their guy. If you need to do it, homie's got you. I don't, right? I know it exists, I've done it before in my life, but it's not things that I remember. So I gave it my table structure, I asked my question, I was like, tell me what to do, and you know what it did? It wrote me the query and explained how to do it, and when you ran it, it mostly worked. It was like a little wrong, but way less wrong than Google would have been, right? So again, I'm like, this thing, genius, love it, let's go. So then I thought, let's give it the hardest thing I can remember ever having to do with Chef, which was install SAP HANA. How many of you have ever tried to install HA HANA? Yep, one guy back there. How'd it go? It worked. He went like this. Right, exactly. It fucking worked, right? Okay, so here's the thing. I asked it, I said, hey, can you, because I was so confident, I was just like, can you write me a Chef recipe to install a highly available version of SAP HANA? And it told me to go fuck myself. It was basically just like, look, here's what you're gonna do. You're gonna do all this research about how to do this incredibly hard thing, then you're gonna write a recipe, then you're gonna validate that you were right, you're gonna make sure it works repeatedly, and then you should think about things like security and backups and monitoring and documentation. Here's some code, install the packages and go fuck yourself. And I was like, oh, I read on the internet that sometimes if you beg, it'll do it anyway. So I was like, could you do it? I know you can, try. And so then it wrote like a longer winded version of telling me to go fuck myself. essentially like an angry developer would do. You know what I mean? If you were like, could you just, I know you can, could you just try harder? You know, and they're like, well, you'd have to do all this fucking hard stuff, and then when you were done, it still wouldn't work, which is literally what it said. So, you know, it has limits. But what it does do is let computers be creative, which is honestly fucking incredible, because that's not a thing they could do before, and now they can, and that's awesome. And it's really fabulous at helping me with things I know but don't remember, or to check my assumptions about the things I already do know. So if you want to know how it works, Stephen Wolfram wrote an incredible thing called What is ChatGPT Doing and Why Does It Work? You should go read it. It's really good. I'm not going to give you that summary now. Instead, I asked ChatGPT to explain how it works and to generate some slides. So essentially, it works by taking in a huge amount of data, the internet, slurps it all up, right? In comes the training data. Then it transforms it into coordinates in 3D space, right? If you were sitting here for Patrick's talk, you saw him talk about this. There's an array of vectors. It's basically saying this thing sits here in space. Then it takes your input and it does the same thing. It maps it across that space. It goes, you ask me a question, I'm going to look for all the similar things in the 3D space of all the information in the internet, and then I'm going to choose what the next basic token, character, what have you, would be. So then it generates a response. And that response then comes into the evaluation loop. So it's basically referring to itself as it goes. So as it starts to write the little chef recipe, it's like, well, I know I'm writing a chef recipe, and what's the most likely next thing for the chef recipe? And like goes along and along and along until in the end it pops out something that's like pretty rad. So look, ChatGPT, hugely better than Googling. And if you do one thing in this talk other than talk to me after this presentation about what you think is cool, it should probably be get a ChatGPT subscription. It'll make you more effective at what you're already great at, and who doesn't need that? Okay, so where are the sharp edges? Because there's always some. Hallucination. This is less of a big deal than you think. Everybody loves to talk shit about hallucination. I did too. I was like, this AI thing hallucinates. You can never use it for infrastructure. I sounded smart. I don't know why I made an accent there. I think I need to apologize, but I'm not gonna. Okay, so it's the source of much of what makes it amazing and unique is that it can hallucinate. If it couldn't hallucinate, it couldn't be creative. If it couldn't be creative, why do we care? But it is going to get things wrong. It is going to make things up, and that's going to be a bummer. The hype is a problem. This is like actual transformational technology. It's very cool, but we treat it like impenetrable metaphysics, right? If you listen to some people talk about AI, they're like, it'll do everything ever. And you're like, well, what about the science part where it has limitations? They're like, no limitations, more power. LLMs will run the world. And you're like, no, they won't. It's a fucked up search engine. Okay. The last thing is blind faith. Lots of people, you just throw stuff at it. It's pretty good all the time. You know, its only real value is as an adjunct to the knowledge you already have. If you don't already know the complex thing you're asking it to do, this thing is going to lead you straight to doom. Just bad, so bad, right? So, you know, everything it does requires interpretation. You're going to have to think about it that way. If you use it to augment yourself and your team and the things you know, amazing, change your life. If you're like, I don't know how to program SQL, so write me a recursive CTE, that's going to go so badly for you. Okay, similar art. Pulumi has a thing called Pulumi AI. It's basically rebranded ChatGPT. If you just want like a ChatGPT that only talks about infrastructure as code, you can get it from Pulumi. Bard. This is Google's version of ChatGPT. It's just worse, so maybe don't try. I asked it the same question. It just got it wrong, like twice. And I was like, nah, pass. Copilot and Cody. So these things use your code base and they generate the prompt for you, which is cool. But it's kind of annoying. They like tell you to do things all the time that you maybe don't want it to do. Just you have to remember, it doesn't replace your expertise, right? So having more of the data at its fingertips does make it easier for you to ask more interesting and complex questions without having to craft them yourselves. That's cool. The part where it's like better autocomplete, kind of annoying. Okay. Possible future research. I mean, we haven't really applied a lot of the thinking around vector databases and proximity search outside of AI. So that's really the only place we do it. I think there's a bunch you could think of here that's really interesting. We have all this data about compliance and security and what would happen if we inferred the security policy rules? I don't know, but I think it'd be cool to find out. We don't have like a Wolfram for infrastructure. If you haven't used Wolfram Alpha, it understands math. and it knows how to do things. So when you ask Wolfram, like, where's the next solar eclipse? It's not like looking it up from a database, it's doing the physics and then telling you the answer, which is amazing. But we don't really have that for infrastructure, and without it, we're not really going to be able to tie something like ChatGPT into a system that's going to be able to do things, because our domain is finite. It's a little more like math. If the configuration's wrong, it doesn't work, for example. So we got to figure out what that is, and we don't know. The last is, the frontiers here are around like world models, reinforcement learning. How does the system know when it's right or wrong? If it's making a guess, how would it know if it's the right guess? It doesn't have a real understanding of what is or what's possible, which means net new things are going to be a challenge. This is why if people tell you it's going to take over everything, not yet. Not without some more development. I'm basically in Jan LeCun's camp. If you're not following Jan LeCun, you should be. I think he's basically right. Okay. Whew. I need to shake it off. That was a lot of talking. How am I doing for time? You're good. Okay, good. Let's talk about system initiative, yeah? Yay! Okay. I cheered for myself because I was nervous. That's what happens sometimes. System initiative is a collaborative power tool designed to remove the paper cuts from DevOps work. It's fully open source. There's no proprietary code at all, anywhere, at all. So you can take it, do what you want. System initiative is open source. Yay! Thank you. Yeah. Okay, so prior art, obviously, Chef, Puppet, CF Engine, all the principles of configuration management, that's my jam. That's where I have come from. It's where I feel most comfortable in my professional life. So all of those things are embedded in what System Initiative is. Another source of inspiration is Unity. So Unity is a platform for building video games. And essentially, you can think of this as a single, very complex workflow. Building video games, super complicated, requires a bunch of people working together with different disciplines over a long period of time, iteratively. Sound like anything you know? The chuckles. It sounds like DevOps. Okay. Oh, yeah, exactly. They have different interfaces for different jobs, right? So if I'm programming in Unity, it looks like an IDE. If I'm doing 3D modeling, I'm using a 3D modeler. If I'm doing scene construction, that's slightly different. If I'm doing blueprints for other people, it's slightly different, right? It's not one thing. It's many things for all the different people involved in the work. So we drew a lot of inspiration from things like Unity. Another is Figma. So Figma is real-time design and really clean multiplayer interactions. If you've never used Figma with another person in real time, you really should give it a go. It's pretty epic, and it feels incredible and very different than what you've done before. We drew a lot of inspiration from Figma, both for how it looks, because it has this very discoverable user experience, but also how it feels when you're doing it together. And then Terraform and Pulumi and the Infrastructure as Code crowd. Obviously, we drew some inspiration. I also think, in terms of art being in conversation, they clearly drew inspiration from the prior generation, right? Like, the way those tools work is roughly the way that Chef and Puppet and CF Engine worked, just now they do it on APIs instead of doing it on servers. Okay, so what's it like to use System Initiative? So basically, it's like drawing an architecture diagram. But the architecture diagram actually builds all the infrastructure as code and manages it for you. So you start out with an empty canvas, and you make a new change set. So you can think of a change set as like a Git branch. You can see that kind of up here. Is that too small to see? But there's like a little change set hiding up there. And then you pull assets over here from the left, and you drop them onto this canvas. And then when you draw connections between them, what you're really doing is configuring them. So, in an architecture diagram, you're just sort of drawing a relationship between them and going, this thing uses that thing. In System Initiative, you're actually inferring configuration relationships is what's actually happening in the diagram. You can then also set attributes manually. So some things don't need to be inferred. The names of things is a good example that is almost never better to infer. But then there's these little hexagons that turn green as you work. So they start out red, and then as you configure things, they turn green. And what's happening is we're making a little simulation, right, of that asset, and we're checking to see if that thing would work or not. So it's basically hypothetically looking at it and going, is this good or is it bad? So we can give you really fast feedback loops, right? Rather than thinking about having to deploy it or do like a plan to see if it would work or to apply it to see if all the actual configuration was right, we can just tell you sort of in real time. Now what this does is basically deploys an instance to EC2, right? So it's not all the most complicated infrastructure in the world, but it's very quick to do. I've probably made this infrastructure in System Initiative, I don't know, 1,000 times. It takes me about 25 seconds to just be like boop, 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 boop. If you know what you want, it's incredibly faster than infrastructure as code, right? If you imagine even cutting and pasting a snippet of infrastructure as code to do this and then replacing the variables, like there's no question which one you'd rather probably use. So then when you're done making the architecture, or when you're done with whatever the piece is you're working on, it'll then tell you what changes it needs to make to AWS or to whatever cloud provider or whatever thing is that's sitting underneath it in order to do what you asked. So you can think of this like a built-in plan. And the difference is that we're computing that plan in the hypothetical space as you go. So instead of having to like run the plan process and it takes it and then looks at the cloud and then does the thing, what's happening here is that we're just computing it sort of as you go, and you can specify which actions to take yourself if you want to. So it's a little more iterative, and it figures out the right order, but you can tweak the order. You can decide to put things in or not. So for example, down here, it's telling us it would create the key pair. If you were like, yeah, but I don't really want to create the key pair right now, I don't know why you would decide that, but you could. You could hit that little X, and then it wouldn't actually do it when it comes time to hit the apply button. So then you wang this little button here. That's a term of art, the apply changes button. And what happens is it'll go out and actually apply all those changes to AWS. So it'll go create all the things that you asked for in this particular case. And it'll do it with as much parallelism as the configuration allows. So it's looking at this big graph, and it's going, well, the first two things that have dependencies that don't have any dependencies are the AWS key and the security group. So we'll create both of those. And then in a batch, we can then create the ingress and the instance rule because they require the data from the key pair and the security group, right? The loop is pretty short. So this loop between deciding, like, this is what I want, and then letting the system go see it is pretty awesome. It's kind of, it doesn't take nearly as long as like a Terraform plan would do, or an apply, certainly than a plan apply cycle or a full code review cycle. As a result, when we see people using it, they tend to do things more iteratively. So rather than like in infrastructure as code, you might write all the code and then try all of it at once. Here it's more like, yeah, let's bring the server up. And then you would see it. And then you'd be like, great, that worked. Now let's do this. And then you'd apply it, and then that would work. And then you just keep going as you do it that way. And you're not losing any of the benefits of infrastructure as code. It's all there in the model. You could recreate it if you wanted to. We can cut and paste it, and all that stuff. Okay, that's cool. But if this was all it did, you'd be like, that's fun, Adam, but it's a toy, right? And the reason it would be a toy is because it wouldn't be programmable enough. Because all of you have complicated infrastructure. How many of you feel like you have in your application or your infrastructure or whatever it is you manage, it has something about it that's relatively unique to your problem? Raise your hand. Most of you, exactly. And so in those moments, you've got to be able to go off the rails and color outside the lines. And so we let you do that too, by essentially embedding a programming language. So everything that happens in System Initiative is essentially the result of a JavaScript function, TypeScript function. And you edit them from within System Initiative itself. So on the screen right now, that's the code for the Docker image that we used in the earlier example. That's what defines the asset. So it basically says, here's all the properties, here's all the different ways you should display them, here's how they relate to each other. And you could then create your own. So you can create brand new assets from inside here and then iterate on them and play with them in the UI. You can also add other things. So you could extend how assets work. So you could be like, in our organization, Docker images work this way, not that way. Or you could change how things work directly. All that stuff just works. It's completely extensible by the user. There's really kind of nothing that you can't do. I love this loop because it's a little like small talk or like Visual Basic had like a weird infrastructure-focused baby. From within the infrastructure, you can change how it would behave and then see that happen in real time, which is super fucking cool. So here's an example of adding a qualification. So what this would do is just check that every Docker image in our infrastructure starts with the phrase config management. I don't know why you'd want that, but if you did, you know, maybe you have a rule that's like, we only pull from our internal Docker registry, right? So you could write, what is it, 12 lines of TypeScript, and what it would do is then apply that to every Docker image immediately every time someone used one. And so suddenly that policy would become that little hexagon, right? It would go red, and a developer would be like, pull it from the public registry, and it would stay red, right? Because, and it would tell them why. It'd be like, can't do it. You got to put that Docker image in the custom registry, right? On the right hand here is an integrated test panel. So what you're seeing us do here is take this code, and we selected the specific Docker image asset that's in the infrastructure, and we just tested it. We said, what if we applied this function to this input resource, and it told us it would fail, right? I love this flow. It's so cool. It's so much quicker than having to pop in and out of like writing the infrastructure description and then writing the policy and then putting them together, right? Instead, we've mashed it up so that they all happen together in one place in the same change set at the same time. This is System Initiative's production infrastructure. It was made collaboratively by 3 different people, including Paul Stack. They built it together in real time. So one of the coolest things that I've seen in the last year was we were in Discord and we had the 3 people who were building it all sort of frame. I have 10 minutes left. Thank you. I didn't have to say that out loud. Well, 9 minutes, 40 seconds. Okay. Yeah, so it was collaboratively made by these 3 people working in real time. Each one of them is building different parts of the infrastructure at the same time. So if you looked at their screens, they weren't looking at each other. They weren't screen sharing. They were just working in the application in multiplayer. They could see each other's cursors. They knew where each other were. And they were putting different parts of the infrastructure on the canvas at the same time. And then would iterate really quickly between it. So they'd be like, hey, do you have that subnet group? And he'd be like, yeah, I finished that. And he's like, oh, I got the ECS task. I'll connect them. And so now the subnet group was flowing through to the particular ECS cluster, which then allowed the IAM rules to get written, right? And all that stuff just sort of flew together. Honestly, this was fucking incredible. It was a complete revelation. The last time, I've been a systems administrator since I was 16. The last time I remember working with someone that way was when Nathan Haney-Smith and I worked at an ISP in Arizona, and everything was servers, and we would just sit next to each other and be like, okay, you type this and I'll type that. It was awesome. It was so good, because we've kind of forgotten that you could do it. How many of you have ever collaborated, spent your whole day in collaboration with another systems administrator in real time? Yeah, most of you, which is great. You want to do it more though, right? If you could, because it's more fun with other people. And it really does let you do it. You know, no code review necessarily. You could do it. The apply kind of shows you what the code is. It shows you what changed. But all the same security that happens from pipelines that we now sort of encode and process, we just sort of encode it into the product so it gets out of your way. There was no setup either. So if you think about adding a 4th person, all they would have to do is log into the workspace and they could just start working. Just join the change set and go, which is pretty rad. Okay, how's this work under the hood? You want to get nerdier than this, yeah? Okay, well, that's what it's like to use it, but here's how it works. So basically, it's this big hypergraph whose values are defined by functions. And it's easiest to understand sort of in one dimension, although it is happening in n dimensions. So, you know, basically what happens is we have this Docker image, which is defined by some schema. So it's got like a bunch of properties, right? And you can think of them as a big tree. Every element in the tree is attached to a function. And that function runs in like Firecracker, basically. There's a big Lambda-like execution engine that runs it in isolation. And then takes the value and stores it in that position. So for example, when you type in like, here's the name of my Docker image, we have a function that also sets the image name to the name, because we discovered that almost always when you type the name of the Docker image, what you're really typing is the path that you want in the registry. So we just infer that value. So how that works is you would type in the property root SI name, which is the name of the component. that would then call a function called setString with the string the user passed. That would then automatically trigger another function, which is root domain image. That function gets called setString with the value of root SI name, right? So whatever the name is set to should do it. That then computes the, walks up the tree. So it says, given that value, now go up one level and compute whatever it should be. And in this case, it should be a key in an object, right? So it's going to say the key is image and the value is an object. If I zoom in here, you can see, right? So now that level is image system init whiskers. So then that pops over here, right? Meanwhile, we set the name here, popped up a level. So now the value of this is name system init whiskers, and then it pops up a level, and now it's SI name is system init whiskers. The domain image is also system init whiskers, right? So it's this big recursive function execution machine that understands how to take arbitrary inputs in a giant configuration graph, right? So if you think about prior art and things you could sort of think you could steal from, like this idea that all the configuration is a single enormous graph that can be reactive to its inputs is a good idea. You should steal it. So for something like a qualification, it works exactly the same way. So part of the power of this as a fundamental primitive is that we can build anything this way. So when we want to qualify a given component, what do? Well, we make a function called a qualification. So we build a property, qualification property. It has a function attached to it, which is the code that we wrote earlier in the little editor. And we say that that function should run anytime the domain data has changed. So we call the specific data about your component the domain. And so anytime that changes, we rerun that function. So if we zoom in, this was the function we told it to run. We change the domain image. That eventually rolls up to the full domain. I've put people to sleep. I'm so sorry. And what it then generates is the results, right? So it now ran the qualification, writes the results. We then take that thing out. We can show it to you in the UI, and you move on. So we call it a hypergraph because each change set, you can tell I made this with ChatGPT. I don't have the artistic skill to actually do any of that. But essentially what happens is each change set allows you to set new values in isolation. So it'll carry over from what the values are in head, and then it'll push them to the back. So we keep track of all that stuff over time, right? So that you can actually, hypothetically, have a bunch of different versions of the infrastructure all at once. So when we say it's a power tool, that's what we mean. It's literally that you can model anything you want inside of it. You can customize anything you want with it. You can extend the system in all sorts of new and interesting ways. The world is, in fact, your metaphorical oyster. So honestly, it takes everything in my power not to do what Drew Barrymore is doing right now. I can't cross my eyes. But like, I wrote this thing and I've been in the game a while, and I know that I'm supposed to be demure. I'm supposed to be like, it's pretty good. You should take a look at it. It's fucking sick. It's fucking amazing what this thing does. It's so cool. And look, it's not like perfect yet. It's got shenanigans, and I'll go through them here in a minute. And like, it's gonna take a minute to make them perfect. But what this thing does, it's the best fucking art I can imagine making. It's so good. It's yummy. It's yummy and delicious. And today, it's the worst it will ever be. It's only gonna get cooler. And I freak out all the time. And it's like a problem for my family. You know, like I walk in and I'm like, it's so cool. Look at the thing they made it do. And they're like, could you shut up already? And I'm like, no, because I'm vibrating with how cool it is. It's so cool. I'm so excited for the future. Thank you for letting me indulge. I promise next time I'll be demure. Was that 10? I'm being like pulled off the stage.
No, you're not kicking
Oh,
off yet.
okay.
You have time for questions, but you're not.
I'm not done.
Oh, Jesus.
Although that's a good ending. Look, I'll skip to the end because I'm clearly being yanked off. Look, there's sharp edges. Let's go a couple. Performance isn't where you need it to be yet. There's not a ton of integrations. There's only 56. They're all AWS focused. People hate ClickOps, so they see that visual composer and they're like, this thing's a toy. It'll never work for me. I hate your stupid face. I get it. I do too. It's not ClickOps, but it is better. It's much faster. You should try it. And it's very much early adopters. And so if you try to use this thing and you don't know what you want or you don't understand what's happening, it's probably going to cut you. But you're in this room, so you're probably in the group that it's fine. Similar art, there's a thing called Brainboard, which generates diagrams from infrastructure as code, has some multiplayer stuff. AWS has a thing called App Composer, generates HCL for not even. It generates CloudFormation for you. And then Mass Driver, which is another thing that basically says you should do this, only it should be a developer portal. So it's like basically you take all the stuff you would normally do, you slap a developer portal on it, but it gives you a UI that kind of looks like a diagram. Yeah, okay, look. Possible future research. What else can we model? We can model anything in System Initiative. And if you think about everything being a reactive graph and what that means for the changes in your workflow, it's super crazy. So like, what about your build process? What about CI/CD? Why do we have a pipeline? Don't really need a pipeline. I could just detect when the code has changed, and then I could react and call another function, which compiles the code, which then runs the test, which would sort of be like a pipeline, but might be better. Different views for different things, right? So security, compliance, cost, telemetry, all that stuff could just be functions. Health checks, what's monitoring but a reactive function to the state of the outside world, right? So that's cool. So look, thank you so much for listening. I'm so glad that you're here. I love being here. I love talking to all of you about it. Please come talk to me about the art that you think is amazing. And I hope that you feel a little inspiration from these examples and we find some more. Thank you so much. I want to leave you with this Rick Rubin quote. He said this as I was getting on the plane, and I thought it was the perfect ending. Art isn't in the tools, material, or equipment you use. It's in the way you see the world. And so if you want to make great art, what you have to do is constantly look at the world and bring in those inputs and make cooler stuff because of it. Thank you. Now I'm done.
Thank you. I thought you were doing great. Thank you, Mr. Adam. We're going to all vote. Should we give them some chocolates? All right. Chocolates anonymous. So we have time for maybe like one demo. Really quick. Question or demo, yeah. Every day, I mean, for the whole conference, I want you to
We'll be here.
Hey, are you Mr. Adam Jacob? Can you please do a demo next time? And if you all do it, it'll be a huge D.AUD, so it'll be very funny.
Okay. Okay, here's a quick demo. Check out cut and paste. Control C. Control V. So what's cool about that, now think about the production environments Keith showed you earlier. So what it would do is strip the resources off the end. It'd be like, oh, this is a new thing. So it's not the same as the thing you had before, which would then allow you to say what it needs to do is create a brand new one. And then it would automatically go red because, for example, like you'd be reusing the same subnets. And so it would just go red and be like, oh, don't do that. You better change those. And so once you tweak them and they turn green, now you have a production environment. Ta-da! Okay, is that my time?
Thank you again. So now I have the pleasure of introducing one of our co-organizers, a fellow with the coolest hair and feet in the conference, Mr. Ben Ford.
Okay, we're going to do Ignite now, so anybody who's given it Ignite can come down this way, make it move quickly. I don't want to go too fast, we gotta get things set up here. But our first Ignite is from Tim over here, and he's going to talk about Voxel Light, which if you don't know anything about Voxel Light, if you've ever been in a public ecosystem, you know who Voxel Light is and what they do. Tim's going to talk about that. But because he doesn't brag about himself, the thing that he's not going to tell you is that the energy behind Vox, the energy that makes it happen, is all right here.
You want to be part of the internet? Then you have to be wired. So.
You want to hook it up?
Yeah. Can you hold this one? And you are in a row, eh? Of few people.
Yeah.
Can you pass it on to the next one?
Probably.
And, right.
Good idea. Okay. Hello, everybody. So I'm Tim, as Ben introduced, and I would like to talk to you today about Vox Populi and give you a short community update about what Vox Populi is and what we do. So I go by BusterFreak on the internet, and you might have seen this picture if you are active on GitHub. I might have responded to one of your pull requests or issues. And I'm active in the Puppet community since 2015, something like that. So Vox Populi, what is it? It's a big group. We maintain 178 Puppet modules at the moment, which is even more than Puppet or Perforce itself. So it's quite a big community. Everybody of us tries to be very helpful and polite to each other, and we try to be open-minded to new technology, to new people, to build a home where everybody feels welcome. And together we try to provide a home for orphaned Puppet modules, and we try to form a collective of many, many people so everybody can work together and no one has to work on their own on software. Every time we do a talk about Vox Populi, we try to measure the number of our GitHub contributors. At the moment we have 211 people with merge access in the GitHub organization, and it's growing quite good. Last year at Config Management Camp we had only 186 people, so there is quite some growth. Who are we? Most of us are system administrators, work in a company maintaining a local Puppet stack and trying to contribute upstream so no one has to maintain stuff on their own internally. Also, some of us are consultants that patch Puppet modules or related tooling for some customers and try to bring the patches back upstream. And another group of people are domain-specific experts that might not have much knowledge about Puppet, but are experts, for example, for RabbitMQ. And we talk to those people, and together we try to write proper Puppet code to automate the specific software. And some of the people also work for Puppet or no Perforce, and yeah, we work along, and together we maintain a big part of the whole Puppet ecosystem. How do we do this? We have a big CI pipeline that is split into multiple pieces. The first is Vox Populi test, which is a very big Ruby gem, and it provides you boilerplate code for running unit tests and static code validation. The next one, Vox Populi acceptance, allows you to run BK acceptance tests for your Puppet modules. And the third one is Vox Populi release, which allows you to, well, make releases of your Puppet modules in an automated way with your pipelines. And all of this we put together into a reusable GitHub Action workflow. Last year we had a 1-hour talk about all the details about this, which was great. And you can check it out, use it on yourself. Since last year, we finally accept donations to boost our community, which is also working quite well. We get $220 to $240 every month from different nice organizations. We use the money to buy some kind of swag, for example, Vox Populi stickers or the nice foxes that you can see on the background of my slides. And if you want to have some, please come to the Puppet Dev Room after lunch. And a key part of the success of Vox Populi is that we have a very scalable and fast pipeline that everybody can use. To make this happen, GitHub is sponsoring us. A lot of concurrent CI runners, also Hetzner Online is sponsoring us CI resources, but that's not enough, so we pay for additional CI stuff to make it even faster and better. And in the future, we would like to make small meetups, small conferences, and maybe pay for people that are unfortunate to have a company that pays for their own conference trips. So I think that sounds quite awesome. You would like to participate. How can you do this? Of course, you can give us your awesome corporate money, so Vox Populi grows even more. But you can also contribute through code, check all the open issues that we have, check the open pull requests that we have on GitHub. Or you can also come to our IRC channel or our Slack channel, both are bridged, or meet us in the Puppet Dev room afterwards. Thank you very much.
Just trying to fix a light thing.
Trying to get rid of the flicker back there.
Yeah. Joe, is it fixed?
Yes, you are. That's it. Okay. All right. Now, as we're shuffling things around, Bram Bogar is our next speaker. He's going to talk about service level objectives and responding to outages. But I just read the other day that somebody had ported Doom to run on a bacteria. And one of the neat things about Bram is he started his career as a molecular biologist. So that means that you might be responsible for this shenanigans.
I'm not, but I could have been.
Here, I'll just stick it in there.
Self-service? Yeah. Right. So monitoring, probably all of you have seen most of one of these, big screens with lines that go beep bop, and you have to be very, very close to actually work out what's on them. This is how we, hopefully used to do monitoring. We build that one massive dashboard for someone to sit in something called a NOC, to stare at these screens for 24 hours, basically, with the question, is it broken yet? Is it broken yet? No, it's not broken yet. And that's how we got to the point that we really started to care about the 5 nines. Nobody actually, you can look up what it means, but it basically means it can go, your thing can go down for a couple of minutes a year. Then, of course, what the thing is undefined, because we're building all kinds of very, very complex systems, so it's actually more of a murder mystery than we can conclusively say we're hitting these 5 nines. So what actually happens when the thing broke on the screen or the line didn't actually do what it was bebop when it was supposed to bebop, the grumpy bastard operator from hell was sent into the dungeons of the basement, and he would have to look at the actual servers. And the problem was, he actually only knows, if you look at this pyramid, if you want to understand your system, you need to understand all 3 layers of the system. And the bastard operator from hell, it only does the system, so he actually knows, is my CPU doing what it's supposed to be doing? Are all the lights lighting up on the rack? And he basically came up with a pattern called red or use, depending on who came up with it at the same time. That's basically, okay, are we looking at utilization? Is my concurrency still doing what I'm supposed to be doing? And in the end, it all boils down to the 3 pillars of observability, right? Can we actually see what's supposed to be going on? And everybody that has a 3-year-old at home, just like me, if you have 3 separate pillars, it's not particularly stable. So what you actually want to do is have some form of tensegrity in the system. All 3 need to be up for us to be balanced, to actually see what's going on in the system. So we need more. We need logs, traces, metrics. But we're gonna zoom into a bit more about metrics, right? This dashboard I'm showing you right now actually tells me a lot more information. The system is up. There's actually people shopping at my thing instead of the 900 lines that you were seeing so far. You can even go a bit further, where you can go, we combine data information, right? Why am I seeing a peak in things or a drop in things? It's Christmas. We're either shopping a lot more or we're not shopping. And here I combined, the marketing is actually doing something. And what we're building this all up for is we need to not only get logs, traces, and metrics in balance, but we also need to balance our dashboards and alert, or mostly alerts, right? We want to be alerted to the thing being broken. And we came up with 3 definitions. We have a service level agreement. That's basically the contract we have. We say we're going to be up for the 5 nines, whatever the 5 nines means. And the SLO is the wish or the hope. We're going to get close to keeping it up for that long. And the SLIs are basically what the things we're measuring. And setting SLOs is a business decision. So we actually have to start talking to the business people, although we're supposed to be doing that, but a lot of the times if they're hard to find or they're hard to pin down, especially getting them to define what the thing is that is broken. So we need to start visualizing like what they care about, and that's usually revenue or number of sales per minute, number of sales in total, you know, people signing up. Or when you have an API, it's the API calls that you're seeing. Or, you know. So when we switch back to this pyramid, we actually need to work on the top 2 things for us to get true value and a definition of the 5 nines. So people will need to ask people to start implementing their code. Like, it's no longer an ops only party. We need to actually get developers to instrument their code. And what that means is they need to emit these signals. Like, it's very hard for an operations person to work out how much sales we're doing. Like, we can only see, you know, CPUs doing what it's supposed to be doing. So if we turn that story to what we want, is actually only alert on these SLOs, the things the customer team cares about. Still do hard disk as well, and that's how we get to the 5 nines, right? If we see sales dipping, that's when we start running. If a backup fails or if a CPU goes above 80, that's literally its job. That's what we pay a CPU for. So what we actually care about is if we're not going to hit these SLOs, and that's actually what you graph on, and that's what you alert on, right? We're going to miss the 5 minutes of downtime this month. Like, you need to start running. Like, it's what I said, if a backup fails, I don't care, 9 a.m. tomorrow morning, a Jira ticket that, make me a Jira ticket that I'll ignore for a couple of days. And that's the end of my talk. Thank you.
Can't forget the all-important chocolate. Okay. Next up is Dylan, who is probably one of my favorite people that I've ever had the privilege of working with in the past. He understands that Venn diagram of technology and people and business needs like nobody else that I know. But today he also gets the award for coolest corporate t-shirt. Can we call it corporate or? Yeah.
Thank you. I use both of these.
Up to you.
I can just use this one? Both.
One's for stream, one's for here.
Okay.
Let's restart. There we go. Let's restart.
Oh, yeah. Yes, please.
You ready now?
Ready. Okay, so I'm going to basically try and repeat Patrick's talk in 5 minutes, so you'll forgive me for having notes here. Who here's heard of a show called Trapdoor? Shit, not many. It's a show that, other than fueling a number of my formative childhood nightmares, was about a blue blob named Burke, and a disembodied voice called the Thing Upstairs, and a trapdoor that was filled with horrible, terrifying creatures that were waiting in the dark to get out. But before we can open the trapdoor, we need to arm ourselves with some knowledge. So get out your bingo cards. We're going to be talking about vector databases and LLMs. Vector databases, as we heard before, they're a type of database that doesn't have a query language. Instead, we query using natural language, and we get results in a way that understands context. It does this by taking your text and converting it into numbers, which is called a vector embedding. To visualize this, we've created a really simple vector embedding model for a real estate database that outputs 2 numbers, the number of bedrooms and the likelihood to be haunted. Then we fill our database with real estate listings, and we plot those vectors on a graph. Then if we want to search for the 1980s British claymation show Trapdoor, we look at the number of bedrooms and likelihood to be haunted of that television show, plot it on the graph, and then return everything that is close to it on that graph. Now, the real ones are a little bit more complicated than this. They use something called cosine similarity rather than Google Slides, but you get the picture. The next thing we need to understand is LLMs, large language models. You've already had this explained to you by someone smarter than me, but I'm going to keep it brief. They're weirdly human in that they make mistakes. They try to impress people that they don't know. They lie. They even get seasonal affective disorder. I'm not joking. Results get worse in December. What matters is, and the other thing is that they are not just the sum of all of the stuff they were trained on. They're both more than that and less than that at the same time. They can come up with things that are correct that it wasn't trained on, but it can also completely forget something that it was trained on, much like a human. The thing that's important for us is the way we interact with them. We give them a prompt, and then which is text, and then it gives back some more text that tries to answer that prompt. That's it. Text goes in, text comes out. So to summarize, we have the thing upstairs, which is a lazy, disembodied voice that gives commands. We have that's the prompt. We have the LLM, which is Burke, the helpful assistant. But this was about documentation, this talk. So the only things that are left is a sentient skull, a very cute spider, and a trapdoor filled with horrible, horrible monsters. I wonder which one's the documentation. Yeah, you bet it's the trapdoor. So documents and diagrams and incident reviews went in there and they got ignored, and then they started making sounds and staring back at you, and only the bravest, most senior engineers can wrestle the Confluence search syntax to find the one piece of documentation that happens to be relevant to the thing that is happening right now. And you've tried to tame it, but it's got a life of its own. So using what we've learned, we can tame it. Firstly, you dump all of your documentation into a vector database. It does the thing, it puts it on a graph. That gives you a really, really good search. We also have the LLM. The LLM is good at understanding documents, deciding what's relevant, summarizing. So how do we integrate them? Well, it is laughably simple. First, we take a question from a user. We give that question to the vector database. The vector database returns some documentation from our internal docs that it thinks satisfies that question. Then we start combining this into a prompt. We create a prompt that says, your task is to answer the following question. User's question. Use the following information from our internal documentation to answer that question. And then you paste the results. If you don't find anything in there, do not make it up. You may have to reiterate that. Really, really don't make it up, because it will try. And then you send that to the LLM and you get an answer. And that's literally it. That's how these things are being built today. There are some smarter things, which you saw, but it's literally you paste some stuff into some text and you send it to an LLM, and that's it. And it's very easy to use. You can definitely get started with it today. We've been playing around with it. We've had an LLM tell us in CI as part of a pull request that you've made this change before, and last time you made this change, it caused an outage, and here is the outage report. We did that in a couple of days. It's pretty cool. You guys have better internal documentation than we do because we're a small company, so feed it into this sort of thing. It's definitely worth trying.
Nicely done. And here's your chocolate over here.
Thank you.
Of course. Next up, Felix Frank is going to talk about green technology. Felix is probably, I think, one of the most brilliant and creative people that I know in this industry. But the interesting thing about them is that every time I run into you at a conference, Felix has always just come from an EDM dance party. So if you ever need, have this pressing, urgent need to get your dance on, this is your person to ask.
That's one hell of an intro. Okay, let's go. Yeah. Yeah, hello. Wow. Usually I do a funny intro at this point, but not today. We're getting right serious. Let's talk about climate change. And yeah, I'll lay down the most important facts, I'll add some opinion, and then I make a couple of suggestions. Okay, let's just go. When you hear talk about climate, there will be some numbers
floating around like 1.5 degrees, 2 degrees, 3 degrees. What these are global average temperature compared to what it was before industrialization, where 1.5 degrees globally has quite an impact on a lot of ecosystems. 2 degrees, a lot worse actually, and past 3 degrees is just catastrophic. And the science community has known that for a long time. And like 10 years ago, lots of nations in Paris agreed that, yeah, let's put an upper limit on the warming, let's do whatever we can. But not a lot has happened outside of just progress, I suppose. And where we are right now, to even have a chance to make the 1.5 degree goal, we would have globally stop burning any fossils by 2030 in 6 years. So speaking of mind-boggling shit, this is some data of 2023 in the red lines, and the gray lines are previous years. And these are like surface temperatures and the amount of Arctic ice at different times. And 2023 is pretty much an outlier, let's say. On the bottom right, you have the amount of forest that burned in Canada over time. So yeah, speaking of really spooky graphs, this is the sea level rise since 1900. It's a solid 20 centimeters. And yeah, the more recent trend is pretty much accelerating, looks like. Yeah, so I don't know about you. I find all of this quite concerning. Although the thing is, most of us hailing from like Northern Europe, North America, we are not facing death and suffering anytime soon. But people in other geographies are, like right now. For example, this is a table of, it's a bit older. It's the largest rice exporters in the world. And leading up to 2020, their numbers were dwindling, like harvests aren't so good anymore. And in fact, the largest exporter, India, last year they banned all rice exports. That's how bad the harvest was. They need the rice for themselves. So our basic foods will be less available and more expensive. Those are just the facts. And yeah, even if we manage to have a really significant change soon, then probably we are still just looking at a 2 degree goal, which is bad, which it will suck, or whatever happens. Why is it so slow? I think one of the reasons is that world governments have this tendency to lie to themselves and pretend like, oh yeah, we do some trading of certificates and offsets and what have you, and all it's doing, it's just delaying the change that needs to happen. They also tell lies to you, by the way, like the carbon footprint, huge hoax, look it up. Your personal consuming choices are pretty much insignificant compared to this global, huge capitalistic machine that just tries to grow and grow and will destroy anything in its path if that's what happens. So what we need is policies, is laws. It's not like your personal choices. So what can we do individually? I guess most of us are still in a pretty privileged bracket. We have a lot of resources, so maybe you can make business choices, like see where you put your work and your energy. Maybe you work for a larger corporation, and then maybe that corporation can cut time out of every employee's calendar to let them on the clock do some activism. Because I firmly believe to affect policy, to have an impact on the laws and on the way that the world works, is we take the streets. And if you are not personally comfortable with gluing yourself to a street or whatever the hell is going on around you, then a thing you can definitely do is support people in marginalized communities, because the folks in the margins of society, they will suffer the worst from what's to come. And if we share those resources, if we share the privilege, it can make a world of difference. So there we have it. Let's make it a discussion. Find me on social media, find me in the hallway track. Let's commiserate in climate anxiety. And yeah, if you need some input on how you can maybe possibly help, I maybe also have some suggestions for you. Thanks.
Thank you so much. What an very, very incredibly important topic. Next up, we have Mar, who is going to teach us in just a couple of minutes about JET. On Mar's next article, I found a really nice quote from Albert Einstein that I love. It says something along the lines of, "I have no particular special talent. I'm just passionately curious." And the neat thing is, I think that applies to every single one of us in here.
Cool. Thanks for quoting again, Einstein. Hello guys, this is my first time at config management and I probably will come back. This is my short talk about JET and Ansible. So there's like a little wordplay. I come from SVA, Systemvertrieb Alexander, from Germany. And yeah, let's go on. So has anyone ever heard of JET before? JetPorch? Ah, cool, okay, some. So yeah, it was founded by Michael de Haan, or created by Michael de Haan. And he was also the founder of Cobbler, Funk, maybe some people know this, Ansible, I guess so, and OpsMob and JetPorch. Spoiler, it was discontinued. So what is Ansible's initial success based on? Well, timing. It was really needed at that time to have an easier access to a way to configure. Documentation was great, was many early adopters and visibility in the scenes in the community. JetPorch stands for Jet Enterprise Professional Orchestrator, and it was is created for Apple systems and Linux systems, and you can install it either from source or with Rust. This is actually for the people who want to watch the video later on. You can take a snapshot or just pause the video. These are all of the ones, and I will talk about some of these features. Many will look very familiar to you. So yeah, the basics by Jet. Of course, you start with a playbook, you have it in your Git, and you write it in your YAML, which Jet uses a specific dialect of YAML. And then you have your control machine, then which configures the hosts, which you have configured or defined in your inventory. Playbook syntax looks pretty much the same. As you can see, we got groups, keywords, task handlers, and different roles. So as an Ansible veteran, or how do you say this, like someone who's very proficient, it should not be very new to you. Here's like a very basic playbook. You can see the structure, and you got here, for example, the groups, which are defined in the inventory, for example, and the tasks. This is another example where you use roles. So if you look in the middle or on the bottom, and from the get-go, it's pretty much very adaptable for Ansible users. If we take a look now onto tasks, you see that there's on the first line, there's a module call with a YAML tag. This is kind of different, and this is part of the syntax in Jet. However, it does pretty much do the same as the way you do it in Ansible. And here we got variables, for example, where you have this location, the path defined. However, in Jet, variables are processed by Rust handlebars. So I'm not very proficient in Rust, but it's pretty cool, I guess. So the question is, it's not this is the same picture. And corporate says yes, but maybe some users would say no. There are differences. So some of them are here listed in 1 second or two. So it's written Rust. It integrates for other programming languages. It was Michael de Haan's idea. That's more open to other developers. It does use templating through Rust handlebars. It can be used agentless or with an agent, and it should always be community-driven. And it had on the roadmap this idea of a so-called planetary scale. So the idea was that you could like scale this up like exponentially. However, this was not realized because what happened, Jet ended very early, very suddenly. So one day before Christmas, he announced the end of the project. And then beginning of January, the blog entry, which with the announcement was gone, the project page was gone, the source hard repository was gone, and Discord was only on read only. What happened? Short version is he said, I just stopped. But there are two reasons that make sense. The first one was that the echo, like the feedback, was not that big from the community. And the second reason was he had no personal usage for such a tool. So Michael de Haan pretty much said bye. This is a meme by my colleague, Niklas Werker. He has also a talk today here. Please visit him. This is his idea. I think it's on point. So anyways, yeah, jet est mort, long vie au jet. Basically means jet is dead, long live jet. So what do we do? The repo is, there's a mirror repository on GitHub you can use. So it's not really dead. Of course, it's open source. We can pick it up. And should we actually pick it up? Is it actually needed? And I would say yes, yes, yes. Not because Ansible is broken or anything, but it's always good to have a competing idea. We should never opt into monopolization of things. If they run smoothly, that's good, but it's always good to have like different ideas coming up. Thank you for your attention. That was very nice, and talk to me please later on.
Cool.
I think it's stuck.
Cool. And now carrying on the topic of green technology, this is part, if you want to chuck that in. Aaron is going to talk to us about how your chip architecture can save you energy and save the world.
You have 3 A's for my name. Oh, okay.
Yeah. Now, I have a question for you though.
Okay.
You worked at SAP for a very long time, and Adam asked how many people had tried automating the install of SAP, and your hand did not go up.
I was very strange at SAP. I was a Java developer, and then helped create their IoT, and then I ended up running their makerspace. So anything that you have problems with SAP stuff, not my fault. I didn't work on it. I don't know ABAP. I know very, very little. So I worked for a company for 13 years and never used their core product, yes. So I was either the best SAP employee or the worst. Yep. Hi, my name is Aaron Williams. My title here is Change Your Architecture and Help Save the World. As we heard before, global warming is happening. DCs, data centers, as you all know, use a ton of energy, about 6% of all US stuff in about 2019. That number has gone up. So we have to do something about this. One of the biggest things is that it's x86. This is a legacy architecture. It was built 50 years ago. In the last 10 years, it's just faster, faster. There wasn't the stuff around global change and things like that that were needed, or climate change. Anyways, the nice thing is at least some of the big companies that do x86 are talking about it, but they keep talking about it as the next challenge, something like that. And they even, hey, this is a change. They say over the next decade. Yeah, why don't we change that? Let's fix it. We can't wait a decade. We must do it today to make these changes that help keep us alive, basically. Before I go on, let's define some terms. Performance, that's flops. Everybody knows that, but we're going to start introducing new ones. This is performance per watt. This is how much performance you can get per energy, or and then the next thing is performance per rack. That's the next new one. This is how much performance you can get out of one rack, because if we start building more and more racks, have to separate them, things like that, you end up with having to build a new data center very quickly. One of the simplest solutions here is just create cleaner power, right? Let's throw windmills up everywhere, solar, geothermal, things like that. These are very great. We need it. We also need it for our housing and other things like that. The next one is that, it's a short thing, so I'm only going to do 2, is immersion cooling. This stuff is really cool, or at least I find it fascinating. Put the servers in liquid that will boil around 120 degrees Fahrenheit, 50 degrees Celsius, and so therefore you can keep your things a lot cooler. But you still have to build out the solar. It's going to take a while. You don't instantly go up and put up, these giant wind turbines and things like that to get the energy we need. Immersion cooling, this is servers in liquid. This stuff is made with permachemicals, things like that. Do you really want a boiling liquid in your data center? And it's a kind of a little limited of how much you do, how many things you can put in there, and do you need a plumber on staff? Well, apparently, this started off as a joke. Google proved it true. Basically, they had a big leak, things failed, and they burned down their data center very, very quickly. I don't mean to laugh, but it was, like I said, it started off as a joke for us and went, oops. Anyways, quick recap here. So background, data centers use way too much energy, but yet we still need that more compute. We always are going to. Now, haven't we already solved this? And if you think about it, the problem statement is simply we need a way to do high performance compute that is energy efficient. We kind of already solved this. I come from mobile and IoT worlds. You can't have huge energy out there. So what's different? Very simply, it's the architecture of the chips. The chips were made, they're ARM64. So hey, use a lot less energy in them. Why can't we put that in servers? Well, we did, and we're one of the largest suppliers of this. So what we're going to do is a quick little example here. We're going to think about 1.3 million requests per second. And if you notice, the ARM64 chips need a lot less servers. And the reason for that is the high density core count. They will perform well. The AMD ones are more efficient than Intel, so that's at least a little bit better. And then this happens as you kind of multiply those numbers out. How much can you get in there? Now, for the racks here, this is the best case scenario for everybody. This is really dense, one after the other. We're pretending that heat doesn't go between them, which if you've ever been in a data center, you know that's false. But anyways, you get the idea here. What you can do is you can get so many in there, or so many more servers in there. But I always get this, but hey, what about? The tooling's not there. Yeah, actually it is. You probably haven't looked in a while. Most of it's already there. And the last thing here that's really important, as people in this room, what can you do, at least in this little bit, is make the recommendation. Odds are your CTO doesn't care. They just want things up and running. And if you can save them some money, energy, put more compute in your data center, hey, that's awesome. So what's next? What can you do? All these places, all the major data centers, cloud providers have ARM64 stuff, and then join some communities. One is ours, the other one is ARM's, has a server Discord for that. And that's about it. I can take questions. No. He's like, get off the stage.
No questions, but you can take chocolate. Next up, D.AUD is going to give us a cautionary tale of the dark side of open source. I'm very curious to hear more about that. Also, I should have a confession to make. When I'm looking at the schedule for conferences, I always like look at people's bios because I'm always curious about how I can improve my own. And when I read yours, I thought that it said you were a motivational speaker, and I was really disappointed to see that it actually said international.
Great. We're good to go? Okay, so I couldn't resist the urge to tell you, told ya. After someone teased me from the organizers, I won't tell you who. So we all got this very lovely surprise back in the middle of our summer holidays, back in August. You all remember this one. HashiCorp announcing relicensing Terraform from open source, MPL, to a non-open source business source license. Yay. And also, obviously, not just Terraform. It also happened to the rest of its lovely projects, Vault, Console, Nomad, and so on. And who of you did it catch off guard? With a show of hands. Okay. So it shouldn't have. Because actually, last year, on this very stage, thanks whoever took this tweet back in the day, I was here actually telling all of you the case study of Elasticsearch going from open source to SSPL, non-open source, source available. Sounds familiar? So we talked back then about the rage, we talked about the response, fork it, and we talked about the risks of vendor-owned open source. So we've been through that, and by the way, you have a QR code about the open source risks. Okay, so you're a wise guy, you told us, we understand that open source can turn to the dark side, but what can we learn out of that? And the first thing I want you to take out of this talk, if there's only one thing you take, is remember that open source is more than a license. First of all, we saw that license can change under our feet, and it can happen also to very veteran, successful projects over a decade old, okay? There's no guarantee in that. And also, remember that it can turn to the dark side in many ways, okay? It can go non-open source, it can also go copyleft, it can also change terms of service, like it happened with a Terraform registry, and many other forms, okay? Many other forms there are. So, how can we protect ourselves? And that's the most important thing. So I'm going to share with you very quickly 3 tips for selecting open source wisely, 2 tips for using open source wisely, and 1 for building it. Okay? So let's go and start with using open source wisely. And first one is ask yourselves which license. Remember that not all of the OSI licenses are born equal. There's copyleft and other semantics. And also, very importantly, source available is not open source. Okay? Remember that one? Very useful new resource that the OSI released is a database for all the licenses. So if you're not sure, go opensource.org/licenses. Very useful resource. Next tip about selecting open source wisely. Ask yourselves also who's behind the project. Is that a single vendor? We saw it can pull the bait and switch stunt on you. Also, avoid the single maintainer thing, even if it's not a vendor. It's a single point of failure. And in general, remember that foundational open source is a good path. I know I'm a CNCF ambassador, so I'm biased, but Cloud Native Computing Foundation, Linux Foundation, Apache Foundation, all of these provide a vendor-neutral ground. They provide oversight. They provide governance. Very good setup. Talking about governance, ask what's the governance policy of the project you're looking into, okay? How can they determine that no single entity grabs control? How can you turn into committers to maintainers? How can you be promoted? How can someone change license? Who can change the licenses? Let's talk about using open source wisely. First of all, manage your third-party licensing exposure, just like you do with security exposures, okay? Apache license containing GPL or things like that. That's one. Second tip for using, take care with automation. We all love automation in this conference, but beware of auto-updating your dependencies without safeguards, without license compliance checks, okay? SBOMs, maintain SBOMs, that's a very good tip on this one. Now, one tip about building open source wisely, remember, open source is not a business model, okay? Make sure that you have sustainable business model around your company, otherwise you'll find yourself in this contentious situation. And I talked extensively about that in the article about the vendor-owned open source, so check it out on the right-hand side, and on the left-hand side you can find actually the cheat sheet with a checklist about the bullets I said, some additional bullets, so a very good checklist to go over. I haven't had the time to deep dive into the OpenTofu and Terraform and all of that, but here's a link to my podcast, Open Observability Talks. I dived into all this episode with one of the creators of the OpenTofu project. Very interesting discussion, and we have the discussion also after lunch with Sebastian, so check it out. You can find me everywhere at Horowitz, as you can see. So I'm Dotan Horowitz. Thank you very much, and may the open source be with you.
Thank you, Dotan.
Before lunch, so don't leave yet. You can get a free book if you stay. So we have Track as a sponsor. So we have 5 books for today. There were a lot of hands for people who were here first time. So if you're here first time, put up your hand. Who wants this book the most of the people with their hands up?
You didn't even say which book.
Well, it's Infrastructure as Code for Beginners. That's why. It's only for first timers. Thank you.
Thank you.
And then you have the next one is the Linux DevOps Handbook.
There's no trash can. We should have given that to Patrick.
Yeah. The next one is DevOps for Databases.
a speaker here.
No, give Mar the practical Ansible one.
Well, no, you should get this one, practical Ansible one.
Okay, thank you.
Oh, you troll. You troll.
I still have a database one for you. Okay, thank you. That's on behalf of PACT, so if you like books, go and visit their website. And then there's lunch. So you go out here, you go straight, and it's the last door. You'll see a bunch of people there already. If you're a speaker, please jump the line. If you're a speaker after lunch, everybody else just take your time. You should have enough time.
part of the ecosystem is represented, and like as we all know, like there's been a shift, let's put it, and I'll let the speaker talk about this, to have the Open Tofu Foundation and the Open Tofu work. So I'm absolutely delighted to introduce Sebastian Stadl. He's the CEO of Scalar, and he's one of the founding members of Open Tofu. So there's no one really better to come and give a talk about this type of stuff. Please ask lots of questions. He has brought a face shield in case he's brought potatoes, but like keep them because we don't want to waste food. But enjoy the talk.
Thank you.
Welcome, Sebastian.
Thank you for the warm introduction. So first of all, sorry, I apologize that the logistics of the event have changed. Originally, we were supposed to have four talks on Open Tofu. There's a little mishap with the speakers that they couldn't fly from Israel to make it. So instead, here I am. I apologize for the regression there. But I promise next year will be a lot better with a full track and lots of great talks, and not just me singing and dancing here. So before we get started, raise your hand here if you already use Open Tofu. All right, a handful, that's encouraging. Raise your hand if you're planning to use Open Tofu. Yes, that's awesome. And raise your hand if you're not planning to use Open Tofu. All right, well, you now know who to talk to convince. Awesome. All right, so I'm here to talk a little bit about Open Tofu, answer your questions, and clear up some of the misconceptions, and just overall just evangelize the work that the community is doing. So I'm going to be talking about what Open Tofu is for the few that don't know, why it matters, the progress we've made on the project. I'll talk a little bit about the contributors behind it, the community behind it, how to contribute. For those that are just getting started, little cheat sheets on how to do that. And then I'm going to elaborate on what's next for the project, and then do a Q&A and answer all your questions and dodge all your tomatoes. All right, so a little bit about me. I'm Sebastian Stadl. I'm one of the core members of Open Tofu. I'm also the CEO of a company called Scalar, which makes commercial products for both Terraform up to 1.5.7 and Open Tofu. All right, so what is Open Tofu? You might have seen this meme circulating. I love it. Essentially, it's a fork of the last open source version of Terraform, 1.5.6. We backported 1.5.7. And the way to think about it is 1.6 is the first release of Open Tofu, which is binary compatible with Terraform. So it looks a little bit like this. It's a declarative model for managing infrastructure. And so this is one of the parts that I want to stress. Open Tofu is compatible with all of the plugins and providers out there. So we don't need to fork all the providers. We don't need to make copies of them. If you are the author of a provider, you don't have to make a second one just for Open Tofu. One of the core guiding principles of Open Tofu is maintaining compatibility with all of those providers. So there, in addition to that, we're 100% compatible with all of the modules out there. So all the code, all the modules you've written already for Terraform work out of the box for Open Tofu. And if by any chance you see any problem with that, a provider that works in Terraform doesn't work with Open Tofu, or a module that does and doesn't, let us know. We will jump on that and fix it straight away. So far, we haven't seen any such case, but we are very dearly committed to making sure that the transition migration is seamless. Finally, sadly, HashiCorp has also changed the license on the Terraform registry, so we created an Open Tofu registry, and we have great plans to expand on the functionality there. The plans aren't solid yet, so I won't speak to those specifically, but if you go to GitHub and you read some of the issues that have been posted there, you'll be able to find out a lot more. All right, so Open Tofu and Terraform in general, infrastructure as code even, matters a lot to me. The reason why, with everyone, with the community, we forked Terraform is very different why some folks forked other HashiCorp products. For us, Terraform is first and foremost a language that we've based and built an ecosystem around. Less so of a product and more so language. And so as a result of that, it's really for us a foundation for all of the infrastructure management and a very, very important part of DevOps and us building the plumbing of the internet. And as a result of that, it's really, for a long time, we've been a little bit frustrated that, that Terraform was sure open source, but it wasn't openly developed. There's a lot of PRs that got rejected, a lot of really quality contributions that never made their way into Terraform. And a lot of that is because it competes with the roadmap of Terraform Cloud or Terraform Enterprise, and so there's a lot of conflict of interest there. And so when HashiCorp decided to relicense future versions of Terraform to the BSL, that provided the impetus for all of us to finally do something about it. And the Linux Foundation was very receptive to the project, and they reached out to us. We had some good conversations there. And then we decided that we would fork it and that the fork would live in the Linux Foundation. For those who don't really know how the Linux Foundation works, they provide a really good governance framework for how to govern large-scale projects. And they provide, that governance framework provides like a technical steering committee to resolve differences that always occur when you have contributors from different organizations contribute that might take the product or the project in different directions. And so the Linux Foundation really provides a governance framework for long-term longevity of all these projects. A simple example of that would be to graduate from an incubating project, you have to have at least 5 independent organizations that are contributing to the project, right? So it's not driven by a single one. Lots of other little tidbits like that. So if you are ever considering an open source project, Linux Foundation is a great home for that, and they've been nothing but supportive and helpful to us. All right, so a little bit about the timeline. This has all been so quick. It's just hard to think that like just 6 months ago we were just getting started. So on August 10, that was the start of it all, right? HashiCorp announces that they're going to relicense under the BSL. Along with a lot of other folks in the community that were frustrated by this change, we got organized. We iterated through a couple drafts of our kind of shared beliefs on what we wanted the direction of a project to go. Put out a manifesto. Hopefully you guys have read that. But essentially it puts out kind of like all the shared beliefs of the folks in the community around openness, around transparency, open development, and all of that. We waited a week. We got no answer. We waited a couple extra days. We got no answer. And sadly, never actually got an answer from HashiCorp. And that's unfortunate. So as a result of that, we started working on an OpenTofu repo. And then September 20th in Bilbao is when we officially joined the Linux Foundation. We signed all the documents. And that's when we announced the project to the world. Since then, it's been such a fun ride. We had a release candidate that we announced in OSS Tokyo. I think that was December 5, something like that. We then continued working on fixing the last few changes and bugs that we needed to make. And I'm very happy to say that as of January 10, OpenTofu is now production ready, used in production by like 150 different organizations now. And it's stable, it's ready to be used. Nobody's really reported any kind of any issue that is impactful. And so we're just very happy that we were able to, in just a few months, make a fork, create the OpenTofu registry, and make something that's production ready and stable. All right. So depending on the week, OpenTofu is or isn't one of the fastest growing communities on GitHub. And it's just been awesome to see like the thousands and thousands of people that have started the project, that have posted issues. I think there's something like, we just passed 80 unique contributors. About half of those are just one time, which we're perfectly happy with, but about 40, the other half, 40, are folks that have made multiple contributions, and we're even more thankful for that. So little call to action of all of you folks. For contributing is super important, but you don't have to contribute code. Like you guys know the rundown for all open source projects. At this point in time, we have more than enough engineering resources. What we're really looking for is folks to use the project, evangelize if you know folks that are using Terraform and are not yet considering OpenTofu. Spread the word, that's super important. And just generally using it and reporting bugs and suggesting improvements. Quick cheat sheet on how to think about upgrading. So if you are currently using Terraform, this is kind of how it looks like. If you're already using Terraform, if you think about it this way, typically folks don't use only use the latest version, right? You've got this bell curve of what versions you have in an organization. Some deployments might use 1.3, some might use 0.13 or others. And then you have this bell curve, and then some use the latest versions. If you are on any version of Terraform prior to 1.5.6 or 0.7, the safest bet is to migrate up to 1.5.x or .7 before considering upgrading and moving to OpenTofu. Just a lot safer, and that's the kind of best practice, what we recommend to folks. Again, as a reminder, Terraform is open source up to 1.5.7, which is the last open source release. And if you're creating a new project, you might as well start it in OpenTofu. There you go. Most folks in the community have just replaced the Terraform binary with the Tofu binary and reported 0 issues in doing so. A lot of folks have also said that for rather than refactoring and changing a lot of the automation that they built on top, sometimes they just made an alias for it and they report that works perfectly fine. That does introduce a little bit of debt, but as far as moving fast, that works. And of the 150 or so folks that we've talked to, none have reported any significant issues in making that. So the takeaway of all of this is migrating to OpenTofu is very, very easy. And if you like the direction of the project, then we encourage you to do that. If you are not using Terraform, if you're not using OpenTofu, then a lot of people have already extolled the virtues of using infrastructure as code, but essentially it's more maintainable code, it's easier to read, it's a better abstraction, and there's a very fast-growing community of resources, so when you get stuck, lots of people can help, and chances are that whether you're using Stack Overflow or ChatGPT or something, chances are you'll be able to get good guidance. All right, a little bit about the release model. So 1.6 was really about getting a stable release into your hands as fast as possible. We've done that. And there's really no compelling reason to use 1.6 other than it's just open source under the MPL. But starting with 1.7, that's when the release model is that every new release will have a flagship feature, which hopefully will be compelling enough to help you make the arguments inside your organizations to make the switch. I'll talk a little bit more about 1.7, but the idea here is we're a community-driven project, and if you have any workflows that you want to see improved, let us know. In 1.7 is the very first of these flagship features. For those who have been in Terraform for a long time, the very first time that client-side state encryption was made as a PR to the Terraform repository was in 2016. It went nowhere. In 2017, there was another such proposal that also went nowhere. It did get a response that HashiCorp's plans was that encryption were to happen at on the roadmap of their commercial offerings, and that's the rationale that they gave for rejecting the PR. A third such attempt happened in 2021. that also sadly got rejected. And so once we made the once we made the repository of OpenTofu available, the contributor reached out to us, created an issue, and suggested to finally get that feature in. So we've been working with them for a while now, and we're super excited to see this is the very first community contribution. It's been a long-standing thing that folks have wanted in Terraform, and because OpenTofu doesn't have the conflict of interest that you see in Terraform, it was easy to get that in, and it'll be the flagship feature for 1.7. So in that feature, we'll support the 4 major lifecycle events for encryption: initial encryption, key rotation, moving away from state encryption should you decide to do that, as well as switching encryption providers if you want to do that too. I think everyone knows what encryption is and why it's useful, so I'll gloss over that. But we're pretty excited about having that in. And this is what it looks like, right? This is someone from the community, not a core contributor, creates an issue. If you look at the date, August 29, this is just like a few days after we opened the repository, or the day of, I think. So Stefan suggested that. We discussed it. We didn't want it in 1.6 because, again, 1.6 is the goal was to get something super stable as early as possible in your hands. But it'll be the flagship feature for 1.7. And it's a really good, so also just a really good discussion with lots of things to learn from if you just follow that thread. We haven't yet decided what we want the flagship feature to be in 1.8. We have some good candidates, but we don't have a monopoly on all that, so we're expecting folks in the community to suggest things. If you've got a workflow that's kind of broken, if you've got a use case that's poorly handled, just create an issue, describe the problem, maybe go into a little bit of a proposed solution. And then we'll look at all of the candidates there, and then we'll pick one to be the flagship feature. And in the release model, we release as soon as that flagship feature is done. Whatever else is done will ship with that feature, with that release. And so that's the decided release model for now. And if you want guidance on how to do that, again, issue 297 for the client-side state encryption provides a really good example of kind of what we would like to see in a perfect issue. All right, so before we get into the Q&A, I just want to reiterate one more time, because I was at FOSDEM the last 2 days. Before that, I was at OSS Tokyo. Before that, OSS Bilbao. And there's a recurring question that comes up all the time. Do the providers need to be forked? And the answer, just like I said just a little bit earlier, no, providers don't need to be forked. There are some providers that are in the HashiCorp namespace. We're just syncing those over. But if you're a provider author, or if you're thinking about making a provider, you don't have to make another one. The OpenTofu team is committed to making sure that all the modules, that all the providers just work, and making sure that those continue working for the long-term future. I talked a little bit more about 1.8, so I don't think I need to go over that a little bit. But a little bit earlier, I was talking about the philosophy that we believe Terraform to be mostly a language more than a software project. And that's why the core OpenTofu community is not going to make forks of other HashiCorp products. Now, there are other forks that have seen different levels of success. But because those are mostly products, there's less of a philosophical point of view there, and so we are taking an approach to just focus on OpenTofu. And so I just want to give a shout out to OpenBAO, which is the open source fork of Vault. Staying with the food theme there. If it's after lunch, I guess so you guys aren't hungry, but I am a little bit. Essentially, I can't say that it's not an officially it's not an official IBM project. That being said, the developers of OpenBOW are employed at IBM. There's also 2 other major organizations that are making contributions to OpenBOW. And so whether that project finishes incubating or not, I don't really know. But if you're using Vault, you can take a look and join that community as well. All right, back to the Q&A. Hopefully we left enough time for a good amount of questions. Yeah, awesome. Go for it.
So
I'll repeat the question after.
You talked about 1.7, the flagship feature being
Yep.
encryption. Why would I use that encryption over rather than just encrypting my S3 bucket?
Yep. So the question is, why use client-side encryption instead of just using the encryption in your S3 bucket? Good question. So there's a number of use cases for why you would want to do that. One, for example, if maybe your AWS account gets compromised in some way, you might want to use an encryption key that is not tied to your AWS account. We know of one organization that uses their Azure encryption keys to encrypt state before storing it in S3. There's another use case, which is sometimes you use a commercial solution, like on my company Scalar. There's also Spacelift, there's N0, there's Digger, there's a bunch of others. And you might not trust those organizations fully to host all your states. And so you might want to encrypt that before storing it in those commercial projects. And then finally, there's shit always happens, right? So like if you control end-to-end encryption, you've got a much greater control over where problems might arise. So those are the main use cases. And I'm sure I'm missing some, but yeah, great question. Go for it. I'll repeat it.
Yeah. What do you see as the challenges for maintaining compatibility with Terraform going forward?
Yeah, so the question is, what are the challenges in maintaining compatibility going forward? Yeah, so we've thought a lot about that. So we're going to decide on compatibility on a long-term, on a case-by-case basis. And so again, we're really community-driven. So if there's a feature that is in later versions of Terraform that the community would like to see in OpenTofu as well, then hopefully someone in the community will create an issue, and then we'll look at that and look at the issue. And then we'll consider adding that as well. We've got a very strict process for doing that, so because again, we can't taint the code for OpenTofu by looking at the Terraform code. So the way we would do that is, if you had a feature that you'd like to see in OpenTofu that you saw in Terraform, you would create that issue, describe the problem, describe the solution, and then without looking at any of the code, we would take that on and try to replicate the solution that you're describing. And then if it works, great, we'll incorporate it in. If it doesn't, we'll just keep iterating. But in terms of deciding, like they're different projects, so over time they will diverge. So the best time to migrate is right now. But as they diverge, there will be a lot of OpenTofu exclusive features. Client-side state encryption is one. There's a laundry list of other improvements that we don't know if they will make their way into Terraform. So the projects will diverge. And if you're using those, it makes it harder to migrate to Terraform, should you ever get crazy and want to do that. But for the migration from Terraform to OpenTofu, that'll be decided on a case-by-case basis. Yeah, and the community is going to drive that. So I think that's the reasonable answer. If you feel strongly about another framework for making those decisions, feel free to contribute it. Great question. Go ahead.
Yeah, while remaining on the topic of
Yeah.
compatibility, the fact that the providers are one-on-one compatible and that you were able to replicate the existing replica so easily, obviously Terraform could change something in the way the providers work, push that out, force all the existing providers, maintainers of providers to update their code,
yep.
Which would potentially break compatibility with OpenTofu. Has that been considered a likely scenario? And if so, what would you do if they would
Yeah. So the question is, what happens if HashiCorp decides that they want to flex their muscle and force all of the provider authors to change an interface in order to remain compatible with future versions of Terraform? We'll have to see if that happens, what that would look like. But OpenTofu is not very useful if we don't have all of the providers out there, right? So it is vital to the health of the project that we support all of the providers. If there's a change in interface, then we will probably make changes to OpenTofu to support whatever the new interface is. It is very also important to just remind ourselves that there's a very long tail of providers that are not made by HashiCorp. They're made by the makers of a ton of different commercial software, commercial and non-commercial software. And if there's a big breaking change to the way that the interface works, they would have to convince a very large amount of folks to support the new interface. And we hope that by that time, OpenTofu is large enough that we would have the community squarely on our side. But very, very good question. It's hard to kind of give a definitive answer other than like, OpenTofu is not useful without all the providers, and so we will continue to maintain whatever interfaces.
I kind of have an extension to that great question. What happens if they change the license of the main providers?
So they change the license of the ones under the HashiCorp namespace?
AWS, Google, Azure RM, like what happens? Is there a contingency plan in place if that is the case?
Yeah, so in that case, we will most likely have to fork those projects that are in the HashiCorp namespace. We've already, I can't really say much on that topic, but the cloud providers, they just want you to use more of their products. So they have a vested interest in making sure that the providers support OpenTofu as well. Can't make any official announcements on that yet. That might be on the horizon, maybe, maybe not. But yeah, they care very much, the cloud providers care very much about OpenTofu being successful, and you can expect a lot of goodness to come out of that in the next couple of months. Go for it.
You mentioned the best time to migrate is now.
Yeah.
For somebody who does not yet quite feel confident enough to migrate to OpenTofu and would like to retain their Terraform configuration,
yeah,
would your recommendation just remain compatible with Terraform 1.5.5? To evaluate whether you want to?
Yeah, great question. So if I can broaden the question just a little bit, the question is if you don't feel super confident in the longevity of OpenTofu, or the maturity of OpenTofu, is it safe to just stay on an earlier version of Terraform and wait a little bit? Yes. So far, nobody has reported any issues. That doesn't mean that there aren't any. We recommend that you make backups of your state files before attempting any migration. 1.5.7 is still open source, and it's a very good release. You can stay on that for as long as you want to. What I meant by the best time to migrate is when you're migrating your workspace or your deployment from 1.5.7 to a later version, at that point in time, that's when it's much easier to go 1.6 with OpenTofu. But if you're already using Terraform 1.6, it's also very easy to make that lateral move to OpenTofu. Over time, as the projects diverge, there will be some features that you might leverage on one side and not on the other, and so that's just going to make it just a little bit more difficult. But this is infrastructure, right? So be cautious. Back up your state files, and unless there's something really compelling forcing you to make an early upgrade, it doesn't really matter if you wait a little bit longer. Great question. In the back there, go for it. With the purple shirt. Yep.
Do you have any idea on compatibility, or they just work out of the box if you have an alias?
Great question. So the questions for all of the surrounding ecosystem tools, whether they support OpenTofu or not. So we're very fortunate to have Jim and Josh, the two main founders of Terragrunt, to be founding members of OpenTofu. They are very involved in the project. We have had many discussions on how to maybe not converge Terra grunts into OpenTofu and have a lot of the functionality merge into OpenTofu. It's too early. Like they haven't. I don't want to speak for them. It's but I do want to say that I do want to remind that they are on the OpenTofu founding board. I think it's Jim who's on the technical steering committee. And so right now, as far as I know, those you can use the wrapper for OpenTofu without an issue. I haven't not personally tested that, so I'm just relaying what I've heard. And basically, like the whole community has moved over to OpenTofu. So if there's any issue, you should report that, and we'll get that fixed. But essentially, the way to think about it, like the community is moving towards OpenTofu, and so it'll kind of look like a closed ecosystem on one side and an open ecosystem on the other. And so over time, you should see almost all the tools just support OpenTofu. There's not exactly a perfect answer to your question, but yeah. And if you want an intro to Jim, just come up and I can make an introduction. Yeah, right there you go.
Which encryption methods are used for the 1.7 release to encrypt the states, please?
Great question. So the questions, what encryption methods will be available in 1.7? So we chose a generic approach so that you can supply your own keys, and you'll be able to so you'll be able to integrate with whatever you want for encryption. The exact specs of it are described in issue 297. So if you want to get the exact answer to that question, you can go to that issue. But the problem we're trying to solve is allowing anybody to use whatever encryption provider that they want to, and so it is in scope of that issue to support anything you might have. Great question. Yes, go for it.
Have you got a sort of goal in terms of time frame for implementing some of the new Terraform features? I'm thinking specifically like the provider functions when they land Terraform soon. Presumably people are going to start using those fairly rapidly, and modules at that point will become incompatible with OpenTofu until you also support those providers that implement these new functions.
Yep, great question. So the questions like broadening it a little bit, but the questions like what happens with the lag when Terraform releases something that OpenTofu might not have straight away, right? Is that a good way to broaden it?
We are going to try and implement this within 3 months. Is there any sort of roadmap for like important new features that you see as like being necessary to implement if you're going to retain compatibility with existing modules and providers that people are developing?
Yep. So we haven't decided on an exact policy or made any promises in terms of what like lag time we want to respect there. But what we have decided on is that we do want the projects to be as compatible as possible. If there's something that you see on the Terraform side that creates some issues there, then we are going to prioritize that. Now, I don't really know. We have not discussed what sort of ETA promises or like what sort of lag time promises on that side. But I can look into that more if you want to, and if you come up to me, I can give you a more detailed answer afterwards. Yeah, great question. This is a great community, by the way. I love the questions. In the back there. Yeah. So the questions, how do you get commercial support for OpenTofu? The same way you would get support for Terraform. Fantastic question. So I think there's a lot of full-time contributors now to OpenTofu that are employed by Spacelift, by M0, by Scalar, by a number of other organizations, and those organizations, as part of their commercial offerings, also offer professional services or support for OpenTofu. There's also a number of consultancies that have announced that they would offer support. I have not looked into the cost or terms of that. But the answer is that we're seeing a broad ecosystem of folks that are offering help in some manner. And so that means that you've got choice of who to work with, and that's why I like open ecosystems, right? You got choice, you got folks competing against each other to provide more value to you. Did that fully answer your question, or you have a follow-on? Yeah. Yeah. So commercial support is, as of today, available from multiple vendors. I don't know if it's possible to get support without using the commercial projects. I can figure that out for you and let you know, but it is definitely possible. Yeah. Any last few questions? Yes.
What about the language? How is HCL affected by this core/licensing?
Yeah. So the question is, what about the HL language? So HL is still under an open source license. We don't really have plans on making a fork of HCL into another language. We're trying really hard to stay focused on the Terraform, that layer of things. There's been some discussions internally, like what happens if HashiCorp decides to make some changes there as well. We don't fully, we're not naive. We know that the success of OpenTofu is a problem for HashiCorp, and so we expect there to be some further obstacles along the way. So we do have a few contingencies. None of them are like, we haven't, in the order of priority of things, we really wanted to get you that stable release out. We want to get you 1.7 with a compelling feature for you to migrate. We're focusing on those first, but in the meantime, we still have in the back of our minds working on contingency plans if other parts of the stack are changed. Yeah. All right, we might have time for one more question. Okay, one more. Going once, going twice. Yes, you got it. Dothan, go for it.
Maybe we see a track with more information about OpenTofu here.
Yeah, so thank you very much for that question. I promise I did not ask him to ask that question. I'm going to be working with Toshin and others for next year's track for OpenTofu. I'm one of the chairs for the Linux Foundation for the KubeCon OpenTofu Day program. So there's a lot of overlap in content there. So I'm going to be working to make sure that next year you guys get a lot more than just me tap dancing here to give you some good talks for next year. Yeah. Thank you very much. One last thing. One last thing, I did print some really cute stickers to celebrate those who have made a successful migration, those working on academic or scientific projects. So if you want some cute stickers, I've got a bunch here. Come up. And you guys have been a great audience. Thank you so much. Thank you. Oh, thank you.
A little gift from the organizer.
Awesome. Thank you.
At least we can do.
Check, check. Yeah. Here.
Okay, everyone. I run a tight ship. We gotta start. I'm welcoming the next speaker, Armin Norifar. He is an SRE. He's come here from Oslo to talk about his love for Kubernetes via Crossplane. He's a technology enthusiast, and it'll be very interesting to hear him speak about Crossplane here. Thank you for coming, Armin.
Thank you. So thank you for joining this session. I'm Arman Norifar, SRE engineer at Rikstv. I'm coming all the way from Oslo to here. At Rikstv we do TV and streaming services. Yeah, that's what we do. And this is actually my second time in config management camp and first time as a speaker. And a bit of like why I'm talking about Crossplane here is I found it pretty cool and like a new futuristic way to provision infrastructure and do some other stuff which we'll see. And I was quite surprised that like this conference is mostly about config management and infrastructure and nobody ever talked about it here. So I was like, yeah, I'm gonna go there and I'm gonna be the first one talking about it there. So let me first ask this question. Probably everybody in a way have worked with Kubernetes, right? Yeah, see everybody nodding. Yeah. Good. And how many of you have heard about Crossplane? Wow, and how many are you using Crossplane today? Right, okay, 1%. Everybody heard? Yeah. Cool. Okay, let's get it started. So today, the high-level agenda is we're going to walk through a very short intro since everybody knows about Kubernetes, and then we want to look a bit more into what is Crossplane, and we want to maybe scratch the surface a bit on like what is the building blocks, how they work together, and basically maybe continuing with some of the new features and things that I'm kind of interested about, and talking a bit about like yet the new thing, infrastructure as data, and maybe finishing with why using Crossplane and why not, and what to consider. And before I start, I'd like to mention that I'm not a Crossplane maintainer or like people working directly on it. I'm just basically interested and motivated in it. So, so that you know, I might say lots of like my personal opinions, which not necessarily is kind of related to Crossplane team and project members. Okay, let's start. We're gonna have a quick intro on like Kubernetes, right? As you all know, Kubernetes, it started as like a container orchestration platform, and then it basically was widely adopted, and not only doing like pod orchestration, but like lots of other stuff. And the main reason was it is vendor neutral, and then it has a kind of a uniform API to define things and objects, and it has a kind of a declarative approach. And as you see, like this is a very basic example, I just wanted to put it there, that you describe what's your desired state of things, right? It's pretty simple to read it, to look at it. Of course, it's YAML, it's not very, how many of you don't like YAML? Okay. Well, yeah. And then you have like one tool like kubectl that you can talk to all the objects that you create. And maybe the most important thing is like the reconciliation loop, that you have the controller libraries and runtimes that always make sure that these are the states that you describe in this YAML always is applied to the cluster, right? And maybe one of the smartest moves in the Kubernetes project was the creation of the extension points. as called like CRDs in Kubernetes, that's kind of opened the door to lots of other stuff in Kubernetes. That we can say today Kubernetes, like one of the things that Kubernetes does is orchestrating pods, but lots of other stuff. I don't need to talk about it, I guess. And there were a group of people that were asking this question on 2018 that, yeah, okay, so it's about talking to an API, right? So basically Kubernetes can talk to any API and make sure, orchestrate it, do life cycles, auto heal, and all those kind of stuff. And they were asking this question, like, why not managing our cloud resources on Kubernetes? And because it's kind of like Kubernetes API and everything is kind of well suited. So you have like your cloud provider's API and like control plane, and then it has like 1 million maybe permutations of how you can use that API, and then you can maybe build on top of that something that can interact with that to kind of create your own opinionated, as we call, control plane in this project. So we're going to talk a lot about control planes in Crossplane. Actually, Crossplane, as it's called, is a framework for building control planes. It's a bit, if you think about it, it's a bit different than automating infrastructure, right? So you are creating a control plane on top of the other cloud provider control planes. And you can basically create your custom opinionated resources and objects and then map it to the API in your cloud provider. It uses the same declarative API of Kubernetes, and it's basically going to be very similar if you have, I mean, as you all know that you have worked with Kubernetes, all the syntaxes are going to be very similar, so you don't need to relearn something new and maybe expose it to people in your company. I need to mention maybe at this point that Crossplane is a CNCF project. So I guess we can be rest assured that what happened in the Terraform side wouldn't happen here. Just the previous talk, we talked about it a bit. So it started in 2018 and then moved to CNCF Sandbox in 2020, and now it's an incubation phase. And the latest release I checked was V1.14.5. So it's still in the incubation phase, meaning there are lots of new features coming and going. So there are lots of things happening there, lots of commits every day. So yeah, we're going to talk a bit more about it. But before going a bit deep into the maybe looking at the building blocks, I want us to think about: do we need yet another IAC / configuration management tool? Haven't we had enough? And that is a question that I like to maybe try to address it in this way, that if we see like a categorization of, like a very bad categorization of the tools we have seen in the past years, the thing is we've been doing provisioning and config management of our infrastructure for a couple of decades, right? It's not something new. So we had or we have, let's say, still projects like Puppet Chef, Ansible, CF Engine, and then maybe a bit like after the next generation of those on like Terraform, Pulumi, and then the CDK wave that's like, yeah, we want to use a full-fledged programming language to do it, that you can do in many ways with like AWS CloudFormation CDK or Terraform CDK or Pulumi. And as well, shout out to the OpenTofu guys, which are falling into this category of IC tools. Yet I think there's like another category of control planes, which we're going to see probably more in the future, and Crossplane is one of those types. And the way I look at it is, I'm still trying to answer the question up there, right? Just bear with me. As our workloads, like day by day, evolve, and there are lots of people now kind of having workloads on Kubernetes, you have basically two ways. Like one way is to bend your current tools of like infrastructure and config management to be able to fit with your new workloads, or you need to find new solutions, right? And that's like the flow of it. And I feel kind of, this is my personal, I mean, it can be debatable that as we move on, basically things in tech don't die, right? They just go into, they would become stable, and then when they are stable, they are kind of losing their hype because nobody is really like talking actively about it, doing conferences, because it's an stable product and everybody's using it. A very like exaggerated example of that would be DNS, right? There is no hype over DNS or TCP/IP, and nobody is talking about, oh yeah, like there is a conference talk about TCP/IP, because it's basically working, right? It's a stable product and people are using it. And but in the new ones, there are still hype, like because they are trying to fill a new gap. They are trying to do something new, and then things don't work. People open issues, and then there are lots of commits and talks and conferences, and blah blah blah, and then the same cycle probably continues. So let's go into the building blocks a bit deeper. There are lots of details here. I'm just trying to kind of move you through like a very quick journey of like what this thing is and how things interact. So let's see how kind of detailed we can get. The first thing here, as you noticed, we have like down there managed resources, and that's like basically some CRDs in Kubernetes that we get by having providers in crossplane. It's a very famous concept of providers, right? And this is like maybe a YAML kind of representation of how you create a provider. In this case, you have a provider for AWS S3, which creates API resources in your cluster for buckets, ACL, I don't know, whatever you can do with whatever action or like object you can have in S3 world, right? Which in crossplane setup, it's called managed resources. So that you know, so we are talking about the black box down there. And the provider is creating those CRDs, and as well, it's basically a pod which is responsible for reconciling those CRDs that you create using that provider, right? And then the next step, or the next building block, we can say, are managed resources, right? So you see in this example, I'm creating a simple bucket. I'm just saying like API version. You see the syntax is very similar to what you do and how you package your stuff in Kubernetes, right? So the learning curve there is, basically there is no learning curve, right? It has a kind, it has a metadata, there's a generate name, this is the name of my bucket. There are some spec, and you see the for provider parts, which is the parameters that your provider actually needs to create. Like if you want to say, my bucket should have versioning enabled, should have publicly be accessible or blocked, or whatever is like available in that provider. And when you basically create it, you see then you have this managed CRD, which is going to list you like all the resources that crossplane in your Kubernetes cluster is representing, which in this case is a bucket with a name. If you see on the right, the external name is the actual name of your bucket in AWS, and on the left there is a different name, which is the name of the object which is mapped to that bucket in your Kubernetes cluster. So this is a very simple, like one piece resource, right? But this is not enough, right? Like Nothing is that simple in the real world. That's where compositions come in, which are basically like a template of multiple managed resources stitched together. You can see we have this kind composition comes from crossplane, and then you can name it, like in this case I named it Dynamo with bucket. I want to create a DynamoDB with my bucket now. It's not just a bucket. And you have a couple of, actually a comment, I tried to like bold some of the parts. Maybe, I don't know how much visible that is, but you try to see the bold ones. So in the base part, you see I have an S3 bucket and then I have a DynamoDB, and at the end of the YAML file, I basically reference what composite resource is allowed to basically use this composition. And if I want to just see all the compositions I have in my cluster, I can just say get composition. This is a very still familiar syntax, right? You always write kubectl get pods, get deployments, and in this case you get compositions. So we are getting like moving through the building blocks. We've understood what are managed resources, compositions, and on the left side now we want to talk about composite resource definitions, which is actually how you're basically you are creating a new API endpoint here, right? And this is defining how your API endpoint is, what is the schema, how people should interact with it, what's like what parameters it accepts and whatsoever. You see in this case, for example, if I move on, I have one as called in crossplane XRD, which is a CRD, but CRD was taken, so they took XRD as the short name. We are defining like how my API endpoint should look like. And you see it's basically, again, very familiar like OpenAPI schema. And in this case, I'm telling it, yeah, my bucket, or in this case, it's a NoSQL, should have a location, and the location should be either EU or US. I don't want users to write like US1 or US East 3, those kind of things. I want to just abstract from the like developers or whoever is going to use this abstraction. And basically we move on, and the next and maybe the final building block here are composite resources and the short form of XR. If you see down like in the slide, the YAML file, this is basically if I'm a platform team and I want to build this tool and pass it on to the developers in my company, this is basically what developers should do, should write to get that Dynamo with buckets. They should just call my X NoSQL API endpoints, the XRD, the resource definition that we talked about in the previous slide, and they just need to pass a location EU, and the rest we will figure out. And the same way you can see all the composites, and when I apply this, you see I get one composite resource object, which is like representation of this whole object, and then still you can see per resource, so you can list all your resources one by one with kubectl get managed, which is going to show you not your object, but all the single resources that have been created in your cluster. Well, different types of, yeah. So going back to this, I guess we are kind of completing the schema here, and the last piece, which is like the simplest one, is claims, which are basically composite resources but are namespaced. so that if you want to have like more isolation for your resources to not be available in the whole cluster. And it's basically the same syntax. But we haven't yet talked about how that location EU was transformed to what AWS can understand, because AWS API don't understand EU, right? You need to specify what region you're using. One feature which we have here, which later on I'm going to tell why it's going to be deprecated, is patch and transform. But it's very, very, very like interesting to understand what it does, which is basically the last part of this YAML file, which is basically saying, just go to that, like to my XRD and fetch that value of EU and then paste it somewhere in my composition. And then on the fly, you can transform it and say, whenever it's EU, then map it to EU West 1. Whenever it's US, map it to US East 1. And that's the actual value that your composition will use to create your resources, which you have hidden from whoever is using this. I think this is pretty cool, right? And you can as well reuse it. There is a concept of patch sets. I mean, probably this region you're gonna have for all the resources. So you can create some reusable like patch sets that you can refer all the time. And there are lots of things you can do with it, which I'm gonna not go into the details here. You can basically move stuff from your resource definition to the composition and vice versa. You can combine things, you can get it from your environment, which I'm gonna tell what that is. And there are different like transform types you can do, like converting, matching, doing mathematical operations, yeah. But is that all? I still want to loop. I still want to do conditionals, right? It's not, without these kind of stuff, it's really easy to get a composition file with like 500 lines of YAML, which is probably no one of you are gonna look at, or it's gonna be a headache, right? And one of the conscious decisions that I guess the Crossplane team have made is to say no to all these requests that we want a loop, we want a conditional. And the main reason is they are trying to not grow into a new DSL. And you know how like easy that can happen, because it starts with a for loop and then you want something else, then people want this thing. That kind of reminds me of the early days of Terraform, when you could count or do loop over some resources, but not the modules. And then there were like, there are lots of like things. You're just entering an era that's there's no like, you cannot get out. Basically, what they've said, like the maintainers, was there are lots of tools that you can define Kubernetes resources in general without writing YAML. Think of Helm if you're thinking about like packaging or customize for like overlaying preferred JSON, or YTT, which I've not used myself, but it's a thing out there, or Q, which we're gonna have a couple of talks, I guess, in this conference, which is pretty interesting for me too. You can still use those stuff to generate your YAML, and that's something that basically Crossplane and Kubernetes in general don't care about. It's just give me the desired state. I don't care how you generate it. I don't care if you have a front end, like a very graphical thing that people can drag and drop stuff and create it. Just give me the YAML file, and that's the rest I'll handle, right? And in addition to that, there was one other feature that Crossplane added, which was composition functions. So they wanted users to be enabled to write their things that they can do in a full-fledged programming language still inside Crossplane, but not rewriting a language, right? Because they are not, like, I guess, language engineers or like language designers. So basically what they did was enabling a feature to basically run your functions inside the composition. And those functions can be written in, there are Go and Python SDKs for it to kind of help you get it started pretty fast. And the way it works is you basically create a pipeline here, and then at each step, your function would get some inputs and generate some outputs, which are the YAML parts, or like the YAML basically config that you want to generate. So if you want to loop, your function would get like a count, and then it would loop over one YAML, like part of your YAML, and then just generate something bigger for you without you needing to look at a very big thing. It's actually interesting to look at an example, right? This is the exact example of looping. And there are lots of functions already written, and of course you can write your own. And, but for some simple use cases of like looping, conditionals, those kind of stuff, one of my favorites is this function Go templating, which you can basically use Go language to template whatever you want to do. And in this specific case, if you see my XR, like my composite resource that I want to create, I'm just saying, give me whatever that is, which in this example is not very clear what we want to create, but that's not the point. But whatever that is, I want count equal to. It's very similar to saying like deployments replicas to, right? You don't know how it's done. You just know it's somehow handled in Kubernetes, right? And then what will happen is the platform team or whoever in the company who's writing the compositions would basically need to write this pipeline in a composition, and then in the bottom part you see you have a range which you kind of doing a for loop over that observed composite resource spec count, right? So you are basically reading what is the count, and then I loop through it, and then I generate that bucket in this case as many times as the user wants. And then you can kind of like build on top of it, make it more complex. There are lots of things you can do with this, because this is like a actual programming language. You can do variables, whatever you can think of, right? So this is like, this feature went into, if I'm not mistaken, beta in the like the latest V1.14, and it's still a beta feature, but I think it's gonna be one of like the released as one of the like general availability features that we're gonna have in the future. And I guess by that we are kind of covered. We have kind of covered the whole picture here. So you have an API, your opinionated API of how infrastructure should look in my company, and you create an endpoint for it, which has a schema and a composition with however you want to do things, and you basically expose it to the developers in your company, or maybe use it in like building a developer platform in your company, so that the developers, which are not necessarily interested to learn yet another like HCL or DSL, would have an easy way to kind of have like write a YAML, a very simple YAML file, in addition to their like service, and get their infrastructure as well, without you needing to do something for them, or like you creating a pipeline of how I want to run Terraform, blah blah blah. How much time do I have?
You have another 15 minutes.
Yeah, cool. So I want to hover over some new features that we got either alpha or beta in the recent versions of Crossplane. One of them is you might end up in a situation as to say, I want Crossplane to pause reconciliating my resource, because I'm doing some operations on the cloud side, and I don't want Crossplane to be involved in like doing anything, because Because I'm reminding, cross-plane is actually trying to make your infrastructure always look like whatever you write in the code. So there is like a reconciliation loop there. It's not like when I run things on my laptop, the infrastructure is going to be created and then nothing. We will probably notice when it's changed or when someone has randomly deleted something, and we would get some alerts probably, and then we would fix it. So it's always like trying to get your things to the desired state that you have written in your YAML, right? Which you can pause for a reason. And the other thing, in the spec part, you can see this is a new feature as well, the management policies, which you can instruct cross-plane what actions it's allowed to do on that resource. Is it allowed to even delete it, or is it just a create, or is it only observe a resource, which is very important and very useful when you want to import stuff to cross-plane, which I'm going to talk about. So you basically can say like how basically define the boundaries of what cross-plane can do with your resources. One other feature which I found really interesting, and again, these are the problems of like continuous reconciliation of infrastructure. Imagine you create an EKS node group or an auto-scaling group. Probably when you create it, your desired state is 1, and then suddenly there's a peak, or there are more workload, and then you need more, right? So then probably cross-plane would try to get it back to 1, because that's what you've mentioned in the code, right? That's where you need like init provider. So those configurations are the configurations that are applied only during creation of a resource, not after that. So when cross-plane wants to create a resource, it would say the desired state is 1, and then it's not. It doesn't care about desired resource. It's out. So it's not trying to kind of do anything with it, which is very cool. I guess it's very, very useful in some cases. And I touched upon a bit on importing resources. This definitely is something if you are not using cross-plane today. The only thing you need to do is basically adding a resource with an annotation, as you see in this example. You should define your external name, meaning what is my actual resource name is, which in different cases can be different depending on the provider, right? And then you specify the management policy as observe only. So what cross-plane in that case do is just look at your cloud resource, and then try to copy over all the information it can get from it. And then if you then describe that resource in your Kubernetes cluster, you see all the configurations which you can then manage some of them after. And if not, it wouldn't do anything with it. So it's just a resource that it's observed. It's like, if you've worked with Terraform, maybe a bit more like if you want to have like data resources to, for example, get your VPC ID or something. One other thing is readiness checks, which you can define specifically when cross-plane should mark your resource as ready, in case you want to customize something. And the other one, which I want to maybe quickly talk about it, is again a beta feature, which is called environment config. Basically, I guess today we had a talk about it. That's about like reusability of your like infrastructure. That's kind of in line with this, which you can create a kind of a key value store of like what are the maybe some configurations that are specific to my environments. It can be like prod, dev stage, those like what are my subnet IDs in prod, or what are, so you can basically have some kind of environments depending on your setup, and then just reuse those values instead of like getting it all over again, all the time. And quickly you can, in some cases where it's very hard for a crossplane to understand, for example, if there is a dependency between your, for example, in this case, EKS cluster and a Prometheus chart. It's kind of not apparent, right? In those cases, you can define a usage, which is basically you are telling crossplane that these two things are dependent on each other. You are not allowed to destroy that thing before or until for example, in this case, the chart is there. You have this like a spec off and by to kind of do it. And on the left side, you have like a way to say like this resource should never be deleted. It's like creating a delete protection for your resources on crossplay. And of course, some of the cloud providers kind of have that option on their side as well. For example, if you have an RDS, you can like enable it on AWS as well. And those are some of the features that I found interesting that I wanted to share as well. But we get to this. I like to show you at the end this slide. This tweet is from 2018, and I guess from even that time we have became more of a YAML engineer, right? And everything is kind of YAML, especially if you enter like Kubernetes world and workloads, then you would see lots of YAML stuff left and right. But the real thing is, like, this is one of the core principles that you need to serialize your intentions to a computer, right? And that happened to be YAML in Kubernetes world. And some people are like, no, I want to use a full-fledged programming language to kind of tell my intentions to my machine. And that's fine too. There is always going to be code involved in any ways. But the way Kubernetes, like kind of way of like manifestation works is you need to basically declare your intentions as data points, not like for loops and conditionals and variables, blah, 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 right? It's a YAML format or a JSON format or XML format, whatever that format is I guess like that debate is kind of unnecessary of like, oh, YAML is this and JSON is this. It's basically a data representation format, right? You can think of like anything, right? These 2-3 data representation formats gained popularity. No one knows how, why, right? And you basically have a form of like serializing your intentions to, in this case, like Kube API server and Kubernetes cluster. And we can say like, in this case, we are defining our infrastructure as data, which is a new term that I've like heard a couple of times in this when people are talking about like control planes and when you do it on Kubernetes, which makes sense. Because you can, at the end of the day, what you do is even your functions, they are basically parsing the YAML or like changing some of the fields, adding, combining stuff. So they are working with the data points in your YAML setup. But don't get me wrong, we talked a lot about infrastructure and like specifically AWS because I've worked a lot with AWS. But there are lots of providers already for crossplane. So what I like to remind you is crossplane is a control plane solution. It's not an infrastructure automation system, right? So whatever that has an API, probably you can control it with Kubernetes, and probably you can control it with crossplane. And there are lots of providers already out there. You see some of the public clouds, private clouds like OpenStack, and some of the other like I don't know, Grafana or PagerDuty, which are like some services not related to like infrastructure at all, right? And I like to wrap up by like, why should I use crossplay at the end, right? First of all, it's Kubernetes native, so whatever feature you have in Kubernetes, and it's a very large community of people and services around Kubernetes that you can enable, like you can use out of the box with Crossplane as well. That is very important, as it empowers Crossplane a lot. And you have a declarative config. Maybe some people don't like it, maybe some people like it, but that's basically how things work in Kubernetes. You need to define what you want. You need to define your desired state as data, YAML, and that's it. And then you can easily build an opinionated. You can say how the API should basically look on my cluster and my infrastructure or my company. And on the top, I see like lots of the talks that you hear about, like infrastructure as like IAC tools and config management. You get this like reconciling controllers that always try to make sure everything is updated on top of this, right? Which none of the kind of like vanilla IAC tools give you that feature, like without any configuration, right? So you always need to do some pipelines or go into like use some other like side tools or go into, I don't know, Terraform Cloud to get those kind of features. And it's a community driven, right? So it's vendor neutral, and I hope it remains that way. And what to consider when using Crossplane? Like, are there any like sharp edges, as we heard a lot today? As you understood, it's still under heavy development. So there are lots of features that you've seen in this presentation that are still in alpha phase, which Crossplane's kind of way to look at it is like, if it's in alpha, we can basically drop it tomorrow and we say, like, no, the community didn't like it, so we're not going to continue it. So it's, yeah, things might disappear, I mean, like, more often than the other more stable products. That's how it is. And maybe you, that's one point, that maybe you need infra automation. Maybe you don't need control planes, right? This should be a conscious decision that you need to make. Does my company needs like an actual, do I do my team or like a platform team or SRE team or whatever team I'm like managing the infrastructure, do we need to act as a gatekeeper in our company and then provide an API like abstracted control plane to the developers, or we don't need it, or our company doesn't accept this basically us be the gatekeeper of the other stuff. And yeah, what are your company needs? And of course, the developer size matters. I mean, yeah. So if you're interested in Crossplane and kind of these topics of like how to do this stuff on Kubernetes, make sure you follow me or like connect with me on LinkedIn. I'm gonna post some interesting stuff in the coming weeks. And by this, I just want to say thank you. It was very nice to talk about this in config management.
We have a few minutes if anybody has any questions. The question at the back.
So one of the biggest problems with infrastructure support libraries is the fact that you need to be very careful about changes.
Can you repeat? Sorry.
One of the biggest problems, in my opinion, with infrastructure as code is change management. Being careful with changes. For example, don't delete the database that's in use. How do you verify the actual change that's going to happen when you apply new code to something across the
Yeah, this is something. This is a very good question. Crossplane by default wouldn't like delete any resource when you change actually a value. It might ignore it, but it wouldn't like delete it without you kind of deleting the resource on the Kubernetes, like the actual Kubernetes object, right? This is a very good question and like, but of course in many cases what you can do with like what change requires deletion and what not kind of is dependent to your like provider resource, right? It's not defined by Crossplane. Any other questions? Nope. Okay. So have a good day ahead. Enjoy the conference.
Thank you so much. Pleasure. That's from thanks. We got about a 20-minute break. we can start like 20 seconds early.
That's fine.
Okay, everyone, we're going to start. We're like 20 seconds early, but that's fine. So I'm delighted to introduce Florian Haas, the first-time speaker, config management camp. Someone who's been around in the Ansible, OpenStack, OpenEdX, and Ceph spaces for a while, and he's here to tell us about why we should quit simplifying. Thank you, Florian, for joining us.
Thank you. All right. If you would like to follow along with the slides that I'm showing here on your own device, then please go to that URL here or snap the QR code that I'm putting up here as a really big one as well. Please do that if you have any kind of vision acuity issues or you're simply sitting at the back of the room. Please make use of this. And also if you happen to be photosensitive and you're prone to migraines and you can't stand staring at a bright screen for a really long time, do this as well, because you're going to see this little hamburger menu at the bottom there, and you're going to be able to change the color scheme to white on black, so on a dark background. And that might be just a little bit easier on your eyes and therefore on your brains. So if you want to use that. I'll keep this up for a few more seconds if there's some people that still want to snap the QR code. And then let's get started. Now, this being config management camp, I think it's fairly safe to assume that everyone around here knows Ansible, at least to some degree, right? Who knows Ansible? Show me your hands if you know Ansible. Okay, great. Keep your hand up if you've used Ansible in anger, so actually used it to maintain and deploy production systems. Keep your hands up if you've reported an Ansible issue or a feature request or something like that. Okay, leave your hands up if you've actually sent a pull request or maybe you're maintaining a collection or something like that. All right, excellent. Okay, great. So can safely assume that everybody in here is reasonably familiar with Ansible. Oh, there we go again. I'll be back in a second. All right, I'm going to have to sort of dart back and forth here. All right, so since we've now established that you're all familiar with Ansible, it's probably safe to assume that you've also seen this at some point. That is the main GitHub repo for Ansible. It has the whole commit history of the entire Ansible project all the way back to, as it happens, quite nearly exactly 10 years ago. Ansible got its start in February of 2012, precisely February the 23rd, 2012. It was a Thursday, and it saw the first commit to Ansible, and it simply read Genesis. That was the whole commit message. Funnily enough, so keep that in mind, February 23rd, 2012, the Wikipedia article on Ansible has the initial release date as February 20th, 2012. So 3 days earlier, citation needed, which I always thought was a little bit cute. Okay. Anyway, so if you've seen the Ansible GitHub repo, you have probably noticed something that I think, at least according to my recollection, has been there pretty much from the jump, pretty much from the get-go, which is this thing that's under the little about heading, the repo description. At least I got my start with Ansible in late 2012, early 2013. I think I remember it's been this way, or that description has been there pretty much from the jump. And it reads, and I quote, Ansible is a radically simple IT automation platform that makes your applications and systems easier to deploy and maintain. Automate everything from code deployment to network configuration to cloud management in a language that approaches plain English using SSH with no agents to install on remote systems. End quote. The second sentence in here might actually be a little more recent, but the first one is the one that I think I remember as having been there from the get-go. Ansible is a radically simple IT automation platform. Would you describe Ansible to somebody who's just getting their start as simple? Like, if you're an Ansible shop and you have like a really new junior person coming in and they know nothing about Ansible, would you use the adjective simple to describe Ansible? Probably not. Probably not. But where does that come from? Where does that claim come from, considering it's been there from the get-go? Well, first of all, whether or not something is simple always depends on compared to what, doesn't it? Compared to what is it simple? And in 2012, when Ansible started, the thing that you would naturally compare it to was the incumbent in the server automation space, and that was, of course, Puppet at the time. I mean, there were others, there was Chef, there was Sieve Engine, but you could argue that Puppet was the incumbent, and Puppet had been around since 2005. So if you compare the two projects in 2012, well, yeah, Ansible was simpler than Puppet, but just because there was a jolly good lot of things that you could do with Puppet that you couldn't do with Ansible at the time. So one thing to kind of take away from that is new systems, stuff that is newly built, frequently feels simpler than an older thing or an existing thing, simply because you can do a lot less with a new thing than with the established thing. I'd argue this is largely due to the fact that for about 90% of software projects or software systems, the following is true. You can design a replacement for the thing in 6 weeks, you can put out an initial release in 6 months, and then you spend 6 years ironing out the edge cases and corner cases. And for some projects, I think the number is actually 10, so 10 weeks, 10 months, 10 years. But yeah, that's the thing, right? The thing that's been around for longer has already solved more problems. You can do more things with it. And as a system grows and as it develops more features and more capabilities, it's subject to a rather interesting phenomenon which also contributes to growth in its complexity. Who in here has heard of or read this article? Mike Hadlow, The Configuration Complexity Clock. Okay, that's way too few hands going up here. Right? Okay, so let me tell you a few things about that. So this is an article from a UK-based developer named Mike Hadlow, who wrote it in 2012. It's almost the same age as Ansible, interestingly. Mike Hadlow is a C#.NET developer. Absolutely not a community that I'm in any way involved in, but this is really universally useful. This article is one of those things that, in my humble opinion, every software engineer and every software engineering manager should have read, but few actually have. In that way, it's not entirely unlike Fred Brooks's Mythical Man-Month. Now, here's what it says in brief. Please, by all means, do go there, do read this article. It's only a couple of screenfuls. It's really useful, but I'll give you the gist of it. So what the configuration complexity clock suggests is that we think of the development state of a system as the face of a clock. And we start at noon, or midnight if you're wired that way. So we start at 12 o'clock, and at 12 o'clock, everything's hard-coded. The system behaves in a certain way. If you want to change how the system behaves in the slightest, you have to change the code. 12 o'clock. Then, as the system evolves, we get to the point of saying, well, some kind of ability to configure things would be awfully nice, and we add configuration values. So those could be actual values in a config file, they could be arguments or options for a command line interface, they could even be environment variables for a container. The environment variables for a container thing was not in the original article because nobody did that at the time, but it's essentially the same principle. So now you're at 3 o'clock. Then you begin to add relationships between your config options. Like, for example, you might have, if you're writing a CLI, you might have like some subcommands, and now you are introducing a global mode switch that makes some or all of your subcommands behave differently. So now what you've built is effectively a crude rules engine for your system. And then all of that eventually morphs into a domain-specific language, or DSL, and you've gone to the rules engine is 6 o'clock, the DSL is 9 o'clock. And eventually we realize that managing our DSL by hand is like really unwieldy, so we write some code to generate the DSL for us, and it's noon again. We've come one full circle around the clock. Now, Mike Hadlow wrote in 2012 in his article this little quote. He wrote, "To be honest, I've never seen an organization go all the way around the clock, but I've seen plenty that have got to 5, 6, or 7, so have done about a half circle around, and feel considerable pain." Now he wrote that in 2012. So with more than a decade intervening, and with the hindsight from that decade, this is definitely an "oh my sweet summer child" moment. So since that article appeared, there have been so many organizations that have taken multiple laps around the configuration complexity clock, and that very much includes many open source software projects. I've seen things that you people wouldn't believe. And Ansible, I don't mean to pick on Ansible in any way, but I think Ansible is really interesting because the configuration complexity clock not only very well describes the evolution of Ansible, but it also describes the evolution of the typical Ansible user, like the way people typically approach Ansible. Because what do you do when you first get started with Ansible? Try to remember what you did when you first got started with Ansible. You probably wrote a straight up playbook. You wrote a straight up playbook, it had tasks, it invoked some modules, it did exactly what was written down in the playbook. You could easily follow what the tasks were doing. It was intuitive, wonderful. Then you realized, well, it would be nice to make some of those values configurable. So you defined some configuration values, you maybe added a vars file, and you moved from 12 to 3 o'clock. And then you created your first inventory. You aggregated some hosts to groups, you applied roles, you set variables for those, thereby you built a crude rules engine. You went to 6 o'clock. And then you noticed, oh, this is nice, I can write my own roles, and those roles can have defaults, and in both the roles and the defaults I can use Ginger 2 templates. And now you operate in this very peculiar, very loosely defined, but clearly domain-specific language, namely Ansible's weird mix of YAML and Ginger 2 and some straight up Python sprinkled in. So you've reached 9 o'clock, and then at some point you probably figured out, oh, hold on, now I can discover most of what I need to, like most of the variables and most of the information that I need for my inventory automatically, at which point I don't even need to maintain host vars and group vars files anymore. And you found yourself either writing or using a dynamic inventory driver, and boom, you hit 12 o'clock again. And of course, the cycle doesn't. this is always very funny when people have sort of this realization. It's like, oh shit, yeah, yes, exactly. And of course, the cycle doesn't stop there at all, because now your inventory driver grows configuration options, etc., ad infinitum. Okay? And lest you think I want to pick on Ansible specifically, this is by no means specific to Ansible at all, right? So if you think of, for example, Terraform beeline straight to DSL, right? But I don't know, I can only speculate. Maybe they thought by going straight to a DSL, they would not go further around the clock. But of course, people got sick of maintaining HCL by hand, and they came up with TerraGrunt. Right? Kubernetes manifests, another example. People got sick of maintaining Kubernetes manifests, and now we have Helm charts and customization and a myriad other ways of building Kubernetes manifests. So quit pretending that you can run away from the configuration complexity clock. Those things that you're doing to ostensibly improve the configuration of your platform, you're not on a linear track. You are very much on a circular track. The next iteration that you think will definitely solve your complexity problem absolutely won't. You're going to find yourself right back at 12 o'clock at some point, and then you're essentially starting over. Let me show you examples from another project, lest you think I somehow cherry-picked Ansible here. And with this one, I cannot necessarily assume that you're intimately familiar with it, so I'll give you a little bit of background on it. The project that I'm talking about is OpenEdX. Now, OpenEdX is a general purpose learning platform. Who in here has heard of Moodle? Okay. If you've heard of Moodle and you have a rough understanding of what Moodle does, you have a rough understanding of what OpenEdX does. They serve very much the same problem domain. Moodle is a PHP code base, OpenEdX is an all Python code base. They have like different degrees of adoption in various regions of the world, but in general, it's a very, like I said, they serve a similar problem domain. And OpenEdX came out of, it was originally developed at MIT, a predecessor project was called MITx, and there was initial collaboration with Harvard and Stanford universities. And in 2013, they formed a nonprofit and released the whole shebang under the Affero GPL, the AGPL. So it's been around for more than 10 years. Incidentally, it's roughly the same age as Ansible. And it's widely used not just in academia, but also in business education, in non-profit educational platforms that are not academic. So for the people who are here from Germany today, for example, if you've heard of Reporterfabrik is another such platform that is built on OpenEdX. And it's also something that I use in my day job on a daily basis as both a courseware author, a maintainer of our own in-house OpenEdX platform, and also as an occasional OpenEdX contributor. Not necessarily to OpenEdX core, but to a variety of adjacent projects. And OpenEdX is at its core really a Python Django application, or rather a whole array of Python Django applications that all work together. It contains a learning management system, a courseware authoring system, a bunch of other things. And the reason that I'm mentioning here is that it's full of fantastic examples that illustrate how complexity, once it's been injected into a system, never goes away. It does not recede. Complexity is always here to stay. And as a corollary to that, no, you cannot make it go away with abstraction, automation, or encapsulation either, because all that those do is abstract, automate, and encapsulate complexity. They don't make it go away. And if you need any illustration of that, recall what bundled subprime mortgage securities did to the global financial markets in about 2007 and 2008. Right? Just you think you can get rid of complexity somehow by encapsulating things. Now, before I proceed, I want to make one thing really clear. I do not mean to pick on OpenEdX here at all, just like I didn't mean to pick on Ansible either. I absolutely do not want to insinuate that there is incompetence in play here in any way, shape, or form. I am perfectly convinced that what I'm talking about here is really just illustrative of something that applies to substantially all collaborative software development projects or software systems. And the fact that projects like Ansible and OpenEdX and so many others are open source just simply enables us to look into them and investigate and analyze these things, which is eminently a good thing. So with that said, let me give you one of many, many illustrative examples of the permanence of complexity from this project. So courses in OpenEdX are basically files and directories, and you've got basically gzip tarballs as an interchange format, but you have to sort of import those into the system and then extract them, and then they have to be stored in something that is basically a shared file system. So you have like a bunch of front-end servers and they need to access this shared file system on the back end. So in about 2012, 2013, they had to make an architectural decision on what they would use for that purpose. And apparently they thought, we don't want to use NFS for whatever reason. They also looked at GlusterFS. They didn't quite trust that. I had a chat with the developer who was involved in that at one point. He said, well, we looked into that, but we weren't particularly happy. They also didn't trust CephFS. This part is perfectly reasonable for the time because we're talking 2012, 2013. CephFS didn't become actual production ready until 2016. So what they did, what they went with, was this kind of very strange, kind of, sort of, but not quite like file system thingy called GridFS, which is a MongoDB feature. And with that, they made MongoDB more or less a core component, or at least a hard dependency of the platform. Again, we're talking 2012, 2013. I had my start with OpenEdX in late 2015. And even then, so 2 years after this decision was made, people were thinking, whoops, this was a mistake. Like this, it wasn't a great idea to go with that thing. We should really get rid of this hard dependency on MongoDB. And it's now more than 10 years later, and the project is still at the stage of, yeah, we might get rid of it real soon now. And it wasn't for lack of trying. They did try to re-implement the whole thing, basically refactor it all, pull it out of the OpenEdX core even, make it a separate application called Block Store, which would use S3 storage or anything compatible with S3, or perhaps even anything supported by Django storages, and the rest of the OpenEdX platform would communicate with that solely via a REST API. And then they found out that that came with like really, really bad performance impact. And then they moved it right back into the OpenEdX core, where now you've got basically another thing that doesn't quite replace the old functionality. You still have the dependency on the old thing. You still need to track MongoDB for updates and vulnerabilities and manage that and whatnot. And there's no net reduction in complexity at all. So no matter what you try, complexity does not recede. Let me give you another example from the same project, which is there's something OpenEdX did right from the get-go to its great credit, which was that they didn't just open source this platform code, this Django, whole array of Django applications platform code by itself, because of course, a Django application has all sorts of external dependencies. It needs a relational database. It needs this and that and the other thing. So throwing just this over the fence would have made adoption tremendously difficult. So what they did instead, again, to their great credit, from the get-go, they also released all of the tooling that was required to deploy and manage and maintain the platform in an automated fashion. This was largely based on Ansible. There's a bunch of roles and playbooks that they defined for that purpose. Initially, they also had some CloudFormation templates, so you could bootstrap stuff on AWS. They dropped support for that at some point, but there was very good support for these Ansible roles and Ansible playbooks and so on, and that allowed you to build an architecture like this. So the Ansible playbooks would give you a backend. That's what you can see at the bottom left of the slide. It would deploy a backend for you. You could run this in anything that gave you any kind of virtualization. You could run it in AWS, in VMware, in OpenStack, wherever. It would spin up these 3 VMs for you. Those would be your database backend. It would deploy a MySQL Galera cluster for you, a MongoDB cluster with MongoDB replication, and a bunch of other services that were needed, such as Memcached, for example, or if you're familiar with Django, you probably know Celery. Celery is this asynchronous task processing queue. It needs a backend that can be either RabbitMQ or Redis, and it would deploy that for you as well. So it will give you that backend. And then you could have as many front-end servers as you liked, because these front-end servers were running effectively Django and a WSGI server and a web server, and they were completely stateless. So there was no user data that was stored on them. The way that you would deploy the front end would be you spin up one VM, you run the Ansible playbooks against it, you shut it down, you take a snapshot, and then you redeploy as many of those instances as you liked. If there was, then you might refresh these snapshots perhaps once a month, or something like that, or whenever there was a new point release or patch release or something, you would also refresh that. And scaling the front end, both in and out, was also really simple, because what you could do is you could spin VMs up and down, you could plug them in and out of a load balancer, fine. So this was all, it was neat, it was cool, it was useful, but unfortunately, over time, as you could do more things with it, as it grew more features and more capabilities, it also became progressively more complicated to use and maintain and somewhat difficult to contribute to. So again, as with the MongoDB content store block store bit, people desired simplification. How do we simplify? We use containers, right? Containers make everything simpler, always, right? Containers simplify everything. So what happened was a project, initially a third-party project, emerged to run OpenEdX in Docker containers. That project went through a few names, but now it's called Tutor. And of course, it was really simple to fire up an OpenEdX platform with Tutor initially. But just as with the story of Ansible and Puppet, it was simpler because it could do less. You could have, it was very simple to basically, you know, fire up a general purpose shrink-wrapped out-of-the-box OpenEdX environment, but when it came to actually making some of those modifications that the Ansible playbooks and roles had absolutely exposed, well, that wasn't so simple anymore. And in fact, as soon as it approached something like feature parity, it was, of course, every bit as complex as the Ansible playbooks. And, this is interesting, what Tutor actually does is it generates Docker Compose definitions and Kubernetes manifests and Docker files for you. So, it is one more lap around the configuration complexity clock. It's code that generates more code in a DSL. Or arguably 3 different DSLs in that case. But what this also illustrates, what the experience with Tutor also illustrates is another very typical problem in complexity management, which is inadvertently, I want to underline, inadvertently making complexity someone else's problem. Let me explain what I mean to this. In Tutor, the lead author maintains a policy, arguably a very, very sane policy, that the project will only accept new features if it benefits a large proportion of Tutor users. That is, accepting features into Tutor core. So even if you have come up with a new feature, you've written the implementation, you're sending a pull request, the author will still say, well, I still want to evaluate, is this actually useful to a large number or a significant proportion, he doesn't say the majority, but a significant proportion of our user base. Otherwise, it doesn't go into core because for those features, there's a plugin system that allows you to effectively implement any feature you like. Again, sounds eminently reasonable. It's a perfectly fine way to sort of approach things. What the lead developer in this case is trying to do is trying to make the project no more complex than absolutely needed for most users. Perfectly fine idea. But what you end up with, and this is not hypothetical, this is actually happening, is you end up with the core of the project essentially being unfit for purpose without its plugins. So Tutor already today has plugins that are required to run an OpenEdX platform. So they're basically core in all but name. But the complexity of managing all these plugins and making them work together, that ends up in the user's lab. In that case, that would be the OpenEdX platform admin's lab. And in my experience, it's not uncommon to have to run on the order of 10 plugins for an average OpenEdX platform to achieve some degree of feature parity to that which the Ansible playbooks offered 4 years ago. So that leads us to our next takeaway, which is pushing complexity downstream does not reduce it. It just makes it someone else's problem. Now, of course, if we're developers or contributors, of course, we want things to be simple or simpler for us as well, not only for the people using our stuff. But we should keep in mind that there is a ratio of upstream to downstream, of people actually contributing to the software versus people using it. And that's what? That's 1 to 100, 1 to 1,000? Depends on what kind of project we're looking at. So if you're looking at a very large community-driven project like Kubernetes, Kubernetes has on the order of about 10,000 committers. And by some estimates, the number of Kubernetes clusters in the world is 7 digits, so somewhere between 1 and 9 million. And it's difficult to assess like how many Kubernetes cluster admins per cluster or how many clusters per cluster admin, but it's probably safe to say that the ratio of upstream to downstream for Kubernetes is something like 1 to 1,000. So for every person that's made a commit landed a commit in Kubernetes, there's about 1,000 people using Kubernetes. If you compare that to curl, curl has a committer base of on the order of 1,000, and it clearly has well over 1 billion users. So there the ratio is more like 1 to 1 million. So making things simpler for some number of people, developers, while making them more difficult for orders of magnitude more people, namely the downstream users, that's not a net win. And it's certainly not a reduction in complexity either. If anything, it's a multiplication. So, what do we do? What can we actually do to simplify, to reduce complexity? And if you're still living in your bubble, I really hate to bust it, but the answer is probably nothing. And I do not say this lightly because I do have physics on my side to back me up. You don't know where I'm going with this yet, but you will in a second. So everything that physicists can explain about the universe, like we cannot explain the whole universe, but the stuff that we can explain about the universe, we can explain with 3 theories. Physicists would love them to be just one, but we haven't really achieved that yet. 3 theories to explain everything that we know about the universe. General relativity tells us about mass and energy in space-time and gravity, the latter being one of the 4 fundamental forces of nature. Quantum mechanics and the Standard Model explains the other 3 fundamental forces of nature, electromagnetism, the strong force, the weak force. And that in turn explains structure and the nature of atoms and ultimately chemistry. And then finally we have thermodynamics, which among other things explains heat and work and so forth. And thermodynamics has this famous second law, the second law of thermodynamics, that we can explain in various ways. We can say there is no such thing as a perpetual motion machine, or we can say whenever we transform one kind of energy into another kind of energy, we always lose some of that energy to heat. But we can also express the second law of thermodynamics as the total entropy of a system never decreases. Okay, so the total entropy of a system can never decrease. It can stay the same, it can grow, it could grow at various speeds, but it can never decrease. And what does that mean? What is entropy? Entropy is the degree to which something, a system, and a system can be anywhere from a single particle to the universe, is disorderly. Now, more precisely, entropy is a measure for how many possible configurations a system has, but that's effectively saying the same thing, because the more possible configurations we have in a system, the more probable it is that the system is in one that isn't useful. So isn't orderly, right? So in effect, the second law states that any system can stay just as orderly as it is now, or it can become more disorderly, but it can never again become as orderly as it once was. And the normal state of the world is that things keep getting more and more disorderly. And you're all familiar with hundreds of examples of this. You can mix 2 paints in a bucket, but you can never unmix them. The same goes for coffee and milk, or tea and milk if you're wired that way. You can scramble an egg and cook it, but you can never return it to the prior protein structure. You can open a container of gas in a vacuum chamber and the gas will disperse, but it will never go back into the container. I mean, it might, but the probability is so minute that in fact it won't. Right? So this happens everywhere. And there is a very curious consequence from this, which is that this constant growth in entropy is one of the best explanations that physics has for the unidirectional nature of the passage of time. Okay? Because the fact that time always goes forwards is kind of confusing, because since Minkowski we know that there is no such thing as a separation between space and time. It's this whole four-dimensional thing that we call space-time. But bizarrely enough, motion through space is reversible. Like, we can describe anything that's moving through space as a vector, we can flip the signs of that vector, boom, this thing goes backwards. But time only ever goes forwards. That's very peculiar. It's very strange. We can, both space and time, this is what we know since Einstein, obey the principles of general relativity, for example. They're influenced by mass, right? But motion through time is irreversible. We can never go backwards in time. We can go slower in time or faster in time, as anyone who's seen Interstellar knows, but we can never go backward. So reducing entropy, simplifying things, is just as realistic as traveling backwards in time. It's just not happening. But we can do things to hopefully inadvertently speed up the growth of entropy, and we can do things to hopefully deliberately slow it down. So what are ways to drive entropy, to accelerate entropy in the kind of systems that we typically manage in software systems? Adding features without gating them behind a feature flag. That means that once the feature is rolled out, you have no way to undo it, and any unexpected fallout from your change is not only here to stay, but it continues to accumulate cruft, making the mess harder and harder to fix. Right? Adding features without test cases. Great entropy driver. Adding features without test cases means when something breaks in a later edition, you have no freaking clue what actually broke. Adding features without documentation means you have no record of how the system is even expected to behave, so you don't even have a definition of the system being orderly or disorderly. Premature refactoring, so refactoring without first achieving feature break. Who's heard of that, right? Like we're refactoring this bit of functionality. Oh, like this little bit of the functionality, we actually don't need that anymore. We can leave that out of the refactoring. Okay? That is an absolutely surefire way to ensure that you're going to run 2 or more parallel implementation strands for essentially ever, because you can absolutely be damn sure that that one thing that you were absolutely convinced nobody needed broke someone's workflow. And finally, violations of the principle of least astonishment. In other words, the system behaving unintuitively will just screw up everything forever. It's just like, be aware of the principle of least astonishment and follow it. Because if you don't, everything's going to be terrible. So what does that mean for the people responsible for such systems? Many of you probably are responsible for such systems. What's your job? If you are responsible for a system, it's your job to slow the growth of disorder in that system. You will never be able to reduce disorder, and any attempt to do so pits you against a most fundamental law of physics. And laws of physics are a little bit like terrorists. It doesn't make sense to negotiate with them. But you can do your damnedest to slow the growth of entropy in a system that you're responsible for. For example, never land a change without documentation. Always make sure that the documentation update happens simultaneously with change, because docs define how the system is supposed to behave. Always follow the principle of least astonishment. Make sure the system behaves in a way that makes sense. And just to be clear, following rule number 1 is not a free pass for this one. Okay? Yes, if you have a system that behaves unintuitively and that behavior is undocumented, that's 100 times worse than the system behaving unintuitively and the behavior being documented. But it's 100 times better for the system to behave intuitively and be documented. Never merge a feature without a corresponding test case. Always include the test case in the patch that merges the feature. Oh, okay, yeah, so you're adding a new feature. Great, wonderful. We need a unit and we need an integration test for this. It goes into the same pull or merge request. It does not land without it. Never send a feature to production without a feature flag. And for when you decide that a particular part of your system needs refactoring, and that happens, and you think that there are some things that that refactor would touch that you're convinced you actually don't need anymore, what you do is you deprecate that feature, you cut a release, you remove that feature, you cut a release, and then potentially weeks or months later, you start refactoring whatever is left to full feature parity. That's a refactoring. Everything else is just duplication and multiplication. And those are all things that any developer, any sysadmin, any operator can do to stem the growth of entropy in a system. But there is something that's a little bit weird, which is that, and I use the term manager in a really broad sense, right? It can be somebody who's actually appointed to like a lead an organizational unit. It can be an open source project leader, like whichever. But a lot of managers are entropy accelerators. They do exactly the opposite of what they're supposed to do. They speed up the growth of disorder in an organization. So let me know how familiar this sounds. You have an internal Slack channel, okay? And communications in that Slack channel are poor and chaotic and nobody can really follow that. How many of you can think of a manager right now whose probable solution to that problem would be, let's have more channels? Right? And of course, those are then more channels that everybody that previously followed just one channel now has to follow, and that one channel doesn't get retired for another 2 years. Right? And that's not a singular example. This sort of thing happens all the time. And I don't have a good explanation for that, but I posit it has to do with this weird, misguided fetish for this thing that we call leadership, that we seem to believe that in order to be useful, people must lead, they must do, they must direct, right? When in reality, there's at least three productive things that people can do when they collaborate, and one of them is not necessarily better than the others. You can lead, you can follow, you can get out of the way. And I chose to paraphrase that patent quote because the original has more profanity, obviously. But sometimes I wish people who are leaders, whether formal or informal, appointed or not, would more often choose option 2 or 3 out of these, rather than always defaulting to option number 1 and sort of constantly stirring the pot and creating ever more disorder. And I want to mention another thing that people, including but not limited to managers, frequently misunderstand, and that is the KISS principle. Okay? Curiously, we don't seem to agree on this is a tangent, curiously we don't seem to agree on how that acronym actually expands. So some people prefer the keep it simple, comma, stupid exclamation point rendering, as in keep things simple, you idiot. Some people prefer keep it simple and stupid, which I always read as don't try to be complicated, but also don't try to be clever. Some people sidestep the stupid issue and they just say keep it small and simple. Whichever, we appear to agree that we want to keep things simple and we want to keep them either stupid or small. But however we expand this acronym there is one bit that's important. It is the KISS principle, not the MISS principle. It's about keeping things simple, not about making things simple. And as such, the principle as such is quite aptly named because it does remind us that the important bit is to keep things simple while you can, precisely because it's impossible to make things simpler later on. So yeah, try to keep things simple because you're never going to be able to make them simple. So to wrap this up, keep in mind that new systems, new open source projects, new configuration management facilities, new this, new that, new the other thing, is often simpler than something that's already there, simply because it can do less than the stuff that's already there. You won't be able to escape the configuration complexity clock. Don't attempt to. But be aware of it. Understand that those things that you're making to your configuration systems, those are not a linear path. They are on a circular path. You will end up at 12 o'clock again at some point. Complexity does not recede. Abstraction, automation, and encapsulation do not make it recede either. Pushing complexity downstream does not reduce it. It might be less of your problem, but it's a lot more of a problem if you do this. If we're talking about a person who is a leader of any kind, formal or informal, appointed or not, their job is to slow the growth of disorder in the bit of the system that they're responsible for. And you want to keep in mind to keep things simple because you cannot make them simple. So, quit simplifying. That's my talk. Thank you.
I'm just going to set up while you make questions.
Okay. All right.
Thank you so much for joining us. We're delighted to have you.
Grab me for questions outside. All right?
tenacious people in the whole of the DevOps sphere. He has been working for many years to be able to create something that is fascinating for himself and for everybody else as part of it.
Well said.
He continues to try and make great stuff. Lambdas are officially here at MGMT, which is what he's going to show today, and I'm going to pass it over to him.
Thank you so much. Hi, everyone. So if you haven't, who's seen one of my talks before? Anyone? Who has not seen a talk? Okay. Who has not seen a talk and has no idea about MGMT? All right, so you're going to be slightly out of luck because I'm going to go pretty fast. So I give lots of talks, or I used to give a lot of talks. I'm trying to tone it down. And so there's some concepts in MGMT I'm not really going to go over too much. I'm going to kind of skim over for time because most of you have done your homework and I've been around. There's a lot of stuff online. So if you're a bit confused and you're one of those people, I do apologize. I will try and answer as many questions at the end as you want. And some of the stuff, it'll be a little bit hand-wavy. Is that okay? I can't do much better. So yeah, I have this project called MGMT. I'm going to be sitting down because I like to type, but don't worry, I'm still here. You can see me. We're doing real work now. Like, this has kind of been a fault of mine because I've been working on this for a long time, and I keep getting interrupted by having to work for like big companies to make money because food is expensive, and I like French butter and whatever. But it's been my fault for not really having something production ready. And I don't mean like hackable production ready. I mean really usable that delivers real value. And it's not enough for me to deliver real value. I want to deliver real value which is better than something else that exists. Like, I don't want to build Puppet. Like, I could already build Puppet. I want to build something that's better than Puppet. And only when it's better, then I think it actually counts. Is that fair? So I'm not going to show you the silly stuff. Who's read my blog? Just raise your hand. If you haven't read my blog, just raise your hand so I seem really popular. Excellent, everyone. And honestly, I go over this, year after year. Are we really honestly happy with the state of automation tools, of Ansible, of Kubernetes, of everything? Like, are we happy? Why isn't this solved? I know Adam's not happy. I'm not using Adam's tool, but I really fucking respect that he's building something because I love seeing different things. And even all of the different tools, whether it's Adam's tool, whether it's Q, I always get some value by seeing something different. And I steal as many ideas as I can to put into MGMT. So I'm not really happy with the state of things. This is my Nope guy, you can see. Yeah. And you've all seen this. I don't really like making slides. I don't have a VC to make pretty templates. So a long time ago, I started with this project called MGMT. This is what I made for you, brand new. I don't know if you can read that. You like that? I'm not from the meme world, but I tried my best. Did I get it right? All right. So previously, and this is real, last year, I promised that I would not give a talk today if lambdas were not ready. And long story short, I want to have a very safe language. And the reason I want a safe language to declare everything is because if you have something that is managing a whole bunch of data centers, a whole bunch of data, if something goes wrong and you have an off by one error, you are going to nuke a data center. Like if US East 1 or whatever the famous Amazon zone goes down, this is a really big problem. This is not okay. So we need to be able to type check things. We need to be safe. Random for loops that are unsafe in traditional imperative languages are not acceptable. And so I realized fairly early on that I needed lambda functions. This is so you can do things like iter.map. You know when you have a list, an array or something, and you iterate and apply a function to each thing? Yes? Who's no? Who knows? No idea what I'm talking about. Don't be shy. You really don't have to be shy, and you're going to see anyways, so it's a win-win. This is a very safe way to do iteration, and we'll see why. And it was super hard for me to implement in the language. And to be honest, I wasn't able to do it alone. I have a brilliant friend who's a super genius, and he just helped me with the hard compiler parts because I'm not a good programmer, and I'm even worse of a compiler engineer. So I think I'm good at the design and the architecture. And hopefully all of you can help bring your smarts and some of my design and your ideas, and we'll make something that makes the Kubernetes people scared. Just kidding, I'm not trying to hurt Kubernetes. So some background really quickly, there's the engine, the resources, and the language. It runs in parallel, it's event-driven, it does distributed system stuff, all this usual stuff. We have like a whole bunch of resources now. It's kind of crazy. These ones with the stars, if you can see over there, they're a little bit magical, and we're going to talk about some of them today because they're a collection of resources that all work together. And for type reasons and other reasons, that's kind of super exciting. I got this quote, must be 20 plus years ago, early programming days. This is really kind of one of my guiding principles. We want to have a language that, put another way, MCL, the language that I've built, that you're going to see today, it's optimizing for glue code. MCL is the glue code of your infrastructure, and I'm optimizing for that. That should be super easy, super safe for you to write stuff, to reconfigure your infrastructure. A beautiful example that I forget someone had mentioned to me, and I realized this is the point, but they expressed it so clearly. For consultants, they have some base stack, and it's a bunch of Terraform or whatever it is, and they kind of have that initial stack, and they copy paste, rename some stuff for client 1, 2, 3 with constant tweaks, right? Who's done that? It sounds like it's pretty common, right? And so here's the thing. If we make that glue language so efficient, so powerful, so much power with few lines of code, you'll be easy to understand, and it'll be easy to just edit a few things for each customer, and it won't be as much work to build bespoke infrastructure tools for each separate customer. Is that a good idea? Are you all asleep because it's the end of the day? All right, you want to see some stuff? Do you want to see some live demos? I'm going to need a little bit more enthusiasm, or you're not seeing a single demo. Thank you, thank you. I worked my butt off for these demos. So yeah, we want to see a quick demo. What? Yeah, so just really quickly, I don't need this folder. I have over here, I built MGMT before. It's all built. It's pretty easy. The kind of simple example that you've seen before, whoops, 0.mcl, is if I run MGMT on the left, oops, not like that. Oops. Just bad at typing. There we go. If you run MGMT on the left, you have a simple thing. I've shown this 100 times, but it creates a file. You've said statically. But MGMT is monitoring the state. So if you remove the file and cat the file, it comes right back. And as everyone's sort of seen, if you remove the file and cat the file, is that big enough for everyone to see? Yeah? Good. It's really, really fast, right? So watch-n 0.1, and it just, it's always just waking up on my left here, and until you kill it, and then obviously. Yep, no, it didn't die. I just killed it on the left. Felix is like, I found a bug. No, sorry, you didn't. He's been waiting the whole day. Like, I knew there was a bug. The bugs are much more subtle, Felix. Come on. And so that's just to show you the code to that. That's just really looks like a simple resource, right? It's a static resource. That's what it does. The more interesting examples, which again I've shown before, I'll actually just show this on this side. I'm gonna, oops, oh my god, I can't type. See if this one will work. I have a bug in this demo, but we'll see. If I just open up this code, oops. Honestly, I'm so bad at typing when there's people around. So this code, if you can see it, is just no syntax highlighting because I don't have a language server or any of that cool stuff. But I have these functions, so datetime.now. And it's not a single value the way it is in an imperative programming language. It's not about when you call it. When you call it, when you put it in the code, it's actually a stream of values. So I can't really point with my finger, but if you look here, when this value updates, this expression evaluates and then re-updates. Then that means this variable gets updated. And when this gets updated, the thing that consumes it. And so I have basically the current date, some math, the system load, again, a real thing from the Linux kernel, and a simple function I built called a VU meter. And all of these are just taking a bunch of strings and gluing them together into a file. Excuse me. And if we, there we go. So MGMT is, oh, I need to probably make this directory, or it's not going to work. There we go. In my code, it doesn't say to make the directory, but if you see, I have this file. And just to show you what's really happening, I can't type again. I'm just going to cat this file so you can see in real time. You can see the file keeps changing because the streams of values update and it pushes into the file. And if I clap, you can see the VO meter actually goes up because it's sampling my microphone in real time. It's just an input stream. And if you look at what's actually happening back on the slides, so this is what we actually do is we take that code and the compiler builds what we call a function graph, not a resource graph. So just the simple code you see here, printf, some string, and then this is just a function that returns the value 42. You have that function call here. It points to this graph. You have the string, the format string, points to this node, and the values propagate through this DAG, this directed acyclic graph. Same thing for here. That's a super simple line of code. A very medium program might look like this. And I mean, honestly, very, very small. Even slightly bigger programs look like this. And the real programs that we're building have these huge graphs. And it kind of wastes a lot of memory if you think about it. But on the flip side, one, memory is cheap, and two, we can now efficiently move data through these graphs. We never have to reevaluate things. And I'm going to tell you some more cool stuff about that. Now, here's the thing that kind of sucks. Whenever we have a lambda, if we didn't have lambdas, the shape of these graphs at compile time would be 100% static. But I want my life to be harder, so what actually happens when we spawn a lambda, we actually change the shape of the graph in real time, compute some stuff, and then close it back down. It's kind of cool. You want to see that? Yes. For everyone else that didn't want to see that, do you want to see that? Yes. Thank you, thank you. Okay, so anyway, so we're going to kill this example. Don't worry, Felix, it didn't crash. I love hecklers. I can heckle back. And I've got the microphone and fireballs. Okay, so which example am I going to show you? I'm going to show you this one. So this is lambdas. So I just have some system packages at the top that are built into MGMT. And then I have this math.mat mod datetime.to. This just makes it so this Boolean here on the left, mod, flips from true to false to true to false every second. And then right here we're storing a function right here. So it's fn the type has a type function of what? What's the type of the function? Anyone? Function signature? I told you this is a hardcore talk. Come on. What's the type though? Func of? Is it int to int? So it's something to int. So, so the interesting thing actually, so the function as it's defined here does not have a precise type. It's just a func of something to something. We know that len returns an integer, so it's a something to int. And then this right here, we have these lists of strings. Those lists of strings, which are going to be this string or this string, so we're going to swap the two lists back and forth, go into in1, which goes into this iter.map function. And that is when we precisely turn the func of some input type into a func that takes a list of inputs. Or, excuse me, the map takes a list of strings, and the func itself is going to take a string, because that map function, that lambda gets called on each element of the string. Okay? I explained that really badly, but it was my first time. And then all of that we're just going to print out. Make sense? Okay, so let's run that. Don't remember what the name of the file where I stored this code is. It's all online, so you can definitely just work along with me. And lambdas. I just write down the file names because I don't remember. Okay, map, iterator, simple. So I'm running MGMT, and the file is right here. So there's actually no file. So I just did a print. And remember, so if we look at our code over here, we have these ABC or ABBCC. So there's the length is 1, 2, 3, and then we have 6, 5, 4. And if you see here, and we're switching the list. We're saying run the iterator on this list. A second goes by, run on that list. And so you'll see it just hops back and forth. 1, 2, 3, 6, 5, 4. This is abstract. This is not a real world use case. Just to show that it really works. Cool? Yes. What are you missing? You want to see the function graphs? Yes. You're like, well, what are you getting yourself into? So that is stage graph is so. Nope. Stage graph is. So remember how I told you that the graphs change shape? So I'm going to show it just, I'm not going to zoom in just right away because it's not that interesting. But so initially you have nothing, right? And then we start up, we compile the program, and we generate a single graph, which looks kind of stupid. This is not a fake graph. This is the actual graph for the code you just saw. Cool? So you know exactly. And all these random constants, like these should actually be labeled and have better strings, but you know, we're being lazy. So it's not as descriptive as it could be. So we have that graph. Oops. I need to do start.jpg. It'll be a lot nicer. Nope. PNG, I think. Yeah, debugging on the fly. So there's our first graph. And then you can see here, now GraphViz shuffles things around a little bit. So you really have to think about the structure. In fact, I really wanted to make it a real animation, but I didn't do it. So if you want to take a list of graphs and animate them for me, that'd be super cool. And you can see now it starts expanding out. I'm going to go through it first, then we'll look at it a little bit closer. It's expanding out. It's expanding out. It's getting big. Oh my goodness, it's getting so big. And then it's going to shrink back down into nothingness, like our universe. So for the physics people out there. So this is all happening in real time, right? Like when this is running, oops, wherever it's running, that goes over there. Where'd my window go? I lost MGMT. No, it's not there. It's taken over. It's the botnet. The AI and MGMT have gone over. I guess I killed it, but yeah. So that's constantly happening in real time because the reason is because we cannot determine at compile time the number of elements in the list. So what we actually have to do is we have to actually receive the list. We pause the graph. We very quickly spawn a whole bunch of mini graphs that are all connected to process each element in that list. We do that, and if they're not needed, we shut it down. If it stays the same, we don't need to change the graph shape. And this is happening, you know, thousands of times per second, I guess. I don't know. I'm just making up numbers. Is that cool?
It's cool.
You want to see? I'll just show you really quickly here. Over in the middle, just somewhere in the middle at the kind of peak of the graph, you can actually see here, we have, you know, these map elements, 0, 1, 2, and you can see this is the weird thing they spawn from. And then over here, this 0 here is because it's the 0th argument to the len function. We run the len function 3 times. We get the output. The func value comes in here, and this map is what spawned the whole thing. And so this whole kind of piece on the side gets spawned out and then collapsed back down. Cool? Yeah, it's nerdy. See this dotted line thing here, by the way? This is a visualization related to some weird data structure magic we do. And I was talking with my friend Sam, who implemented this dotted line, because we didn't have that. It was just floating before. And I was like, yeah, it would be really useful if we could do that, but that's like too impossibly hard. And he was like, oh. And literally 20 minutes later, he had a patch, which like, you know, not nice Golang. He's a Haskell programmer. He's not a Golang guy. But man, just genius. Like something for me that is impossibly hard is a 20-minute thing for him. And here's why you should work with other people. It's super beautiful us working together because stuff that he doesn't understand at all, like it's super simple to me. And when we're pair programming together, sometimes I'll be like, oh yeah, no, that's wrong. And he's like, how do you know it's wrong? Like you have no reason to believe that's wrong. And then 20 minutes later, we go through and he's like, ah, you were right about that thing that's wrong. It's uncanny. So find someone who's different from you to work with. You'll be able to build more interesting things that way. Okay. Any quick 1-second questions, or do you want to see something even cooler? What about the rest of you? All right. So yeah, big graphs. So what can MGMT build? So I have actually brought here a standalone computer. Uh-oh, the screws are falling out. Apparently not a very good one. So it's kind of like a fat Raspberry Pi, but it's an x86 machine. It has an Ethernet port, which is plugged directly into my laptop. And it has a little HDMI port, which I am going to plug into my laptop. And the cool thing about that, let me just want to get set up here. Oh my God. Where is that code? There it is. Okay, so I'm going to start that up. And then over here, I'm going to show you. something like this. Yeah, that works. So that is just going to show the output of the screen. Okay, so it's not on, so at the moment it's just nonsense. And what I'm going to do, just in case someone is brave, instead of doing this provisioning demo on this computer that I have, I want to know, does anyone have a laptop they'd like to lend me? I'm going to install a brand new OS on it, completely erasing all of your data live in 20 minutes in front of you. Anybody? Do you want a brand new distro on your laptop? No? Fedora. Yeah. Arch? Anyone? No, I'm just kidding. Okay, I mean, I could do this. It would be a little bit risky because maybe have some weird firmware bug that I haven't hit. But all right, so I was right to bring a laptop. So this is what I'm actually going to do. This is the code. So obviously there's core resources and functions built into MGMT. And those are usable in all sorts of scenarios. And what I did is I took a few of those and I glued them together with MCL code. And the entire lines of code, not including this stuff here, is like max like 500 lines of code. So I've built a provisioning tool that all is one single binary. And here's what I'm going to show you. So we have this modules provisioner. That's the code, the 500 lines. And so you come along, you import that. And the provisioner package, the string here, basically magically the last token in the path becomes a variable here. And so it has a few things that it provides, this package. One of them is base. And base just takes a struct with a few input fields, right? So this is basically ETH0 for my laptop's Ethernet port. I just choose what network. There's defaults if you don't want to pick these numbers, but it makes sense, right? Yeah? And there's a scratch directory and so on. So import that. The second thing we do is we define a repo. So what distro? Fedora, the architecture, which kind of flavor, which version. This is 38, and where the actual packages come from. Now, I actually did an rsync before because I don't want you to wait for that. But I have a new version of this demo that doesn't need to rsync. It'll just speculatively pull down the packages and cache them the first time they're used. But that's not published yet. So at least for now, makes sense? And then lastly, you put something like this. You define all of the hosts that you want to provision. You can have it just do anything, but it's nicer to have say, only do these MAC addresses so you don't accidentally plug in a machine and then erase it. So I just put the MAC address, what IP I want that machine to have. In this case, I have a root password. If anyone wants to decrypt that, you can. The host name. And I have a flag provision true, right? You can also add a few packages. I actually added cowsay to the demo version, but I didn't test that. So let's hope cowsay works. And then lastly, when you do this include, again, you have a name here and a struct with all this config as hostname. Hostname gives you a handle to all of this code that's running. And then you can do something like $hostname1. It's the same hostname right there, .provision. So there's magic variables or functions that get kind of exported from this class inclusion that are live variables, right? So there's actually a small bug that I haven't fixed, but basically it should probably work. When this becomes true, it will just in real time print out that message. But instead of printing out a message, you could do something like deploy cluster 2, deploy cluster 3, or magic. Is that okay? Let's start this running before I talk too much. Right, so that's over here. I just have to plug in the machine, and then this should work. Let's see what happens. And over here, I'm just going to, I made some files that change state in the directory. No, that's not the issue. That's a great question. Remind me about that. So I have some state data, some state variables that I just put out to text files just to see what's going on. And so it's trying to start up over Pixie right now. And now you could plug your Ethernet port into a switch and then have multiple computers. But I didn't want to bring a switch, and you can always just plug directly. And let's see if this starts over Pixie boot in a second. And yeah, it's always nerve-wracking doing these kind of demos. This has worked lots of times, but might have to debug something on the fly. Why is it not going? Let's see if I messed with my network. No, should be okay. Let's just see what happens.
So this MAC
MAC address that you showed, you configured this into your little computer, yeah?
Yeah, I mean, there's a MAC address that comes with this, any computer that has a MAC address. Why aren't you working? That's super embarrassing. Let's see what happens if he's going to time out. Weird. Oh, I know what's wrong. I know what's wrong. What's wrong is I rebooted my computer, and the one part of MGMT which I didn't do yet is I didn't set up the firewall. So allow me to do that. I don't have a firewall resource yet. Modules. Provisioner. Okay, yeah. So I have to actually open up my firewall manually because I didn't build a resource for MGMT yet. So I think that's the issue. Okay, yeah, that was the issue. Nice. And this is my kind of philosophy. If you know what you're doing, you should be able to live work through that. And one other little thing, so I actually run this command on the build so that the binary itself gets root access to a few things. So if I asked that net question, the reason it was erroring is because since this device is offline, there's no power, so it thinks it's disconnected. So it errors setting the local IP address on my machine. And so that's what you were seeing. Here's an interesting thing. My type unification algorithm is super slow. It only happens at compile time. And it happens twice for a weird reason, which we'll get rid of. But it kind of sucks because you have to wait like 20 seconds for this to run the first time. And that's what we're sitting through right now. Yeah, so now it's going to provision. So I did this talk in the Golang dev room, and I realized it's kind of a little bit boring watching machines provision. But I have to say, like, for me, it's kind of, is the word cathartic? I'm not so good at English. Because as a sysadmin, I've spent like years of my life sitting and watching machines provision. I don't know if you've all done this, like watching DNF do its thing, like DNF updates, syst updates, all this stuff. And it's kind of like, I don't know, it never felt bad to me. So now you're suckered into this too. Like it or hate it. Yeah. Yeah. And so, basically one of my next few projects is I have to actually write efficient type unification code because I'm doing all sorts of crazy hacks. It used to be much worse, and then I made it. My goal is always to make it just good enough because if I do all the work by myself, then companies won't pay. So basically I'm going to plug in this computer now. Should be starting up in a second. Okay, and so now hopefully everything should work. Okay. Yeah, so basically MGMT's resources just set up a THCP server, a TFTP server, DHCP server, and so here you can see it happening. Look right here. You actually can see the real live happenings. So right now it automatically pulled up this grub screen in kickstart mode. If I push the keyboard, which I don't have, I could change it to manual and do some stuff, but it's automatically doing that. And the really cool thing, you can see all the different things. You can see the DHCP request coming in right here. You can see which exact files it's trying to look for, because this is a programmatic TFTP and DHCP server that's in pure Golang in my project. So it's very useful if you have some weird piece of hardware that you don't know what files it's requesting. In fact, I found this machine requests files that I've never seen in any documentation anywhere. So some firmware engineer was like, oh, let's ask for this file too. And it's okay, because if it 404s, it moves on in the search path to the next one. So over here, so it did a bunch of EFI stuff here. What was this file? VM Linux and initrd. What are those? Felix says kernel stuff. Yeah, so you have to have those. It's basically initial kernel that's going to boot up to run this installer. And what it's going to do, it's going to download, if I caught it, right here. It's going to download this file right here. This file is a file that we template. We don't have to create a physical file. It's just in memory, although we can put it on disk, which is a template of the setup that we want to actually do. So which packages to install, how to partition the disk. And again, all of that is built into MGMT. If you look here, actually I don't have it here, but there's another field you can add to this struct part or partition or something, and you can choose which partitioning style you want, if you want BTRFS or X4 or XFS or whatever, and you can choose all these different settings to customize things. And so it's starting up. I can actually zoom in here, I think. Nope. Yep. And go like this. MPV hacks. And I can do this. And this. Oops, wrong way. And so if you just want to see what's happening. So basically Anaconda started. It took this kickstart file. It's checking the storage, doing something. And if you want to get some more information about what's going on, in parallel, I can cheat. I have a hack. Do you want to see a hack? Yeah. Yes. So I just have a wget here, which I have carefully crafted because I know how the magic works. Can you all see that? Yeah. And so this is just the magic path, which is there. And if I run it, I'll just go over here, just so you can see it actually works. Press enter, boom, you see the file get requested. This is the kickstart file, which is what the machine automatically downloaded. And it just generated some stuff. The networking, this is a template in MCL, so very simple. The repositories, obviously it's going off of my local machine. You're pointing, something cool. Cowsay, yeah. Uh-oh. Oh no, I forgot to put the new line. So this is gonna break. Uh-oh. Should I restart it quickly to show you?
No, let's watch it back.
No, it's gonna break when it tries to install the packages. Maybe, I don't know. I knew I should have tested it before I added Cowsay. Does it skip? Jeez, let's see. Oh well.
I mean, you're not going to be able to make the Cowsay anymore.
Yeah, it won't Cowsay.
Otherwise, everything's cool.
Oh yeah, no, I definitely need to skip it. Jeez.
Can you show the buff?
Yeah, I'll show the.
Oh no, it didn't skip it. Right.
Yeah, it's gonna.
It's waiting for you to type yes on a keyboard you don't have.
I know, I know. Someone have a keyboard? Someone have a USB keyboard? Cowsay. Yeah, see, that's why you test your. I was just like, I'm gonna add Cowsay. It's gonna be fun. I didn't think about that. Okay, so we're gonna kill this.
You are required in this array to put your own new lines.
It's a templating bug because I never tested installing more than one package. Yeah. Whoops. So that's stupid.
Have you seen the template?
Yeah, I'm gonna show you the template. We're gonna, oops, kill that. I just got rid of Cowsay. That's super embarrassing. Oh well. Anyways, so this is the, this is what we do. We test, and while that's starting up, I'm going to just wait. While that starts up and then starts provisioning, I can tell you about a few other things. So I actually took some screenshots. This is just, working on a random computer. It works on old crummy computers like this one. And downloads the packages, does this thing. Someone asked a question about this error that they saw in the network. So the cool thing is it's trying to set the IP address of the device, but you can't set an IP address if a device is down. And so what actually happens is it tries and it fails because it was like, hey, you asked me to set this IP address. It doesn't know if I unplugged the cable. And then what actually happens is when this machine powers on, that device comes back online, and MGMT notices the state has changed of the network. And says, oh, something has changed. Let's try again. And it does that. And you can configure with meta parameters if it retries and not, and so on. It uses Netlink. Yep. Exactly. So we wrap any kind of events we can, depending on what we're looking at. Yeah, pretty straightforward. So, and while we're waiting, we can actually go here and just check that. Oops, I'm glad I checked. Oh yeah, the server's not up yet. We're gonna check that kickstart file. If you want. If you're bored, you don't want to stick around, you definitely can leave. But yeah. So basically what I'm doing, and I'll talk a little bit forward in my talk, some really cool things about FRP languages that I wanted to tell you about. You can actually instrument your programs in real time. Like you can take a variable, because it's an event stream, and you can just pull it out and look at it, and you can see how the variables are changing as your program is running. It's kind of cool. You can do that with fancy GDB hacks with other compilers, but this is even easier. You could even graph their states over time and so on. Okay, this must be running. That looks okay. Okay, let's plug this back in. So you can see that. There's this one. You can see. Oh, you can see I have a TFTP client, and if you want to see what actually gets pulled down, it's actually just, again, another template of exactly what you expect. Okay, and so then here's our machine. It's downloading the stuff again, and I think this time it's going to for sure work. We'll see. Yeah, so yeah, just a few things while that's provisioning. So yeah, you can do that. It's very fun to debug. So at the moment, I have an rsync. Basically, I exec the rsync to pull down the mirror, and it knows how long to cache it for and when to recheck and so on. That's all automatic, but you have to pull down the whole mirror, which is like 100 gigs or something silly. And that's a temporary hack. And what I realized I can do is I can actually have an HTTP resource for just the file, but that gets it from the mirror. So what will actually happen is, yeah, you want to see some more code? Yeah, this is actually very cool. Provisioning. So yeah, just this is the tree of the code. Oh, that's all the firmware stuff. That's just blobs. But there's the files directory, and there's just those templates. Very simple. Not too unlike Puppet, but also kind of different. We have the main.mcl. This is all of the code that's with lines and comments and like work in progress stuff. 445 lines of code, like a whole provisioning tool. And again, the goal is not for me to sell you and convince you to use a provisioning tool. That might be one tool you want to build. But the other thing is you can take that, customize it, build entirely new tools that I have not thought about. You could build a very simple Nomad container orchestrator clone in MCL. And I'm really looking to find out what the next thing I should build is. I'm going to be putting this in the hands of people to try it out with real provisioning workloads. Like it doesn't support, say, anything but Fedora at the moment, because I just did the if this, get the mirror from these locations. But maybe you're a Debian shop and you want to try this out with Debian and so on. And the really cool thing, if we look at the HTTP resources here, so we have basically in MCL, there's a bit of mess here because of comment and debugging and hacking. We have the HTTP server. This is kind of like a file, the file resource in Puppet or whatever. Same idea, right? Except we have one that's called server. And we also have other resources called file. And let's look at another one. Another one here, that's just a string. Another one here. And what actually happens at compile time, at runtime, all of the relevant HTTP resources get grouped together, and it actually builds basically a custom HTTP server in real time. And you can add and remove pieces. You can add files to it and from it. And lastly, the really cool part is we also have an HTTP flag resource. And what this is instead of serving a file on this path, it actually, when you send it a request, an HTTP post, to this special URL, the HTTP server actually takes your incoming request and turns it into data that MCL can see. And that's what happens at the very end of provisioning. We run a post, like in the kickstart, which is a wget that pings this flag, and the flag says, oh, something has happened, and it changes the machine from not provisioned to provisioned, and it re-executes and does all this magic. Is that very complicated? It's a little complicated to explain, but once you have your hands on and you're playing with it, it's actually very easy to understand. At least I find it's very easy to understand. So now, we're back to where we were before. If you can see, it's actually downloading. Look at all the stuff going by. It's downloading all the packages that it needs to install the Fedora machine. I noticed it requests all sorts of weird, sketchy files. Like, if I was like, hypothetically, a 3-letter US agency that wanted to have like special things happen when magic files were in certain locations, like this would be a great place to hide it. Who's checked what it's actually downloading? Has anyone ever looked what it actually requests? Anyone? I was surprised, one person. I'm not actually implying anything malicious, but like it just surprises me so much. I've been kickstarting for, I don't know how many years, 10, 15 more years, and I never knew that it asked for some weird little things. So it was kind of an interesting learning experience as well. So it's installing all the packages, which you can see. Is that big enough? You get the idea. You can see all the packages going by. And then we'll flip back here. So yeah, so back to that code that I was just talking about, in wherever it went, I've lost it. We can have also a new resource that I plan on writing, an HTTP cache resource, which will have the base prefix of the actual mirror. So it'll actually offer that file into this dynamic HTTP server. And so the very first time that it requests the file, it basically requests, the machine requests the file from my laptop. The laptop will transparently block, request it from the internet. It'll pull it down, relay it on. And then the second time you run this, it'll just already be there. And so if you provision machines, you'll have the exact offline copy of every file you need and nothing more. And some time back, I remember actually trying to get from the Anaconda developers, hey, is there a way I can just find out exactly the minimum set of files that this Anaconda is going to generate? And they're like, yeah, we don't know. It does its thing. But so this is literally a way to instrument your provisioning, capture what you need, and then put that in a minimally kind of perfect offline way for future builds. I care about everything working offline because you should have complete control of everything. And this is the step one in greenfielding a data center that's down. Like if your routers are down, if everything is down, you have no internet, like what do you do, right? This is like if Google goes down, if Amazon goes down, if enough important pieces go offline, they're out of business. They do not have a solution, as far as I know, and I have no insider knowledge here, but they have no solution to actually greenfield or bootstrap a data center or their own infrastructure, because their own infrastructure depends on their own infrastructure, right? Like, this is completely crazy. Does anyone have, do you know companies that are careful about this?
Facebook.
Are they really like 100% good? I don't believe that.
I mean, I sat and watched them turn a data center
Did they?
from scratch.
What if everything goes offline?
Then they're fucked.
Yeah. So like, yeah, so that's the thing.
The cache data's fucked, not because they can't.
It's a hard problem, but I really am coming, and I've taken a long time to build MGMT because I'm going all the way back to first principles, thinking what do I absolutely need to build things the right way? Anyone who set up Cobbler, I set up Cobbler a long time ago, or Red Hat Satellite, or I don't know, whatever provisioning tools, how long did it take you to set up that tool? Ages? If you copy this single binary to your laptop and run it, and then wait 30 seconds for type unification, you have a provisioning tool. Is that better? What? I need an algorithmist. I'm not a good algorithmist. So yeah, that's what's going on there. This is what I think is, this is config management to me. This is, and people say, oh, it's too dynamic, whatever. What's actually happened is we want real-time dynamic things, but we've farmed them off to other tools. We've farmed them into Kubernetes. We've farmed them into all these other sketchy products that you have to glue together. We are just that dynamic piece. But I call it config management because that's what I truly believe it should be. But you know, it's naming. It's some people say it's a choreography tool. I'm just going to finish some slides and then we'll watch the provisioning finish. Does that make sense? Future work. Type unification performance I told you about. Remember this whole graphs changing in real time? I have some concurrency bugs. Like if a bunch of things error at the same time, it can, in some small percentage of the time, deadlock, which is fine because it's dying, but it's not good in general. I have some bugs there, and there's some other small things. So if you're good at Golang concurrency, definitely would love your help. My error messages, if you have like a missing comma or like basically early Lex or parser stuff, are really bad. And I won't lie, I have briefly kind of manually bisected my own code, like delete half of it, is the error still there, yes, no, to kind of find out where the typo is, because I don't have good error messages yet. It's fine, but it's not something you want long term. And actually the good thing is I only expect a very small number of people to actually need to write MCL. Only the crème de la crème, you people, will write the MCL. Everyone else will just consume a module. Like, I had this problem with Puppet. How many HTTP modules are there for Puppet? Like 50? 20? There's definitely at least 20. Everyone wrote their own because code was not reusable. I have worked so hard on the module system. Someone will be able to write an MCL module, and that's going to be good for 99% of everyone. And if you're that 1%, it's probably because you're working at some weird FANG company that has some ugly Cloudflare hack. I mean, some ugly hack that you're doing something weird and special. So I think that's going to make the whole, like, you don't have to understand MCL as well as, you know, you would have needed to understand Puppet. Make sense? We want to build a whole bunch of stock tools just to prove out MGMT. So maybe a container scheduler could be one, a tool that sets up a distributed, sets up and continuously manages, that's key, day 2. A distributed Ceph file system, that's one of my short list. If you have any ideas of what you know, we should build, I need suggestions. And actually I had this realization like maybe a few weeks ago. So we have MCL, which is constantly generating, MCL is a function graph which generates a stream of resource graphs. And those resource graphs swap from A to B to C to D very, very quickly. And I actually came up with a crazy way in my head to actually do it even more quickly. But like, it's kind of a little bit tricky, but algorithmically it would work. So they're already pretty fast, but I think they could be like millisecond, like a few, like very, very, very fast. So if you want like a crazy hard graph problem, come see me. Same thing, I'm provisioning on x86-64. If anyone knows anybody that works at ARM64 kind of chip company that wants to, I know I'm thinking of Dave, I'm just teasing him. If anyone wants to send me a demo board so I can try this on other architectures, other things, please. I have Raspberry Pis, so I'm doing that probably next. But you know, if you have some cool stuff, this is, you know, needs help. This is still installing. It's just finishing the configuring step. I don't really know about business or money or all this stuff. I'm just some weird nerd. But I got to make this serious, right? Either I go back and work for Amazon or some big company like to make some money, or I keep working on this. And so I really need a way to make some money because I don't want to have to make a proprietary thing. And do you want a proprietary thing? No. So I need you to be really serious, real talk here. I have a little sign-up form for this new MGMT partner program I'm starting. Find your companies, convince them to sign up. I have tiers as low as 100 euros per year for individuals, 1,000 to 5,000 euros per year for small companies, medium companies, things like that. And what I want you to do is such a small amount of money. People are saying, no, you got to ask for a lot of money. I don't want to ask for a lot of money. I want it to be so easy that if you have a budget struggle with this, it means you're not really serious about investing in this technology. And I want you to invest that small amount of money in me, in this small team that I'm trying to assemble. And every month or two, I'm going to send you a little newsletter, let you know what's going on, and I'm going to send you some prototypes, the provisioning tool, some other stuff. I'm going to listen to what you're interested in, and I'm going to try and just have kind of the bare cash just to pay for food. I'm definitely still losing money. Trust me, I can make much more at a big company. But that's not my goal. But this won't work if you don't really commit to signing up. So I have a QR code. Oops. Take a photo if you want. And then we're going to go back to provisioning. So hurry up, take your photos. Just a little Google form. It's not great. But please push this. Sign up. This is kind of the make or break. I want to provide real value, but I need to get real funds out of it. Does that sound reasonable? If we do not fund open source software, we are not going to have open source software. Like, we're losing this. And this is why. This is why. This is the moment, at least for me. So, I'll show that again at the end. Yeah. Okay. So this is just about done. It's just in, oh, that didn't work. Did I break? I have another bug actually, but oh, it's running the PostScript, but I think I have another template bug because I added some other hacks. So let's see if this actually works. Yeah, I was just having too much fun hacking last night, and so it runs. I added a sleep here for some fun because I was debugging some stuff, but you can see it's actually all grouped together. But even if it doesn't run it, I can actually cheat. So what it actually does is it runs this command with done equals true. Give it a sec. Yeah. So it runs this command. I just faked it because I still have that templating bug. Whoops. Test your code, folks. And so it actually reruns MGMT. it does some math and figuring out, and it flips those variables from will provision to will not provision, and is provisioned. And you can see that when this machine starts up in a second, it will skip the, you don't want it to reprovision itself forever and ever. Make sense? So the only kind of shitty thing, I always have stupid hardware issues. The timeout, the Pixie timeout is so long. So it's like, come on, like, why don't we have OpenCore or whatever, like fix the firmware problem. This part of the stack needs much smarter people than me. And so, but MGMT is not going to provision it. And then the UI, like in the package tool, is you just have a flag you can set. Do you want to reprovision the machine? Yes, no, and so on. Pretty straightforward. So that'll boot up in a second. And then we can SSH into it. And yeah, this is just Pixie timeout. If you're a large company and have clout with the hardware vendors, like, yeah, all these little things need fixing. But yeah, that just makes your machine take another 15 seconds to start up. Any quick questions while we're waiting for that? Don't be shy.
Can we see the template for the Kickstarter?
Yeah. Go ahead, Dave.
Were you here for Florian's talk just before yours?
I was not.
Okay, because his contention was that everything kind of, you sort of work your way around an abstraction clock, and anything that's simple starts simple because it does less.
Yeah.
And it gets more complicated.
Yes, I saw that end bit. So I have actually strong opinions about simplicity and all these things.
So do you agree with his thesis or disagree? It seems like you're going against it, right?
No, so I don't think this is more complicated. I think that we want to do fancy things, right? We want to have servers that auto-scale so that we don't waste power. There's a lot of real use cases that we need to solve. And this is the simplest way that is possible to solve them, in my opinion. Just to show you, and also you can SSH in because we still have that DHCP server running. So you can run in, the password is password. And there, this is, I don't have a keyboard, this is literally that brand new machine. You can see it shows you the kickstart that got here, the original one. So kickstart takes the original one and then redoes it. And you can say, whoops, I just forgot new lines. When I was joining, I just didn't put new lines. So kind of a simple templating bug. And now we can mess up this machine. What should we do with the machine? Run some sketchy commands. Anyone? Is truth real? Oops. What is it? Bin true. Yeah, thank you. Still working. How about false?
Remove libc.
Where the hell is libc? Don't do this? Oh, oops. Still working. Oh, bash not working. Does anyone have a provisioning tool I can use? But yeah, and I didn't even bring a keyboard. So yeah, so does it work? There's still little polish and small things to do, but if you sign up for this program, I'm going to send you a new version. You find any bug, I'm going to fix it, and try and take this seriously. How much time do I have left, if at all? I think I'm a little bit over, actually. So let's just recap. I love this Arthur Benjamin recapping joke, so I'm just stealing it. So we're still on IRC, although it's kind of quiet. Maybe it's not as cool. So I have a MGMT config channel on Matrix. I don't really know how this works. Joe does, and he's an admin. He's responsible. And Red Hat was hosting our mailing list, but then Red Hat decided to make all mailing lists kind of internal only for admins. So our longtime mailing list that lots of projects were using is dead. So if someone has a mailing list that's stable long-term that wants to let us host, preferably for free, that would be ideal. If anyone knows anyone at Free Desktop, I opened a ticket, said, hey, can I have a mailing list? And they still haven't responded. So if you have some clout there, please let me know. You know how to find me, purpleidea.com, not a big deal. Purple ID on IRC Mastodon. I have Twitter. If you added me on Twitter recently, I'm not doing new stuff. I'm just kind of posting when I have a new blog post, but I'm not really interacting as much there. So if you want to get a back and forth, like ping me on Mastodon or something like that. On Wednesday, so not tomorrow, the day after, I will be here all day doing an MGMT workshop. So you can hands-on, try MGMT, play with stuff, get your laptop provisioned, anything you want. Silly things. I have some stickers here as well. So if you'd like a sticker and you plan to actually use it, please come up at the end and get a sticker. And I'm kind of like trying to figure out what to do. So I am officially looking for a job. Particularly, I'm not sure what role is best. Kind of flexible in terms of a team lead or a junior manager. I've been doing this mentoring program for a long time, and it's been very successful. DevRel stuff, individual contributor stuff, kind of looking all over. Ideally, or remote, ideally Golang, and ideally kind of MGMT. So I'm kind of seeing what works out. So if someone wants to hire me to do a bunch of MGMT stuff for your company, even if it's not 100%, I got to figure this out kind of soon. I have some runway. If I can do the partner program, if that works and I get success. If not, I'll have to refund your money. And you know, I don't know. I'm just a nerd working on stuff that I believe in because I really want us to have good infrastructure. We cannot allow a small number of companies to control the world's computing infrastructure. We have to make this accessible to everyone. And then we're going to start with provisioning, automate things, and move on. So that's my talk. Thank you so much. If anyone has questions, come see me, I think, or just call out some questions. I can stick around. Yeah?
Scream it out.